Welcome to the course that I wish that I had when I was learning to code. You see, as beginners, when you're just learning, trying to understand everything and decide what path you're going to take, it's often tempting to look at jobs boards and see that things like React and TypeScript are really popular, and so you dive in and try to learn those things. But you don't really understand why they exist in the first place, and it limits your learning. So in this course, I'm going to take you on a complete journey from the very beginning, where we are going to look at a completely vanilla JavaScript, HTML, and CSS application. And when I say vanilla, that just means no frameworks whatsoever. And then we're going through a complete progression from the vanilla build to a TypeScript build all the way to a React build. And through this process, you're going to see how it evolves, and you're going to start to understand why we have some of these popular technologies in the first place. This is a highly interactive, project-based course. It's completely free, but I have meticulously planned it out so that we go on that evolution and you really learn some foundational concepts along the way. The game we're building, a Tic Tac Toe game, is nothing particularly special, but it is a great beginner project that will expose all of these different things that we need to learn. And if you don't know anything about TypeScript or React, as I was just talking about, that is completely fine. All you need to know to be successful in this course is the basics of HTML, CSS, and JavaScript. I will explain the rest along the way. So let's take a quick look at what we're going to be building. Like I said, it's a basic tic-tac-toe game, but it's going to have all sorts of really cool features. So as you can see, I have two browser tabs open, and as I play the game, the state is synchronized across those browser tabs. This is possible through localStorage and JavaScript event listeners, and that'll be a really fun part of the project to implement. Additionally, the user has the ability to reset the game, so the moves that they've made so far, or even reset the entire round. The players will have their wins and losses tracked over time, and if you pop open the localStorage tab in the browser DevTools, you'll see that a complete history of all the games played is stored in localStorage. So that can be an interesting way to extend this project if you wanted to take it a little bit further. You could almost build out a leaderboard or something like that. I'm super excited to do this course with you. I'm going to be walking through it step by step so that we don't miss anything. I'm going to go ahead and jump into the PowerPoint here. We're going to talk a little bit more of those specific concepts that we're going to learn and a few prerequisites to the course. All right, let's jump in. We are going from vanilla JavaScript to React, and let's see the prerequisites. Like I said, all you need to be successful here is the basics of HTML, CSS, and JavaScript. You don't need to be advanced here. You can check out my full course. I have courses for basically all three of these on my channel, so I'll link to those. So be up to speed with those technologies. And then what will we learn? On a high level, we're going to learn just how powerful vanilla HTML, CSS, and JavaScript are. There's some really cool features that you can use without any framework that we're going to see, especially as it's paired with the MVC or model view controller architectural pattern. So you're going to see how that plays out. We're also going to figure out why we need frameworks like React and what benefits we get from using TypeScript. So we're going to go through both of those. That'll be really interesting. And then in terms of concepts, we're going to learn things like what is state management, a few VSCode tips and tricks along the way. It's going to be a completely responsive design. We'll be using CSS Grid to do that. And then we'll move on to things like localStorage. We're going to talk about transpiling code with Babel and Webpack when we get to the React section. And then, like I said, benefits of all these technologies. And then finally, we're going to talk about grid layouts, full page modals, event listeners, even event delegation. That's a little bit complex, but you'll see what that does. Popovers, menus, animations, and transitions. There's all sorts of cool stuff that we're going to do. So at this point, I think we've covered everything. So it is time to jump into the vanilla build. This is going to be the bulk of this project, the longest section, and we're going to go through some really awesome concepts. So buckle up, get yourself a coffee or 10, and let's get started. all of the code that I'm writing here is going to be in this Tic Tac Toe subscriber refactor repository that is on my GitHub, and I'll drop that in the video description. But what I'm going to do is actually create a new folder, live vanilla build, and this is where we're going to be working out of for this video. I'll basically be recreating everything here in the vanilla refactor, and I may reference this a little bit here and there just so that we're not getting too far off from that code. So just as a forewarning, the live build that we're going to do might have like some tiny little differences between the final state that you see on GitHub, but overall it will go in the same exact direction. All right, so what is the first thing that we do when we start a new project? Well, we're doing a front-end project here, so the natural thing to do is create an index.html document. But before that, I want to do some administrative stuff with Visual Studio Code. I'm going to assume that you are using Visual Studio Code, and the reason is because it's an awesome editor and most people use it. So the first thing you'll need to do is go over to extensions and open up a live server. This is an extension that basically allows you to view HTML documents in your browser on port 5500 is the default. So you can see that's already running. Let me go ahead and click close. So that'll dispose that. Let me get these windows figured out here. Okay, so if you see I reload this, it won't reload. Let's go ahead and close that. And then if you go down, get rid of my bar down there. If you click go live, once this live server is installed with Visual Studio, it will open up port 5500. So let's go to this and it'll show you just the directories you're working with. So it's just replicating this right here. And what we're going to do is click on the live vanilla build. Right now it's empty, so it's not going to show anything. But what we're going to do is create an index.html file. So we'll say index.html, and then we'll use VSCode's built-in Emmet snippets to type HTML, and then we'll click HTML5 to get some boilerplate built out for us. Now the second thing that I'm going to show you is format on save, and this should be really part of your dev workflow no matter where you go, because it's just useful. So as you can see, this boilerplate is not indented correctly. And when I click Command S on my Mac to save, you can see that it formats this document. So the way that I got that working is through another extension called Prettier. And Prettier is a code formatter used by pretty much everyone at this point, or at least it feels like. So it's a very industry standard. And what you can do is hit Command P, hit the little bracket, or not bracket, whatever that, caret, and type open user settings, and it's right here because I've used it recently. Don't worry about all this stuff. These are the only lines that really matter. So you'll add these two configuration lines. This is also documented in the extension. It'll show you right here that you need to add those. And once you've added those, it's going to detect every time you save and reformat the file. All right, so that is kind of the administrative stuff that we're dealing with. I don't think I missed anything, so make sure that you get set up with both of those things. So now that I have saved this, we can go back to our live server, and we should have an empty HTML document. So if you inspect, you can see that here are the elements, and let's just go ahead and change this to vanilla.js T3 for Tic Tac Toe. And then we'll go ahead and just put a placeholder p tag in there so you can see something. And you can see that when we save that, it auto loads, or it has hot reloading so that all the changes are reflected immediately in the browser. All right, so the very next thing that I will always do when I'm starting a project, and this is really kind of the starting point for me, at least for any project, whether we have a backend involved, if it's full stack, or just like we're doing here where it's just front end, I'm going to start with the UI and build the layout for the entire application. And I actually have a video on that kind of explains that process in depth in my front end course on this channel. So you can go revisit that if you need. But basically, the goal here is to build out the HTML structure and then build out the layout with CSS. Now, I debated this in my head a bit of how much time I was going to spend on this portion of the video. And I ultimately decided that this is going to be deprioritized a little bit so that we can focus more on the JavaScript patterns behind all of this. I have plenty of previous videos where we go in depth, like in excruciating detail of how to build HTML and CSS, how to bring those together and design things. And if you watched my front end course, the last series of videos in that course was all about CSS Grid. So we're going to leverage that. We're going to use that in a real world project here, but I am not going to be getting into every last little detail. We're going to take some liberty and do a little bit of copy pasting from this vanilla refactor that I've already built as kind of a precursor to this video. That said, we're going to take it piece by piece so that you can at least see how it's coming together and the thought process behind that. But I will not be typing the HTML and CSS line by line because we will be here for the next 10 years if I do that. My videos are already quite long and they do not need to be longer, especially when this is not what we're focusing on. So let's go ahead and do some copy pasting here. So if we look at this index.html, this is the final HTML of this project, the one that we're going for. So the first thing I want to focus in on is the grid. So that's the hardest thing to conceptualize with building this out. And when I say that grid, we're going to actually duplicate this tab so that we have a reference to look at. And my vanilla refactor will give us that complete picture that we want. And so what we're trying to do here is build a grid that has all of these squares here, but then as you can see, there's also these state variables down here. I shouldn't call them state variables, but a little scoreboard that lines up perfectly with this grid. And something a little bit less obvious, up here, the actions menu also lines up perfectly with the grid. And this player one, you're up indicator, this spans kind of two sections of the grid. So really what we've got here and what we need to replicate is a grid that is, let's count it. You've got 3 columns, so 1, 2, 3. And then the number of rows is going to be 1. So this top kind of header section is going to be one section of our grid. Then 2, 3, 4, and then this 5 bottom one. So really what we have is a, how does this go? Which one goes first? Is it the 5x3 or 3x5 grid? Hard to remember that while I'm talking here on video. But that's basically what we're going to be building. And if I collapse this finished document, so VS Code has these code collapse things that can really help to see kind of how things are structured. So what we can do is collapse everything until it's a lot more clear as to what the grid items are. So you can see that my container has a class of grid, and that grid is going to give us the display grid. So if we go to our index.css and we go to the grid class, you'll see that that is initializing the grid container. And let's go back to this HTML. And then, as we know, if you watched that previous series on grid, is that grid is going to have child elements, which are called the grid items. Now, these are direct descendants of its container. And as you can see, we have 1, 2, and then there's 9 of these squares. And then there's 3 little scoreboard squares there at the bottom. So that's the basic structure, but we are not going to start with all of these different styles and markup. You want to start simple, and the way that we're going to do that is by creating a bunch of divs and just starting with a basic grid here. In order to do that, we need an index.css file. So if you see in the vanilla refactor, we've got some folders for the different types of files. You don't really need that. That was just an organization thing. For this rebuild, I'm just going to try to mirror that. So we'll create a CSS folder and then a new file in there called index.css. And then let's go ahead. This is something that I always do. Let's just throw an all selector and then color red. And that means every text, everything is going to be, or all the text is going to be red. And the reason I do that is just to make sure we're hooked up correctly. So let me close all these files out. This index.html is our starter. You can see I have a placeholder here. And what I need to do is right above the title, we're going to add a link. And we're going to go down and hit enter on the link CSS. And you can see it already knows to go grab the style.css, but that's not what we want because we have a custom directory. So let's go to CSS and select index, save that, and now if this is hooked up correctly, this should be red. So let's go right here, and you can see that it is red and it is connected up. So the very first thing that we need to do is put in a main HTML tag. And the reason that we put the main tag in there is because this should represent the dominant content of the document. Now, if you wanted to figure that out on your own, you can just type in mdn main. So mdn main, and it'll be the first result. And it says it represents the dominant content. If you scroll down here on the usage notes, it says it should be unique for the document content that is repeated, such as sidebars, nav links, copyright, should not be within main. So in our case, this Tic Tac Toe board is the dominant content of this index.html document, so we want it inside main. Furthermore, we'll need a div container, which will be the grid container itself. And we want to give that a class of grid, which we will style within index.css. But if you remember, let me hit Command B on my Mac to close out that sidebar. If you remember on this original, we had the grid class, and then we had all these grid items. So we had 1, 2, 9 more right here, so 11, 12, 13, 14, if I can count basic math right. But basically, we just need a bunch of divs within here. So we can make one, Command C, copy that all the way down. And how many is that? 3, 6, 9, 11. Okay, we'll come back to this if we didn't get that right. But anyways, we've got the skeleton of our grid, and now if we come into index.css, we can make that grid class and say display grid. Another thing that we'll want to do just to start us out is the CSS reset. This was in the original project already, and we can just copy it over. So the CSS reset is just going to reset everything so that we don't have any weird padding going on and anything like that. So let's go ahead and put that at the top. And then we can also initialize our fonts and colors. Like I said, I'm not going to spend a ton of time on this portion of the video. I've got prior videos that go into more depth here, but basically we're importing a Google font right here, and then we are initializing our set of colors as CSS variables on the root selector. So we'll be able to use that with the var and then dash dash whatever variable it is within our CSS. So we'll save this. We'll come back to our document here, and you'll see that it's completely empty, which is kind of what we're looking for. Now, if you looked at the vanilla refactor here, I got it zoomed in way too much, it has this darker background. So the first thing that we can do is actually get that in there, and that would be, I believe, the dark gray right here. So let's just copy that over. We're going to select the HTML in the body and give it that background color. Now, the reason that we have 100% height This is something that's useful for mobile devices because there's another strategy of 100% of the screen height, but that screen height is different on a mobile device versus a desktop, and you'll actually get some little padding at the bottom, so I prefer to do height of 100%. But anyways, the main point here is we're giving it that background color. And this is actually kind of a mistake from the original. We should be just putting in a CSS variable there. All right, so we'll come back and it looks like we've got our background matching. That looks good. And now we can start to initialize this grid. So at the moment, you should be able to find in the main that we have all of these grid items. They're just not showing up at all. So we need to give them some space within the document so that we can start to work with them. So if we wanted to do that, the quickest way to come in here and do that is to go right below the grid and then just select any div that's within the grid class. And let's just give it a height of 20 pixels and a width of 20 pixels. We'll get rid of this in just a moment, but, oh, and then we also need to give it a background color of, let's just say red, something annoying. And you can see there's our grid items. We could also give it, a margin of 10 pixels so you can start to see that separation. So right there are our grid items, and they obviously don't look near what we want them to. So what we need to do is set the boundaries of this grid. Rather than doing this height and width, we can actually dictate how large these items are using the grid container. So if you look in our original CSS that was built out, you'll see that the grid container has template columns and template rows and then a grid gap. So let's start with the columns. We will copy that over. And what this is going to do when we say repeat 3 times 80 pixels, that means that each column is going to be 80 pixels wide. So let's save that. And you can start to see that we've got some columns going here. And immediately you can see that I've added one too many div elements. So we can come over to the index.html and delete those. So now we have this perfect grid right here. And then we can come back to the CSS and then add our template rows. Now our template rows are going to be a little bit different. So I'll explain this in a second. But we'll copy that in, and what we're saying is that the first row is going to be 50 pixels tall. Then we're going to have 3 rows, so we're repeating 3 times. The next 3 rows are going to be 80 pixels tall, so that will correspond with our columns. So we'll have those perfect squares. And then the final row, which is kind of like that scoreboard at the bottom, will be 60 pixels high. So that, once we save it, you'll see that expressed within the grid here. And I believe we actually need more grid items here. I'm sorry, it's hard to count while I'm teaching here, but let's make 3 more. And now I think we're getting what we're looking for. So we can now get rid of the explicit height and width of these items because the grid will take care of that. So now you can see that we've got the skeleton of this grid, but let's go ahead and start isolating things. So we want to maybe style the top row as a different color than the main grid and the scoreboard at the bottom. So this will evolve and change, but just to kind of demonstrate the concepts, I'm going to quickly put something in there. So for the top 3, we're going to hit Option in click in VS Code, and that should allow us to click 3 things at once. We'll give these first ones a class of turn, and then we'll come down and give these divs here a class of square. How many is that? 3, 6, and then 9, so class equals square. And then finally at the bottom, we're going to give these a class, oops, clicking too many things at once. We'll give these a class of score. Okay, so now we'll come back and instead of grid selecting all the divs, all the grid items, we'll select them based on what they are. So let's get rid of this margin also because we will have a gap. We'll go ahead and add a gap of 5 pixels to every grid item so that everything's spaced evenly. And then instead of this, we're going to say, what was it? Turn was the top row, square was the middle one, and then score was the bottom. So we'll give these different background colors. The squares will stay red. We'll make these turn ones green, and then the score will be blue at the bottom. So we'll save that, and then if we come back, now we've got all of these highlighted a little bit differently. And if you look at the final, you can see that this matches almost perfectly, but this little turn indicator seems to take up 2 full columns. And in order to get that working, we can actually do this within the child, the grid item itself. We can tell it how many columns to span at once. So we actually have to go to the HTML and highlight, we can remove one of these div items and keep that as turn, and then this will be actions. So this will be the little drop down, and then this will be the turn indicator. So let's save that, and it should be all kind of messed up now at this point. But here in red, that should be our actions menu. And if we go to the CSS, let's go actions. What did we call that? Actions, yep. And then this will be a background color of, I don't know, let's go purple, something like that. And then finally the turn is going to stay green, but we're going to say grid column start, and that's going to be 1. So we're going to start the first column, and then grid column end is going to be 3. So it spans 2 columns wide. So once we do that, we should be able to go back, and now you see this green is taking up 2 full columns. We've got the actions in the top right, scoreboard at the bottom, and grid in the middle. So if you compare this right here to our final, that's pretty much what's happening. We have 2 spaces here, actions, full grid, and then scoreboard at the bottom. So this is the hardest and first step that you'll do when building any sort of project like this. You have to nail the layout, and then we can start, making it look a little bit better, arranging it on the screen. So I'm going to keep it looking just like this, and we're going to continue this process and get it centered within the document, and then also make sure that as we resize things, as you see, when we resize it down to this small device, it just kind of breaks out. We're going to make sure that it resizes appropriately. Now, if you just take a look at the underlying HTML that we've got going on here, let's make this a little bit larger. You can see that we've got the main container sitting here, and then the body container. So if we wanted to center this main container, really all we would have to do is go to the body element itself, and I believe we can just display flex and then justify content center and then align items center, and you can see how that brings everything to the middle of the screen. So that's generally what we're going to be doing here. So if we come back to our project, and then if you look at this original, so this is the completed version, and if we go to the CSS, you'll see that on the body element, what we've done is we've displayed flex, we've set the flex direction column so that it's going up and down rather than left to right, and then basically aligning everything to the center. So what I'll do is I'll just copy this snippet here from our completed CSS, and we'll bring this to the top or right under HTML and body, and then save that. And now when we refresh, you should see that it looks very similar. The last thing that we need to do, as you can see, we don't have a footer at the bottom. So I've added this little attribution at the bottom, which provides some spacing so that it pushes this grid up a little bit. So we can quickly go add that. So if we come to the final project here, I'm just going to copy this footer markup because it's relatively simple, doesn't really add a whole lot to this. So I'm just going to copy that verbatim, and we will put that under the main tag. So remember, footer is repeated content that if we added pages, we would probably have that on every page, so it doesn't belong in the main content of that page. So if we save that, let's see what we are looking like. You can see that the footer has been added down there, and that's because it doesn't look good because we haven't added those styles yet. So let's go back to our completed one, and I have a section at the bottom that has the styles just for the footer. So let's see, they're all right here. So I will copy those styles to our current working CSS. So let's go ahead and say footer styles, copy those in, and then hopefully this will start to look a little bit better. So now we've got the workings of our project. This is pretty much the skeleton of things, and the last thing we need to do is make sure that it resizes appropriately when we're on a mobile device versus a larger desktop device. So to do that, we will also go to the final project here, and I'll point you to where this is happening. You can see right here, I have a media selector. And so this we've talked about in the responsive web design video that I've done in the past of the front end series. And basically what we're doing is we're saying that we want the grid container itself to resize a little bit differently based on what screen we're on. So what this rule is saying is any screen that is 768 pixels or higher, so basically like a tablet or desktop device, we want the grid to have a width, an explicit width of 490 pixels, because we know we have enough space for that. And then we want to explicitly set the columns and rows to be a different size than these originals. So right now, if you were to select one of these squares, it's 80 by 80. So you can see as we hover over that, it's 80 by 80. Now on a desktop device, we've got some more space, so we would want that to be 150 by 150. So let's go ahead and copy that and paste it right under the main grid selector. So essentially this will be the mobile styles and this will be the desktop styles. So once we refresh here, we're still on a mobile device in this scenario and it looks a lot smaller. And then yes, it will cut off eventually, but really no mobile device is this small. So this is about what it would look like. And then as we resize, you'll see it jump up. So let me go into responsive mode so that we can see this a little bit better. And watch this up here. You'll see as we hit 768 right here, it resizes. So we have a much bigger game to work with on these desktop devices. All right, at this point, we have the bulk of the HTML and CSS, the structure of our project. And the rest of the work that we need to do here is primarily going to be just details of just finessing the look and feel of this until it matches our final product here, where you can see we've got this drop-down menu that's going to be controlled with some JavaScript. You can see when I hover over each square, it kind of gets a little bit darker. We've got a pointer cursor. You can see the mouse is a little different depending if we're on a clickable element or not. And then of course, as we take a turn, watch this up here, it will do this little animation where it kind of zooms in and then slides out. So these are all just little details that we need to add. And like I said, we've done a lot of HTML and CSS work in prior videos. And the main focus of this one is going to be kind of the JavaScript side. So I will walk through over the next several minutes of how we take this right here and turn it into this. But I will intentionally be moving a bit quicker than normal. So be sure to just pause the video if you see something that doesn't make sense, and just kind of walk through it on your own to understand what's happening here. I'm just going to be basically referencing the original CSS document in HTML, and I'm going to be progressively building this out. I'll try to walk you through the thought process as we go, but just a heads up, it's going to be a bit quicker than usual. The first thing that I want to tackle is this green area, which is the animated turn indicator. Now this is obviously going to be controlled by JavaScript at some point, but we just want to get the animation right. So in order to do that, let me close things out. This is our working CSS document and working HTML document. From here on out, I think what I'm going to do is keep the completed CSS here on the right, as well as the completed HTML on the right, and then we'll close that out. So on the left is our working project, on the right is the reference to the final one, and I'll try to just kind of hide this a little bit, only for reference. Okay, so what we're working on is this div right here. So let's go ahead and put some placeholder content in there just so that you see what's going on. So there's our placeholder. I'm going to go back into a larger mode here. So the first thing that we need to do is get this all centered, get the text in there looking good. So if we come to our final project, you'll see that we have this turn class right here. So within the turn class, we're going to have some FontAwesome icons and then a turn indicator. So we'll copy that in there. And if you notice, we have these classes FA solid and FAX. These are being provided by something that we have not added to the head of the document yet. So we will need to do that. This was taken originally from the Yvonne who submitted this project had put this FontAwesome kit in here. So if you just copy this script over right under the style sheet, that will add these classes so that they actually show up within the document and give you an icon to work with. So once we've added that script, these should show up, and you can see there's the little X right there, so we know that our icons are working. And then finally, we need to just style this. So as you can see in the original, we've got the turn class on there. So we need to go down and Control F to find, let's see, where's the turn class? Here it is. Okay, so we will copy these styles on over. We've got some of them already. Looks like we've got the, so the background color we're gonna keep. We want to actually display this as a flex container with center alignment of the items and a gap of 20. So that's the only thing that we need to add, and then we need to align self-center. So that's going to tell the grid where to align things. So really what we have here is just some development only background colors. This tells it how to align itself within the grid. And then this is the specification for how the content within this container is going to be aligned. So if we come back over, you can see that it's now looking a little bit better. And if we were to remove this background color, now you can see that things are looking great. This is exactly the alignment and positioning of the final one. Now, obviously there are different colors going on here, but we're going to be controlling a lot of that with JavaScript, so we can move on from here at this point. Just for the moment, I'm going to turn this to, let's make it that yellow text, so we can give it a color and then use one of our variables. And you remember we had defined a variable of yellow here at the top under our root, so we should be able to throw that in there and get that yellow color right here. And then we need to animate this. So in order to do that, this is a little bit more intermediate level CSS stuff, but in order to do that, we need to add some keyframes in an animation to animate both the icon and the text. First though, you can see that we have some selectors for the icon and selectors for the text. So I'm going to copy those over right under turn. So we've got the paragraph text and then the icon text. I'm going to get rid of this animation stuff for just a second and save that. So now you can see that we've got this looking a lot closer to what's going on here. And now we need to do the animation itself. So when we do an animation, you have to first specify the animation's name on the animation property the CSS property, and you'll give it a duration and then some behavior that you want it to have, and then of course the reference. So for the icon itself, that's what we'll start with. This is going to be the animation that makes it kind of pop in and out, get a little bit bigger and then smaller. So you can see that we have referenced turn icon animation. Now this is an arbitrary value that we have actually defined as some keyframes. So this selector right here matches this. They need to match because right here you were referencing to these keyframes. And what it's saying is that at 0% of the duration, it's going to scale to 100%, and then 25% into the animation, it will scale to 140%, and then once it's finally done, it will scale back down to 100%. So it kind of pops in and then comes out. And when we save this, you should be able to see that. So every time we refresh, you can see that this little icon is just popping in and out every time it reloads. So that icon is going to be complete. Now the same thing applies for the text. We want that text right now, all it's doing is popping in and out, and then this right here is staying in one place. But in the final, you can see what happens is that text kind of fades from the left and animates out. So to get that to work, once again, we need to copy in the animation. So we find our paragraph of the turn selector and copy that in. And right now it's going to be the same animation time as the icon, just so that they match up. Same type of behavior. And then turn text animation, that doesn't exist yet. We need to copy that keyframe right here. So now that we've defined our keyframes of the turn text animation, you can see that we're transforming it at 0% to negative 20 pixels. So it will kind of pull it to the left 20 pixels. And then as the animation animates, it will translate it to go back to its original positioning, which is where the final position we want is. So once again, turn text animation references this key right here. So when we save it, now every time we refresh, you'll see that animation is happening really nicely. So we've got this indicator done. Now obviously we've got an X, it should be an O, so on and so forth. But that's going to be controlled with JavaScript, and we are not quite there yet. Now the next thing that we'll do is we'll build this actions menu. Now once again, this has to be controlled with JavaScript to toggle the open and close behavior. But what we can do for now is just put a placeholder in here that is styled like this, and when you click it, it won't do anything. So in order to get that, we'll come back to our original. So let's come back to our original index.html document. Once again, this is the completed one. And you can see that we've called this menu, and we've got some markup within here. We've got a button. This is going to actually be what is shown. And then down here, this is going to be the popover that is initially hidden. And then as you click the button, this is going to show and then hide every time you click. So what we can do is just copy this markup. And I think I've named it something differently. So yeah, I gave it a name of actions right here, but we'll update that in our CSS. So let's see, this is the drop-down menu, turn that into a comment. This is the turn indicator, and then this, oops, deleted that. This is going to be the game board. And then finally, this will be the scoreboard. Just a little bit of organization. So what I'm going to do is actually comment out the popover just for a minute and work on this button. So if we save this right now, it's not going to show up very well. It's just showing up just like this, and when you click it, nothing happens. We have the correct icon in here and then the correct text, but now we need to actually center this and style it. So you can see that I've given this a menu class, which in the original index.css, we'll go find this. I've just given the menu class a position of relative. The reason for that is because we need that popover that opens to have a relative reference so that it knows where to open relative to in the DOM, because it's going to have absolute positioning. So we will put this, where should we put this here? So we've got our turn stuff. Let's just make a different section. So this will be the menu styles. Just trying to keep this straight for everyone here. So give that a position of relative. That's not going to do anything to it. It's still going to look the same. But then once we add the menu items, so if we go back to our markup in HTML, you can see that we should have some items. Those are commented out, so we're not quite ready for that. Let's see, we just need to style the menu button right now. And I'll get rid of this just for the moment. That's going to come in later, as well as this data ID. I just don't want to add anything earlier than it applies. So the only thing we don't have styled is this menu button. So let's find that here. There's our completed style. So let's copy that in right under menu. You can see that we want it to be 100% width and height of its container. And if you remember from this original, the container that we're working with is what's highlighted here. So this is just one grid item. So if we say it's 100% of that, it's just going to be 150 by 50. And then we're going to display flex. So the items within it are going to be flex items, and we're going to give them space around and justify them center. So let's go ahead and show you what that looks like for now. So you can see that we've got this menu item that's looking a lot better. It's got the wrong styles, but we're getting closer. So let's come down, uncomment these. And here we're going to give it a background color. I believe this was like a one-off color that didn't fit into the color scheme, so that's why I'm defining it here without a variable. And then we want the text to be white. We want to give it a border and then make that border rounded a little bit. So we'll go ahead and save that, save the HTML. And now you can see that our actions menu is looking exactly the same as this one. Now the final thing that we have to do, we don't have JavaScript functionality to this yet, but we can still kind of mock out what this menu looks like. So as we click this and open the menu, we can still build this even though we don't have JavaScript. So to do that, all we need to do is uncomment this div. And at the moment, we haven't styled these classes, so it's going to look very weird. You're just going to see it right below the actions menu. But what we want to do is make this items class. And then more importantly, it's going to be hidden initially, and then our JavaScript is going to be what's responsible for unhiding that. So here's what I'm going to do. Let's go ahead and remove, well, no, let's keep it as is and define the items class. So where is that? Let's search for items. All right, so here are the menu items. I've actually selected any element with an items class that's within an element with a menu class. You don't really have to do that. We could just copy in items directly because we don't have any additional styles going on there. So we've got the menu button that's always going to show, and then the items are going to be these items that you can click once they're expanded. So there's a couple really important things going on here. The first thing is position absolute. So because these items are within the menu class, the absolute positioning is going to be relative to the nearest parent element that has a relative position on it. And as you can see, we've given that menu a relative position. So these items are going to be positioned absolutely relative to that menu element. A little bit confusing, but we've gone over that in prior videos in the series that I built out. So we want to give it that absolute positioning and a z-index of 10, which means that it will sit over the grid of items. You don't want that to go behind. So the top, it'll be 60 pixels offset from the button itself. So I'll show you what that looks like. Let's go ahead and just look at those styles right there. Or actually, let's go ahead and take out everything except for the absolute positioning. Okay, so absolute position, you can see that nothing really has happened here quite yet. Now, once we uncomment the rest of this stuff, let's go ahead and comment that out for a second, and we're just going to give it the actual positioning that we want. And now you're going to see that things are looking a little bit better. Now the positioning is going to be relative to this right here, so the top left corner. So if you see, the total height of this button is 50 pixels. So that's why I gave it an offset of 60 pixels from the top. So it will offset 50 pixels from this to get it to the bottom of the button, and then another 10 pixels to give it this little gap that you're seeing right here. And then, of course, we need to give it a background color, a rounded border radius, and some padding within the container. So you'll see now it's looking a little bit better. We still haven't styled the buttons within it. But then finally, we'll add the z-index. We just want that there to make sure that it's always sitting on top of these items. Now the last thing we need to do is style the buttons in there because they don't look very good. As you'll see here, they're not super well styled or anything, but they look a little bit better. So in the HTML, you can see that we've got a reset button and a new round button. These have data IDs on them. I'm gonna get rid of those because we don't need that quite yet. We're just going to style them based on their parent. So we're gonna look for the menu and then items within the menu, and then any button that is within that is going to be styled like this. So we can actually just remove the menu. It'll still work if we do the buttons relative to items. So if we save that, now you'll see that the buttons are looking a little bit better, although you can see we don't have any like hover effects. We want the cursor to become a pointer so that the user knows that they can click on them. And to do that, we're just going to need some hover styles. So if you pop that in there, we're going to underline the text and give it a cursor pointer. And now you can see that this looks a little bit better in that regard. So as you'll see, there's no border around this button in the final until we actually click it. And once we click it, it's been focused and everything's going to have a border. So we'll have to wait on that until we have some JavaScript. But for now, you can see that everything is being aligned correctly. And then the last thing we need to do is just create that hidden class, because as you can see, we've got the hidden class here and then a border class. These were shared styles that we would use across multiple elements. So I put them in shared utility classes within the CSS file. So we'll bring this to the top. We'll put it right under the body as shared utility classes. And I'm just going to copy these in all right now so we don't have to come back and do this in the future. So we'll copy those in, just a hidden class that displays none, and it has important on it just to make sure that nothing conflicts with it. Then we have some shortcuts for yellow and turquoise. You don't have to do this, it's just a little bit easier once we get into JavaScript. And then just some standard borders and shadows that we'll be putting on different elements. So once we add those, you'll see that given these two classes we've put on this, it will hide that menu. So you can go ahead and remove that hidden right there, and it will be showing back up with the border. But for now, we just want that hidden, and then JavaScript will unhide it for us once we implement that. All right, at this point, you can see now we've got some conflicting styles going on over here. We'll be sure to come back to that and handle that with some JavaScript, as well as our actions menu that we can't really do anything with at the moment. It's not really clickable because we need some JavaScript to enable that. So we are done with this first kind of row. Now these grid squares or game board squares. These will be relatively easy to style, so let's get in and do that real quick. So here's our game board, and then let's go ahead and look at the reference, the final one. You can see that I've given each of those a square class, which dictates their styles, and then we've put a shadow. Remember, we just defined those shared utility classes, and I've defined a shared shadow class that will apply to everything. So that's just kind of keeping the code dry, making sure we're not repeating ourselves too much. So what I can do is now add those in. So once again, I'm going to hold down Option and click through this within VS Code to select multiple at once, and we will add that shadow class. Now, furthermore, we're going to want to give, we don't need the IDs quite yet. That will come when we add some JavaScript. So let's save that, and then finally we can get rid of our background red. So wherever we put our squares, we don't want that background color anymore. We want a much nicer looking one. So you can see here are our square colors. We want it to span 100% the width and height of its container, which, as you can see, this is going to be the grid item itself. So we want that to span 100%. And I don't think that is actually necessary now that I'm looking at this, because the grid will control those. So let's go ahead and just copy this gray background. I'm going to put a little rounded border, and then we're going to make sure the content within it's a flex container so that the content is centered within. And then the font size is going to be 3 rems because we want those icons that are sitting within to be extra large. So we'll copy that into the square class, save it, and now our board just started to look a lot better. So you can see that we've got those shadows that you see on the final. The only thing that we're missing here is when we hover over them, it doesn't do anything, so it doesn't feel like to the user that you can click. So in order to cover that, we need the hover styles. So that's what this is for, the hover style for a square. We'll copy that in. We want to give it a cursor pointer and then just a 90% opacity. So now when we hover, it's going to act like it's actually clickable. For now, we're going to leave the icons kind of off of this at the moment, because that's once again going to be controlled by JavaScript when we actually click these. So the last thing we have is the scoreboard down here at the bottom. This is relatively simple markup. So we'll look at the final project, and you can see we've just got some basic HTML, a bunch of div containers with some paragraph text, and then a little styled scoreboard where it shows how many wins they have. So I'm going to just copy all of this stuff verbatim. It's not very complicated. You can read through it on your own. So we'll put that in the scoreboard section. We've already implemented the shadow class in our shared styles. And I've added an inline style here with the color, mainly because it's just easier to read. It's easier to see that within the HTML what color it is, rather than making a different class for each of these. You could do whatever. You could add this to the index.css, but I just thought this was a little more straightforward to read. So once again, let's get rid of the data IDs for the moment, because those are more applicable when we get to the JavaScript. So this is our scoreboard. And the last thing we need to do is implement this score class, because if we come over here, you can see that nothing looks very good. We've got the different colors, but they're not centering the text or styling the text or anything like that. So we need the score class implemented, which we can go find in the final index.css. All right, so here's the score class. We're going to replace the background color blue. Oops, we need to get rid of that. Okay, so we're just going to display flex so that each box is a flex container, and we're going to give it a top to bottom flex direction, and we're going to justify all the content and align all the content to the center of it. And then we're giving it a height of 60 pixels, which once again, I don't think that that was probably leftover stuff because the grid should be dictating that. And then we're going to give it a little border radius so that it's rounded. So let's save, and you can see that things show up okay here. The last thing we need is this text. It's obviously not styled very well yet compared to the final. You can see that there's a little bold style on the title, and then the number of wins is going to be a little bit smaller. So to do that, we're going to do some sub-selectors. So the paragraph text within the score box is going to have a font size of 14 pixels and a font weight of 600. If you scroll to the very top where we've imported our Google fonts, you can see that we've imported a font weight of 4, 5, and 600. So that's what allows us to use that font weight. If you didn't import that, then this is not going to do anything. So just a note there. And then the span element, so this is where we actually show how many wins the person has. We're going to give it a font size of 12 pixels and a little margin on top. So we'll save that, and now you can see that everything is styled correctly. So at this point, looking between the two, we pretty much have the same exact design going here, and we're, for the most part, completed with this HTML and CSS portion. So let's go ahead and scroll through this final completed one and just make sure that we've got everything matched up. So we've got the footer in here, that's perfect. Looks like the modal we need to still do. I forgot about that. So we'll get to that. And then in the main content, we've got the scoreboard right there. We've got all the squares for the game board. We've got the menu implemented, and then the turns implemented. And then I think pretty much everything else is done. So HTML looks good aside from this modal, and then of course we'll add the script once we get to the JavaScript section. And then from a CSS standpoint, let's go to the top. Make sure we've got everything. We've got the import correct. We've got our styles, the CSS reset, global, HTML and body styles. Let's see. We added this global style that looks like it got put in the wrong place. So let's go ahead and add that to our shared utility classes. That's not really supposed to be a utility class, but that's global, so I forgot to add that. And then the grid, we've got that done. This is the responsiveness. We got all the utility classes. We added the turn along with the animations. We added the menu. Looks like we covered all of this. We got the footer. Okay, so really, we have completed everything except for the modal. And when I say modal, I'm talking about what happens here when someone wins the game. So you can see it pops up this kind of focused element, and then it puts the game in the background, makes it look as if this is the only thing that you can click. So in order to implement that, we obviously need some JavaScript, but we can implement it with just HTML and CSS, and then we will come back to it once we have some JavaScript available to us. So the first thing that you need to do when you're implementing a modal is give it the HTML markup. So we will copy this over, and you can notice that I'm putting it at the very bottom under the footer. And one could argue that this might belong in the main content, but really this is going to be hidden initially, and it's going to be absolutely positioned or fixed positioning, I think. So it doesn't really matter where in the document it goes, it will show up correctly. So I think one could make the argument that it goes in main, like I said, but let's go ahead just to stay consistent and put it at the bottom. And then since we've got this hidden class of the, this will do display none, let's get rid of that for the moment, just because we want to see what it looks like. And if we go back to our project, you can see that the modal is right here. It's at the very bottom. It's got this P tag and then a button that says play again. Obviously, this is nowhere near what we want. We want this centered and have a little backdrop. So we've got some CSS that we need to write. And if you see in the final, we've got all these modal styles. So I'm going to copy all of this over at once at the very bottom, give it its own section. And then what I'm going to do is just comment things out so that we can progressively see what things are doing here. Okay, so we've got everything copied in here. The first thing we need to do is target the container. So this is the div container with the class of modal. So what we're doing here with this modal container is we're giving it a display property of flex and then positioning of fixed. Now fixed positioning is relative to the entire document. So what that, or the viewport I should probably say. So if we're looking at our viewport, this entire screen here is the viewport itself. So this is going to be relative to the entire viewport. Well, something like absolute positioning is relative to the nearest relatively displayed element. So in this case, since it's a full screen takeover, we want this to be a position of fixed. We want to give it a width and height of 100%. And that will work because up here at the top, we have given the HTML and body a height of 100%, and it's automatically going to span the width of 100% just based on how block elements are displayed. So by giving it just this stuff, display flex, or we don't even need that yet, position fixed, width 100%, height 100%, let's save that. And now you can see up here it has moved. So now this takeover, the modal, spans the entire screen, as you can see. Now we want to take this content and put it right in the middle and give it some styles. So what we need to do is uncomment the justify content and align items, and then also the display flex. So really we need to bring those up, just so that, not for functionality, just so you can see it all together. So display flex, and now you can see it's right in the middle. And then finally, if we give it a background color, it's really going to start to pop out. So this entire modal has this dark background color. Now, of course, we need to style the contents of the modal to also have a background color, and that's where the modal contents come in. So if you see in the index.html, the container within it has a class of modal contents, and what we want to do is just uncomment all of this stuff. So I'll quickly walk you through what's going on. Let's see. The first thing, let's get rid of that for a moment. Height, width. Okay, let's get rid of these last ones and start with this. So the first thing we're doing is giving this container a height of 150 pixels and a width of 100%, and then a max width of 300 pixels. So in other words, what we're saying here is that by default, we want it to be 100% width. But if the screen is big enough to where 100% width is larger than 300 pixels, then default to that max width. This is just a little trick that I use a lot for mobilely responsive or mobile first CSS. And that way it will just look good on everything. So let's go ahead and save this and then go back, and you can see our modal content is coming together. So to display, or to show you what I mean here, let's go down to a smaller device, and you can see that that's kind of resizing as we are on the smaller device, and then as it gets to a bigger one, it's going to stop. Right now it's 238 pixels, but once it reaches 300, it's going to stop getting bigger. So right there, it reached 300, stops getting bigger, and it stays centered. So that's what this little trick is doing right here. Now we want to display flex and basically align everything center. So let's get rid of these comments. And now this right here should basically center everything. So now you can see player one wins and play again. It's all centered. So that looks good. And then finally, we want to give it a flex gap of 20 pixels so that the content within it has some spacing. We want the content to have text color of white, and then we want the whole thing to have a margin of 10 pixels. So let me comment that out for a second. Here's our spacing, white text, and then you'll notice on the mobile device, once it gets too small, it pushes right up against the edge. So if we just add a margin of 10 pixels, you can see it adds that little gap there. So that's only for mobile device. Then the last thing, we just need to style this button. So you can see that I've targeted any button within the modal contents and just given it a padding of 10 pixels, background color of turquoise, text color of something a little darker than that, and then some rounded borders. So if we save that, you can see that the button now has these nice styles. So our modal is complete, and if we just give it that hidden class back, so if we put hidden on there, it's going to be completely gone, and then we comment that out, and it's back. So you can see how our JavaScript is basically going to take that hidden class and it's going to remove it, add it back, remove it, add it back based on when someone wins the game. And then the play again button will also trigger a JavaScript action. All right, so I know I said that I was going to kind of gloss over a lot of the HTML and CSS, which I sort of did. We did a lot of copy pasting, but hopefully that was a good blend of, how did we get to this final state, but not typing every last little letter. So if you just toggle between the final one, final game right here, and our current game, everything looks pretty much the same. So HTML, CSS, that's done. But obviously when you click anything on this board, nothing is going to happen because we haven't hooked up JavaScript, which is going to actually control the game. So we want to be able to, make plays and reset the game and do things like that. So at this point, I would recommend, if you're watching this video, to take a little break because we are going to switch from HTML and CSS mode to JavaScript mode, which requires a little bit different type of thinking. So we're in the JavaScript section, but something that happened to me when I was first starting out is I would always just be asking this simple question of, when we're looking at JavaScript, where do you even start? Like, what's the first thing that you think about when you're trying to connect up some JavaScript functionality to a static HTML and CSS application? So looking at this, we can click stuff, but it's not going to do anything. And so the question is, where do we even start thinking about adding these event listeners and all the different state management that happens to make this game work? So in asking this question, I think the next question that we need to ask is, what actions can a user take in my app? So we're building a game, and there's really 3 actions that a user can take. Let's go back and look at the finished game. This is the refactor that I've done that's actually working. And if let's reset everything, new round, get everything cleared out. And the first action that a user can take is they can click on one of these squares on the game board. So this is just, a player move that is happening. So that is the first thing that we need to jot down. A player can make a game move. Now the second thing that they can do, once someone actually wins the game, so player 1 wins, we play again, and you can see down here, player 1 has 1 win, 0 ties, player 2 has 0 wins. So the next action that they can do is hit new round, and that's going to clear out this scoreboard down here at the bottom. So we can say clear, or actually new round. And then finally, the last thing that they can do is, if they started a game and just want to reset it, you can go to the reset button, and that will clear things out and it won't touch the scoreboard. So we can make a new round or reset the current game. So I think with any application, any front-end project like this that we do, this is a great first question to ask yourself, just so that you can get a better understanding of these requirements. Now, of course, once we have this question answered, you obviously have to start writing code to make this happen within your static HTML and CSS. So there's a lot of different ways to approach that. And ultimately, where we're headed by the end of this video is to have some sort of model view controller pattern that's going to help us organize our code to make this stuff happen and handle these events correctly. So model view controller is just a pretty common architectural pattern that's commonly used for developing user interfaces. So this is actually me from the future. I was editing this video and realizing that I had created this diagram to kind of give an overview of the MVC pattern, and I didn't actually go through it. So this is the MVC pattern, model view controller, and I wanted to just walk through kind of the flow of this. So as we're building our application, there's three separate concerns basically. We have the view, which, as you'll see, this is event listeners that handle either UI only events, so like toggling a menu, as we'll see here, just toggling this actions menu, or we can manipulate the DOM and respond to state changes. And what happens is the store over here is kind of the model, and this is responsible for getting state and saving state and emitting state change events. And this app in the middle is the controller, and this is responsible for kind of orchestrating between state and the view and making sure that, you know, state updates and the view updates all in one concise, consolidated place. So I know this probably doesn't make a whole lot of sense, so I'll stop here, but just keep this in mind, come back to it as we go through this build, and hopefully this gives you a little visual representation of this pattern we're using. Now, this is going to be a very challenging pattern to implement straight off, you know, right off the bat, and it's not going to make a whole lot of sense. So what I've decided to do is almost a contrived example where we basically start with a more naive approach where everything kind of sits in one file and we don't have really any architectural patterns behind this. And we're going to progressively iterate on that and get to that MVC pattern that's a little bit more stable. So we'll call this the video progression. We're going to start with, you know, a naive approach, all in one file. Then we're going to refactor and iterate as we go. And then finally, we're going to end up with MVC pattern that is, and this is very important, it is going to be easy or easier to debug later, and it's going to be easier to extend and add features to later. Now, these are really important parts of building software because anytime you're building software, you're going to have users that expect things to be improved and fixed and extended. You want to add more features. So, for example, in our basic Tic Tac Toe game, you might want to add some leaderboard over here to the left side or the right side. And you might want to be able to add user logins and, you know, registration and whatnot. And being able to do that is going to be very difficult if we haven't planned out a little bit of architecture and a little bit of software design behind what we're doing. In other words, everything in one file is going to quickly become unmanageable. With that said, I think we can go ahead and get started. Now, just thinking about this a little bit, let's enter this down so we got some more room. What actions can a user take in my app? We've defined these, and what I want to kind of point out is that these pretty directly, oops, did not mean to do that. These pretty directly map to event listeners on HTML elements. So in each case, when we look at this, we have individual elements. So reset is going to be some sort of button, new round is going to be a button, and then each of these squares on the game board are going to be like a button or a div or something like that. And every HTML element has event listeners that you can hook up. And then when that event happens, you'll put in some JavaScript logic that will maybe manipulate the DOM and update some sort of persistent state in local storage or session storage, so on and so forth. All right, so I think that's enough planning for the moment. We're going to kind of come back to this whiteboard a little bit to plan out some more features as we build this out, but I want to get started just to kind of jump in. So if we're looking at our HTML document, we have to ask the question, how are we going to add JavaScript to this? Well, theoretically, you can put JavaScript pretty much anywhere in this document, but you will always see a best practice of putting that JavaScript at the end of the body tag in almost all cases. And the reason for that is because when we are loading an HTML document in a browser, the browser has a bunch of code that's running in the background that actually has to read through this HTML document and parse it, and parse all of the elements there and all the styles, attaching those to the elements, and it has to actually paint that to the screen. Now, this is called the critical rendering path, and I would say this is a more intermediate to advanced concept that you can kind of check out on your own. But the point of this is to say that when we load this HTML document in the browser, it's actually going to make a network request to get the document. You can see that over in the network tab. You'll see this first 200 GET request. Let's make this a little bit larger. This is the initiator, is the document, and it's of type HTML. And when we click this, it's going to render the HTML here. But if we look at the raw response that we're getting, this is the HTML document that has been sent over to the browser. And the browser has to go through and parse that. Now, why is this significant? Well, the reason being is if we have JavaScript that happens or is placed here at the top of the body, what that means is that before the browser can parse any of the HTML and show that to the user, they have to run all of that JavaScript that is sitting there at the top of the body. And if you've got a large enough JavaScript bundle, that's going to block things, and the user's not going to see anything in the browser until that's done. So that's just a poor user experience, and that's the reason that we'll generally put a script tag at the bottom of the body. So once we've got this script tag here, we can run arbitrary JavaScript in it. So we can say hello world and save that, and then our live server is going to reload, go to the console, and you'll see hello world. And just a side note, you'll see this GET request that's airing out on the favicon. We don't even have this in our HTML document. The browser just by default is going to look for this because it's kind of a standard, so we can safely ignore that. But anyways, you can see we've got JavaScript running, but obviously we don't want to do all of our JavaScript inline here because we're going to have to write enough of it to where this will get pretty cumbersome. So ideally, what we need to do is make a script that has a source tag. And that source tag is going to point to a JavaScript file that we're going to add to our directory. So we'll come over here to the live vanilla build, add a new folder called JS. It could be anywhere, but we can put this in and we'll call it app.js. You can call it whatever you want, main.js, index.js, any of those work. So here, let's go ahead and put our console.log, hello world, save that, and at the moment it's not going to do anything. If we refresh, well, I guess we haven't saved the HTML yet, so let's save that, refresh, and you're not going to see anything. You'll just see the source attribute of script is empty, and that's because we need to populate that with a path to our app.js JavaScript file. So once we save this, you should see everything's hooked up. We get hello world in the browser, and we have our basic JavaScript file. So at this point, now that we've got a basic JavaScript file set up, I want to go ahead and start on these user actions that can happen. So remember, we've got these 3 user actions, and there's actually a 4th one that we are going to start with because it's probably the simplest implementation. And that one is toggle the menu. So this new round and reset current game, these are part of the menu, but we actually have to implement that so that this menu pops open and closes every time it's clicked. And that can't happen with just HTML and CSS, at least without something crazy going on. So that's the first thing that I want to do because it's rather simple to implement. And then we'll start working on those user actions and how do we track the state of the game. So the first thing that we're going to do is kind of scaffold out our actions. And to do that, we need to identify the elements that we are going to select. So I'll show you a better way to do this in a couple of minutes, but we're going to start with kind of, as I said, the naive approach of what you might think to do first. So if we're looking for that menu, you're going to come to the drop-down menu section of our HTML, and you'll see that we've got a div with the class of menu. So probably the easiest way to select this element with JavaScript is going to be, let's call it menu, and we're going to select the document, which should be globally available to us in the browser runtime. So that should be available. And you can see VSCode has already kind of detected that this is available to us. So it's giving us all this autocomplete stuff of the browser APIs. So we can say document.querySelector, and we can select by a class and select any element that has the menu class, which we know just to be one div element. Now from this menu, what we can do is add an event listener. And we want to listen for the click event. And then on the callback, we're going to get an event object, which has a target, which represents this element right here. So if we were to console.log event.target, we should see when that is clicked in the user interface, we're going to see the element itself printed to the console. And you can see that we've got the button, and if you open this up, you'll see all of these different attributes. And these are all the things that we can read off of this element target. Now to get this to actually toggle down that menu, if you remember from our HTML, all we needed to do here is go down, I'm sorry, not there, right here. This is the menu items, and you can see that we've put a hidden class on there. So if we were to go back to the browser and select this element and go find that div that is hidden, and then we can uncheck this hidden CSS class, you'll see that, well, this actually shows the modal because we're sharing this hidden class with that modal as well. So let me refresh and just remove that class for a moment. And you'll see that now by default it is showing. So really all we need to do with JavaScript is toggle that class on and off every time that button is clicked. So this is the class we're targeting. But in order to do that, we need the ability to select this item so that we can manipulate it. So there's multiple ways that we can do this, but you can see we've already selected this div element that has a class of menu. So we've already got that context within JavaScript in the menu variable. Now we can use that and select any div that has the items class within it. So a simple way to do this is to say menu items, and we can say menu.querySelector, and then look for the items class. And from there, we can then manipulate that. So when we see that the button on the menu has been clicked, we can come down and say menu items, and we can say class list, and then we have this method available called toggle. And we can pass in a class of hidden, and that's going to toggle the hidden class back and forth every time the button is clicked. So let's see if that works. We click this, click it again, and you can see over here on the right that hidden class is just being added and removed each time. So the question is, how did I know to do that? That's always a good question to ask. And let's go ahead and go to MDN, which is our favorite documentation for the web. And what are we going to search? We want to look for class. Let's start with element. So element is a base class. It's the most general base class from which all element objects in document inherit. In other words, what that's saying is when we do a query selector and get an element back, then all of those are going to inherit the instance properties and instance methods of the element. And if you look at instance properties, you'll see that we have a class list available to us. And from that class list, if you look at the value, you can see that we have a toggle method. So the toggle method of DOM token list removes an existing token from the list and returns false. If the token doesn't exist, it's added and the function returns true. So that's how I would go to find that this is available to us. And that's how I knew that we had a class list on the menu items, which basically is going to map to this right here. That's what we're dealing with in JavaScript. And then the toggle method is just a convenience method that allows us to add and remove this class or whatever class we pass in as an argument. So just with a couple lines of code, we now have some functionality in our application. We can toggle this actions menu. Now, of course, we can't click the new round or reset and expect it to do anything because we haven't set click listeners on those yet. But what we do know is that we can toggle it. Now, there's already something wrong here, and there's nothing terribly wrong, but I'm going to start making a list over here. If we can remember where this is, we'll say, let's zoom in a little bit, make this a better font. So best practices when developing user interfaces. All right, so the first one that we're going to talk about here is global scope and namespaces. So if we go back to our application, there's something that's a little bit wrong here and could cause you problems in the future if your app gets bigger and you start splitting this across multiple script files and using similar variables. So let's say that we went ahead and added another script to our index.html. So let's copy this down. We'll say second app.js. And over here, we're going to add a new file called second app.js that we'll delete in just a minute. And I'm going to define a variable called menu. And this is just going to be some object, some JavaScript object. Okay, so we've got in our second app.js a variable called menu. In our first app.js, we also have menu, but they represent two different values. So the question becomes, which one's going to win? Which one's going to take precedence? So let's go in here and click our button again, and it seems to be working okay. So let's go back here and flip the order of these scripts and save it. Now let's click here, and this is no longer working. And the reason being is because we have a redeclaration of the menu variable. And so it no longer knows what to do because we're trying to set an event listener on a constant object variable because they're conflicting. So as you can see, this is already a bit of a problem. And the problem here is not that we're defining two variables of the same name. That's totally acceptable within, programming. It's the fact that we're declaring the same name in the same scope. Furthermore, we're putting it all in the global scope. So believe it or not, if we would go to this console here and type menu, you can see that that value is an empty object. And then if we type menu items, let's see, menu items will be undefined because we're deriving that based on menu. But let's go ahead and flip this script. Oops. Okay, so we're flipping them in the different order. So now this menu will work okay. And if we type menu, it's now back to that element, and menu items is going to be another element. So you can see that these are available in the global scope, which is usually not a great idea. So something that you're always going to want to do when you're developing applications is make it into a namespace. So when I say namespace, all I'm referring to is one variable, that a single name that we can encompass and store, basically put a closure over all of our other variables so that it's not going to expose all these different variable names in the global scope. So a way that we can do that is just defining a variable called app. And this will just be a basic object to start with. And within this app, we're going to store some of our selected items, and then we're also going to add an initialization method. So the first thing we'll do, let's get the menu and menu items on within this namespace. And something that's really nice to do is put a prefix in front of that. So we'll just put a $. That's a pretty standard convention that people would use. And so this will be a property of this namespace. And this is where we're going to put all of our selected HTML elements. Okay, so right here we're going to call it menu, and we can say document.querySelector looking for the menu class. And then we will also put menu items, But now we no longer can derive this based on menu, because at this point in the initialization of this object, we don't have menu available to us. Now you could try to do something like app.menu in reference, or sorry, app.$.menu, and then query selector, and then look for items. So you could try that, but if we save that and go to the document here, it's going to say uncaught reference error, can't access lexical declaration app before initialization. So in other words, we can't reference it here because it hasn't initialized yet. So a quick solution to that is to just replace this. Instead of deriving it based on that element, we'll just look for it in the document. There's only one element with a class of items, so that should not conflict with anything. So we've got our selected elements. We're looking a lot better here. And now if we go back, and let's go back down in our index.html and flip the order to where it was broken before. And now if we refresh, it's going to say menu is not defined. What are we doing here? Oh, I'm sorry, that's because the event listener is no longer going to work. So let's comment that out for just a second, and things should work now. You're not going to get any namespace errors. This menu is not going to conflict with this menu because this is has a closure over it with app as the namespace. So let's get rid of second app. That was just for demonstration. We'll delete that. And then in the HTML, we can delete that reference. So we're back to where we started. And now what you'll see is if we go to try to access the menu variable, it's not going to be available. So I guess there's a built-in called menu bar, but menu's not available. But if we go to app.$.menu, that is how we could access that element that we've selected. So now all we have is a single namespace called app. And theoretically, we could define that same variable in a different file and it would conflict, but it's much less likely and much easier to track all the variables we're defining when we only have one namespace that's covering everything else that we're defining. So the next thing that we'll do to make this a little bit better, we could of course uncomment this down here and say app.$.menu.add event listener and save that. And then we come here and it's going to say menu items is not defined. I'm sorry, because I have to reference app.$.menu items as well. And we're going to toggle this and it'll work just fine. Now there's one improvement we can make, because right here we're doing this in the global scope. So a better way to do this is to make an init method within our app namespace. So the init method is going to be where we're going to add event listeners to our application. And just to note, this is ES6 syntax. This is just a shorthand way to define a function property on an object that we're calling app. So another way to do this would just be a property, and then you could add like an anonymous function just like that, or you could do an anonymous function like that, so on and so forth. You could even define a function up here and assign it there. But this is just a quick way to do that shorthand. And then what we're going to do is move this initialization logic into that method right here. And what that does for us is now it allows us to control when our app is initialized. And what we can do here is if we save this, this is no longer going to work because we haven't initialized our app. But a nice way to do this is say document.add event listener, and we'll wait for the document to fully load. And you can see in the documentation, VSCode populates. Actually, this is not for the load event, but this is basically waiting for the entire document to load so we know things are safe to use, and select. And then from here, we can have a callback function that we'll call app.init. So another way of doing that, we could call it like this, so app.init, and save it. And if we do this, it's not going to work, and I believe the reason is this should be window instead of document. So let's try that. Looks like it works. Let's go ahead and look at the reference here. So MDN document. So we can look at the document here, and then let's look at the events reference. So listen to these events using add event listener on the document, and it looks like the load event is not available there. But if we look at the window, if we can find that, so let's look at window and then events here, and this is where we're going to find the loaded event, I believe. And you can see here in the load and unload events reference, here's the load event we're listening to, and that's fired when the whole page has loaded, including all dependent resources, such as style sheet images. In other words, this happens when all the HTML is in the document and we can start selecting it safely. So that's why we're listening on the window here, and basically we're just listening for the load, and then we're initializing our application, which will select these elements and add that click listener to our menu. Now, a shorthand way to refactor this, rather than this syntax, we can just remove this and remove the call, and that's a more concise way to write that, and we'll have the same exact functionality just like this. All right, so we have a basic toggle menu that's working, but the next thing that we need to do is kind of start on this game and working on the state of tracking the different moves that a player can do. So let's first scaffold out kind of the events that we're going to have to listen to and the elements that we're going to have to select. And then we will come back and fill in that logic with an actual implementation. So as you know, init is where we're going to register all of these event listeners to handle these user events. So what we can do is first define the elements that we are going to trigger those events on. So let's go back to the game. And the first two are pretty easy. We need to target the reset button and the new round button. So one way that we could do that, you can see that we've got two buttons, reset and new round. So there's no selectors on either of these buttons. So what you could do is just add a class, but one thing that I'm going to show you here to refactor, and we're going to do this as we go, is add a data ID. So this is a much more stable way to select elements when you're querying them in the DOM. So if you go to MDN and type data-star, you will see this attribute, which is global attributes form a class of attributes called custom data attributes. This allows you to add proprietary information to be exchanged between HTML and its DOM representation. In other words, we can give data ID or data whatever we want to define, and that's going to allow us to have a stable selector. So let's come back first to Excalidraw here. So we've got global scope and namespaces, and now let's talk about stable selectors, data star attributes. Okay. So what do I mean by that? If we go to index.html, we could select these buttons indirectly by looking for the menu div and then looking for items and then getting the index of the button to select which one we want. But a more stable way to do this, let's start with menu up here, is to just add a data ID. And we're going to call this menu. So let's save this document and go back to app.js and update our query selector here for menu. So instead of selecting the class, we're going to select something, we'll put some brackets, which says we're selecting an attribute called data-id, and that will be equal to menu. So let's save that and see if things are working okay in our app. And it looks like they are. We're allowed to select that. And let's break it on purpose. So take out that U just to break things. And now it's going to say uncaught type error, app.menu is null. So you know that this is working. And we could also call this whatever we wanted. So data custom selector, just to demonstrate. And you could update this to say custom selector. And that's going to work just fine. We'll still have that being selected appropriately. So data ID is just a convention that I've always used, and I think it's a good succinct one that you can use as well. So we're going to put a data ID on each of these elements that we want to select. And the main reason for doing this is to have stability. So if you changed the name of this class for menu, or if you rearranged the HTML elements in the future, you don't want all of your JavaScript to all of a sudden break because you changed a style element of your document. You don't want to couple those two pieces together. And so this is a way to keep things a lot more stable. So we'll come down here and add a data ID for this of menu items. And then we'll add a data ID for this reset button. Same thing here. Oops. New round button. Okay, so now we have selectors that are a lot more stable for all those, and we're going to register them here. So we need two more. We need a reset button and a new round button. And we're going to just copy these query selectors so we don't have to rewrite that every time. And then we'll replace this with menu-items is what we named it. This one we called it reset button, and this one was new round button. So if we got that right, we should have all of these being selected, and we should see no errors within the document. And you don't see any errors other than this one we know about, and this is working fine. So this has been updated correctly. At this point, it should be relatively simple to add the rest of our actions here. So we've already got the event listener for the menu toggling. Now we're going to select the reset button and add an event listener. We want to wait for a click on that and then open up a callback function that receives the event. And we'll just say reset the game. That'll be our placeholder for now. We can just copy this down, almost do it verbatim. Instead of reset button, it will be new round button. And we'll say add a new round. So we've registered those click listeners. And now if we open up the actions, it'll toggle. If we hit reset, it will reset the game. And if we hit new round, it will add a new round. So we've got these hooked up okay. And then the last thing that we need to do is register a click listener on each of these squares. Now there's a better way to do this than what I'm about to show you, but the way that I'm about to show you is probably the most intuitive and the simplest way to do it. So what we will do is let's look at the index.html and find these game board squares that we're trying to select. So the quickest way to do this is let's go ahead and add a data ID. And I believe we can duplicate these data IDs. So let's just call it square. And then we'll add that for all of these properties here. So I'll hold down Option and just click in VS Code. You can highlight a bunch at once. And then we'll add data-ID equal to square. Okay, so now we have a stable selector on all of these. And what we can do here in our selectors is say, let's say squares, and we'll say document, but instead of query selector, we're going to do query selector all. So we want all of the elements that have a data ID of square. And if we go to the init method and just console.log app.$squares and look at that in the DOM, you can see that we have a node list which has all 9 of those squares represented here. Now the last thing, we don't have a unique ID on each of these. We of course have an index to our array, but it would be nice if we just had an ID so that we had kind of a coordinate to map this to. So one way we can do that is to just click here and go down to each of these and give it a basic HTML ID property or attribute. Okay, so I'll start all of them with 1, and then we'll just go down and replace all these. So now when we select these, the node list is going to have an ID on each of them, so we know when they're clicked which ID that we're dealing with. So going back, we can add an event listener to all of these, but since it's a node list, we need to iterate through them. So we can say app.$.squares, and then we'll just do a for each. So for each square, this should be a node in the DOM. So we should be able to say square.add event listener, and then add a click listener. And then the event that is returned from there should give us an ID. So let's go ahead and console log square with ID, and then we'll interpolate event.target.id was clicked. So we can remove this console log, and now what we would expect is every time we click them, we will get the ID back of the square that was clicked. So this one should be square ID 1. This should be 9, so we're going 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's click 1, and you can see square with ID 1 was clicked. Go down here, square with ID 9 was clicked. So that's a pretty simple way to register an event listener there for each of those squares. So now going back to our initial question that we had asked, let's go over to what actions can a user take in the app. We came up with 4 of them. A player can make a game move, new round, reset current game, and toggle menu. And if we now look at our init method, we have 4 events that are being listened to on different DOM elements. So one organization method that we can use, instead of putting this all in the init method, we'll leave the init method there and define a new one. And let's just call this register events or event listeners or something like that. And this is just going to be an organizational technique here where we can just put all of that same type of functionality within that method, and then we'll keep the init method pretty clean. So all we'll say is app.register event listeners. So now what's happening is when the window loads the document, we're going to call init, and init is going to register all of those event listeners for us. And if we go back to our app, we should be able to toggle this, reset the game, new round, and then click any of these squares and get an ID returned from the squares. So at this point we have a template for our application, and we've stubbed out some methods that we're going to need to implement. So as you can see here, we've got this one done. This is toggling the menu. So we'll call that done. I'll just add some comments here so we can track. This one is going to be a to-do item because we have not implemented what happens when we reset the game or add a new round. And then this bottom one is also to do, but this is probably what we're going to work on next. But speaking of what to work on next, that is a really good question as you're building an app like this. How do you know what comes next? Well, in this case, we can kind of go through the process of elimination. With these actions, reset and new round, those are not going to be possible to implement until we have a functioning Tic Tac Toe game that we can actually reset. So let's go back to our notes here, and I want to take a minute to go off of this point here. Let me get my arrows worked out here. I'm not super familiar with how to use this quite yet. So we're going off of this point of player can make a game move. So the next question we've got to ask is, what is a game move? Well, there's a couple considerations that we'll have to think about here. One being, how do we determine who is up? Who is the player that is up next? So let me add that as a requirement here. Who is currently up? The next thing we want to know is, did the latest move cause a tie or a game win? And then we also want to know who won, or was it a tie? And then what else can we think about here? Let's go to our final refactor, the one that's actually working here. Up here, this is our question of whose turn is it? We need to know that so we can display that. We also need to know that so we know which icon to display when it's clicked. And then as you see, we have a modal that pops up when someone actually wins the game. So we need to know when that happens. And then at that point, when we click play again, we need to be able to reset all of the state to a blank, fresh game. So those are the main questions that we have to ask. So who is currently up? This is for the turn indicator icon to play. And I think that's pretty much it. So we'll take these step by step because it's kind of tough to think through all of this at once. As you get more advanced in building these things, you can probably map all of this stuff out from the beginning. And that's kind of my first step when I'm building this, is trying to map out what does the state of this application require and what do I need to track. One thing I'll add here is also the question of what state do I need to track. So we'll talk about this concept a little bit here in a minute, but I'm going to kind of organically talk about this throughout the rest of the video because it's quite challenging at times if you're not super familiar. So when I say state, I'm really just talking about, what does the current state of the game look like? So that might be things like current player, might be total wins by player. We can also track total, can't type here, total ties, and then prior game history. Those kind of things are the things that we'll want to track. And to do that, we're going to just build this, step by step, and we'll eventually come to some sort of model that we'll use to track that state. So not going to talk too much about that at the moment. Let's dive in and start building this out, and you'll start to see how this makes more sense in a minute. So the first thing that I'm going to do is try to implement a basic move. So in other words, I want to display an icon in these squares when they're clicked. We're obviously already registering an event and getting the ID of the square that was clicked, so that is useful to us, but we need to change the DOM or the UI when that happens. And to do that, the first thing I will generally do is go to the HTML and just mock something up. So just figure out how to statically display that for the first time. So I believe all we're going to need to do is put in an I tag with a class, and then that's going to be one of our FontAwesome icons. So let me just check my references right here to see which icon we're dealing with. Okay, so it really should just be FA solid is the base class, and then it's going to be FAX or FAO. So we'll simulate both of those here just to make sure that our game board is going to display things correctly. So FAX and FAO. And you can see that we've got those displaying correctly. So this is the right size. Obviously, these are not the right colors. If we were to open up our CSS, if you remember from earlier in the video, we had some of these shared classes here at the top somewhere. And in these shared utility classes, I gave us a yellow and a turquoise class, just so that things are a little bit easier to deal with and easier to remember. So what we can do is just pass in yellow and then turquoise into that class list, and then our X's and O's will be the right color. Now obviously you can see we've got mismatches just about everywhere. We'll get that worked out in just a moment. So if we're trying to do this with JavaScript, obviously we can't just statically put in these different icons. We're going to basically build these elements and add them as children to the appropriate div that has been clicked. So what I'm going to do is open up app.js again, and right down here in our event listeners for each of the squares, I'm going to just copy over this HTML and add it as a comment. And that's just for reference so that we can look at it and translate it into JavaScript. So we've got FAX and then FAO. These are the two that we're dealing with. So we can get rid of those here in the HTML. And then in app.js, we know which ID was clicked. and the event itself carries a target which represents the individual square that was clicked. So what we could do, just to start us out, is actually derive that, or not derive, but create this I tag. So let's call it an icon, and we can say document.create element is one of the built-in browser API or DOM methods, and we just need to give that a tag of I. So we've created the element, and then we can say icon, or I'm sorry, not redefining it. We can say icon.classList, and then I believe we can just add an array of tokens, and that would be the classes themselves. So we would want to add FA solid, FAX, and then let's say yellow. So we're just kind of hard coding an element. We'll hard code a yellow X in this case. And then from here, we've created the element, but we need to insert it into the target that was clicked. So really what we could do is just say event.target.replace children, and then I think we can just pass in the icon. So that should work. Let's go ahead and click. You can see something's going on, it's not working. So let's inspect. You can see there's some sort of content in these div elements, and it looks like our icon class or icon element has been added, but the class list has commas. So we need to not do it that way. We're not supposed to pass an array, I guess. Maybe we're just supposed to pass multiple arguments. Let's try that. Okay, so that's working better. And now you can see that the content within here, or where did we go? The content within the one we clicked has the correct class list now. So now, anytime we click any of these, we're going to get a yellow X. And obviously this is not useful yet. We're just filling them up with X's. And if we click them twice, we also can have problematic behavior because we're not checking to see if there's an X already there. We're just adding it no matter what. So that is problematic, but at least we've got something working here. So ideally, what we want to do is know whose turn it is, and then depending on that turn, we'll choose either FAX or FAO, and then the yellow or turquoise color. And at this point, we've finally reached a place where we can start talking about what state is and what state management really represents here for us. So to do that, I'm going to pop over to the whiteboard again, and we're talking about game moves and what state do I need to track. Well, I think the next question really is, what is state? Well, there's really two types of state that we can talk about. So we have client state, and then we have server state. And these are very loose terms. So there's a little bit of an overlap between the two, but these are the two kind of categorizations that I would be using. So when we're talking about client state, the way that I think about that is any sort of state that we have within the DOM that does not need to change anything that is persisted long term. So I guess that's a complicated way of saying something like this actions menu popping open and closed. Every time we open and close this, the client side state is changing, but we're not actually doing anything, to persist that change. So if we opened this actions menu up and then refreshed the page, it's going to close every time because we're not tracking that state across browser refreshes. It's just temporary in-memory state that we're tracking. So in other words, client state, a good example of that, let's just make an example over here. Let's add some code here. So let's say client state equal to, and make this hopefully was going to get that a little smaller, but let's open up some brackets. So client state might be something like is menu open, and we'll start that with false. And so as you can see, when we click this menu, that state variable is going to update. It's going to be either open or closed, true or false. and that's not going to persist across browser refreshes. Now, server state, and server, again, is kind of a loose term here because we don't actually have a server. We're going to be working with local storage to kind of emulate that. But generally, server state is kind of what you would think of as a database. So it's a snapshot in time. It's a snapshot of what the current data looks like. So this would be more conducive to something like a game move. So we could copy this down. And we could say server state could be something like current player. And let's just put an ID in there. Let's say player 1 is the current player. And then we could also add things like, we've got the current player. How about the history of games? So we might have an array filled with all the different games that we had played in the past. We could also track things like, the current game. So this might be an array of game moves that have happened, and that way we can track across browser refreshes, who has moved in which square. So these two types of state we're going to need to track, and we're going to eventually refactor this to be a little bit more stable. But as I said in our kind of game plan over here, in this video progression, we're doing everything in one file as a naive approach, and then we're going to refactor it to be a little bit more stable. So what that looks like for us in terms of state, I'm just going to create a state property on the app. Okay, and to start out, state is not going to be persistent across browser refreshes because this is just a variable, and every time we refresh, this is going to be reinitialized and reassigned. So the first piece of state that we want to track is current player. And for now, I'm just going to keep things very simple, and we're going to say that each player is represented by a number. It's going to be either 1 or 2. So we'll say that player 1 is going to always start the game. So we'll track the current player, and that alone will allow us to decide down here in our event listener which icon that we need to put in the square. So obviously we need to update that state each time a move happens. So if we were to, we'll leave this console log here, but every time something is clicked, what we're going to need to do is say the current player is going to be equal to app.state.currentPlayer. Now you don't need to save that to a variable. I'm just doing that to kind of be a little more clear here. And then we're going to say if the current player equals 1, we're going to add a certain element to the DOM. Otherwise, we'll just assume there's only 2 players here. We'll add a different one. So in this case, let's just say that player 1 is going to be a yellow X. So we can create the icon no matter what, because it doesn't matter, that's not styled at all, but the class list is what we're going to use based on the player. So if it's player 1, we're going to have a yellow X, and if it's player 2, we're going to have a turquoise O. So we'll put in turquoise right there. But the thing is, we need to, of course, update that state every time this move happens. So we'll go ahead and create this icon, add the class list, and then what we're going to do here is say app.state.currentPlayer is going to be set equal to whoever is not playing this move. So in other words, if let's say the current player is 1 and has created, this class list, so we're going to say if the app.state.currentPlayer equals 1, then we're going to set the current player equal to 2. Otherwise, we're going to set it equal to 1. So in other words, it's sort of just a toggle on who's playing the game. And then finally, we'll take the event target, which is the square, and replace the contents of that square with the appropriate icon. And so next time this is clicked, we'll know which player to use. So I'm going to also log this up top. We'll say the current player is, and then we'll say app element.state.currentPlayer. So we can get rid of these down here. And then there's one more important thing. As you saw earlier, we can't play in a square twice. So we need to know if the square already has some sort of element within it. Let's go ahead and just save this and see what we're dealing with now in our game. So we'll click a square, and then the next one should be an O, and it is, and that's because we've updated the state every time we see a new play. Now I think, if I'm not mistaken, what's going to happen if we click this twice, so let's say that we click this square again, it's going to add an X next to the O, which is obviously invalid. And now it's going to think that the O's turn is up, even though X should still be up because they played in the wrong spot. So that's obviously a problem. And the way that we fix that is basically putting a check within this click event. And we're just going to say, is there something in that square? And if so, we're going to return early, and we're not going to allow the player to actually play. And this will prevent us from updating the current player in state, and it will force them to replay before the next player can go. So the question is, how do we check that? Well, we're going to eventually do this to be, we're going to eventually check this in a much more stable way. But for now, I'm just going to keep things simple. We're going to go to MDN and go back to the element reference. So elements reference, oops, I clicked the wrong one. I just want literally the element class. So which one is that? I think this will work. So we've got element.getAttribute. Now we can look through all of the different methods that are available on an element, and there should be one to check if there are children already within that element. I'm not finding it here, so I'm just going to search what I know here. Has child nodes, and we're not finding it on element because it exists on the base class of node. This is like the abstract base class upon which many other DOM API objects are based. So basically any element, as it mentions here, will inherit all the methods of node. So we can use this hasChildNodes method, and this returns a Boolean value indicating whether the given node has child nodes or not. In other words, what we can do here is the first thing we do is say if event.target.hasChildNodes. So if there's any X or O in there, we're just going to return. We're not going to update anything. We're not going to update the state. We'll just return from that function early. So by adding that, I believe we should get the desired behavior here. So we'll click 1, click 2, and then try to click this one again. And it's not working. Let's see why. So I had to pause the video to figure out what was going wrong here. And it's a little bit tricky, bad programming on my part, but basically what happened here is when we clicked on the icon itself, you can see if I like specifically click on one of these icons, it's going to continue adding icons. Now if I click somewhere else in the square, it's going to have the correct behavior. And what's actually happening here is the event target, so right here, is going to represent what was actually clicked. So the element that was actually clicked in the DOM. Now the square up here is going to represent the square that we're actually looking to target for this behavior. So if I were to console log this, let's go ahead and say console log, we'll say the square, and then we'll pass in the square itself, and then we'll console log the event target, and then we'll pass in event.target. Now what you're going to see is as we click right here, the square is going to represent that div, and the event target represents the div because we clicked on the same thing. Now if I put the mouse in the middle of that icon, remember we now have a new HTML element right here. If I click that, it's going to register the event target as that I tag rather than the div. So what you'll see here is that the square and the event target will not match up when I click this, and we'll have that weird behavior. So you see the square is the div and the event target is the actual icon. To make this behavior more stable and just better programming practice in general, we should be updating the square element itself and not relying on the event target, because we can't control whether the user is going to click the icon or the square. We need it to work no matter what. So let's remove these console logs. And then instead of checking whether the event target has child nodes, we're going to check if the square has child nodes. And then furthermore, where we're replacing the children down here, we don't want to replace the event target's children. We want to replace the square. So that will make all of this behavior a lot more stable. And when we save this, we should be able to click in any square as many times as we want. And you can see our console log is going to say the current player is 1 still. So if I'm clicking any of these, the turn is not changing. The turn only changes when the player clicks a valid square, and then we're going to have a different current player. So we've got this working. This is kind of some boilerplate for what we're going for. We will refactor this to be a little bit more stable, some better practices, but for now this works just fine. I'm going to clean this up. We don't need these console logs anymore. The next thing that we're going to need to do is, if we just keep clicking these and playing the game, you can see when the O player, I think that's player 2, when they win the game, nothing happens. And that's because we haven't programmed anything to happen. So we need a way to detect when this game ends. And there's going to be different patterns that represent a winning game. And then of course we can also, if we refresh, reset everything, we can also end up in a tie. So I believe if we, let's see if I can even produce a tie here. Requires a little bit of thinking to do that. So in this case, the game should be a tie, and we should be able to recognize that. Now, there in the original project that I was refactoring here, they had a pretty nice way of handling this, and I want to highlight that. So if we open up main.js from the original project, what they were doing to check whether the game was won is they had basically an array of winning patterns. And they were basically just checking which squares were currently had plays in them, and did they match these winning patterns, and that's how they would determine whether the game was a winning game. So I'm going to copy this array here, and I'll show you how we're going to use this. So let's start writing some comments here because our method is getting a little bit large. So check if there is already a play. If so, return early, because we don't want any turns to change or anything like that. Then we'll come down here and we'll get the current player. We'll create the icon, and we will add that icon to the div right down here. And then the next thing that we need to do is, well, let's actually put a comment here. Determine which player icon to add to the square. And then finally, check if there is a winner or tie game. Once again, we're going to refactor all of this, so I know it's getting pretty busy in this method. We're going to refactor it. I'll show you a better way to do this. For now, we're going to paste in those winning patterns. And so the question becomes, how do we know the current state of this game? How do we know what squares have been played in and which ones have not been? And furthermore, which player has played in each of the squares? Now, we could, of course, do some elaborate check where we basically say, we search the current square, we check if it has anything in it, and then we could maybe check the class list and check if it's an FAX or an FAO, and then basically loop through all of the squares on the board to determine what the current state of the game is. But what's a lot easier to do is to just track that in state as we go. So rather than doing this sort of check, we can just check the state. But first, we need to define what that state is. So what we'll say is that we need to track an array of game moves. And those game moves are just going to be the player that has played. So what it might look like is something like this, where we have, we need to track the square itself too. So we're going to say the square ID is going to be 1, and then the player is going to be 1. So that move right there would represent if player 1 clicked this top left square. So we basically are just tracking a square ID and a player ID in the moves array. So let's empty that out. That's going to be our default state, is an empty game. And then down here within this event listener, as you can see, we're updating the current player in state. But what we also want to do is we want to push a move to state. So app.state.moves, and then we want to push a new move that is going to be an object with a square ID. And let's just reference the square itself, or we could also say we'll just say the square.id. And this needs to be a number, so we'll add a little coercion there to make that a number type. And then the player, we'll just call it the player ID just for consistency. That's going to be equal to the current player of the game. So we've already updated the current player right here to be the next player, so we need to actually put this state update right above that so that the current player is right. So we'll say, I don't know why we're checking this right here. We've already extracted that there, so let me refactor that real quick. And then we can put current player right there. And then just for us to see what's going on here, I'm going to console log app.state after those updates have happened. At the moment, this isn't going to change any of the behavior. We're just tracking another state variable. So let's click something, click another, and you can start to see we're building up state. We're building up an array of moves. And you can see that square ID 1 has a move from player ID 1, so the X. Square 2 has a player ID of 2, an O, and square 3 has a player ID of 1, an X. So you can see as we add moves, we are adding to that array of moves. Now what's interesting about this is that we can also derive some state here. We can simplify things a little bit. So if we go back up to our state, you got to ask yourself, well, who is currently up based on the number of moves that are in that array? We actually don't need to track the current player because we will be able to derive that based on the moves that have been played. So let's actually delete the current player from state. All we really need to track is moves. And I'll show you how to derive that right here. So the first thing that we want to update is, let's see, the current player variable right here. So what we can do is we can say if app.state.moves .length equals 0. So if there's been no plays at all, then we're going to say the current player is 1. We'll just always say that the current player is 1. They start the game every time. If it is not equal to 0, then we're going to check for the last move of the game, so the last element of that array, and then grab the player who is opposite of that player. So this is going to require a little bit more logic than we have right here. So I'm going to break that out. So we'll say the last move is app.state.moves, and then you can use a little convenience method. You could, of course, check it by saying app.state.moves.length -1. That's a typical way that you could grab the last element of the array, but there's a more concise way with JavaScript. You can just say @-1, which will grab the last element of that array. Now, of course, we don't know if that array has anything in it, so that could be, I believe, undefined if there's nothing in the array. So now we can come down to the current player. We can say if the length of the array is 0, we'll go with 1. Otherwise, we're going to grab the last move, and that move has a player ID in it. So it's going to not be the player ID of the last move, it's actually going to be the opposite of that. So what we can say is a little convenience method, get opposite player, and we'll just pass in a player ID, and we'll say if player ID equals 1, then we're going to pass in player 2, otherwise 1. So we'll say get opposite player of the last move. Sorry, this is getting a little complicated. We'll break this out into some helper methods later. But basically what we're doing is we're finding the last move. We've got a helper method that gets the opposite player, and then we're checking to see if there's any moves. If there's not any moves, then player 1 is up because it's the beginning of the game. Otherwise, we're going to get the opposite player to the last move that was played. And that will give us our current player, and that way we don't have to track any of that state. And that should flow down to here where we're checking and adding moves to the game. So let's save that and see if it works. You can see that we're alternating, and we can click on these as many times as we want, and it's pretty stable. Now there's one more thing that we can do now that we're tracking the game moves. We don't really need to check whether the square has child nodes because that's really relying on the DOM itself. It would be better just to express what we're trying to do to check the state of the game. So let's say we need a helper method called hasMove, and what we're going to do is just define a function that takes a square, or actually a square ID, so that'll be a number, and then we're going to just basically return, or we're going to say existing move is equal to app.state.moves, and then we're going to look for that square ID in that array. So we're going to call find, and we're going to look at the move and check if the square ID matches the square ID that we're passing into this helper function. And then we're going to return the existing move does not equal null. And that's another way of saying does not equal undefined or null. So we could also say does not equal double equals undefined. Okay, and that will give us whether there's a move. So now we can replace this with hasMove, and then we can just pass in the square.id and make sure that's a number so that it's comparing the same type. I think if we got this right, we should be able to click squares multiple times and it will not do anything, which is telling us that our check has worked okay. So at this point, I know that we've done a lot of refactoring and it seems like for nothing, but the goal of this is whenever you're tracking state within an application, you want to keep it as simple as humanly possible. And the reason being is, as we've seen down here, where we're actually updating the state to the current player, which, by the way, we can get rid of now because we're deriving that information. But when we update state, as we're doing here in the moves, pushing a move to the array, every time you track something in state, you also have to update it somewhere. And the more things you track in state, the more updates you're responsible for, and therefore the more possible errors that you're going to introduce to your application. So the goal with tracking state is to keep it as simple as possible so that you have the least number of variables to keep track of over the life cycle of your application. In this case, all we're doing is tracking an array of moves, and then from that little piece of information, we're able to then derive who is the current player. And from that, we can then, update state to make another move within the game. At this point, we've refactored our state and we're updating it to just have an array of moves, which allows us to derive pretty much everything that we need to know about the current game. Now, the next thing that we need to do, that we can now actually do with this state, is find whether someone has won the game, or if it's a tie, or if it's still in progress. So what we're going to do is actually make a utility function for this. And I'm going to add this just at the top. And this is not going to be the final destination of it. Actually, we could even just put it within the app, but we'll probably rearrange this in the future. So what we want to do is call it something like get game status. And this function is going to take an argument here. So what are we going to pass in will be an array of moves. And then we also probably need, well, I think that's pretty much all we need. We just need an array of moves, which is tracked in state. So with that array of moves, we should be able to give a couple pieces of information. So we'll define the return value of this just to start. The first thing is going to be the status, which this can either be, we'll call it in progress or complete. So we will put a placeholder in there for right now, but this will become dynamic. And then we will also give a winner, which again, we'll put a placeholder in there, but this is going to either be 1 or 2. So player 1 or player 2. And then also it could be null, which would represent a tie. So that's kind of how we're going to represent this. And based on these two pieces of information, we should be able to know whether the game, what to show in the UI, whether we show the modal that pops up and gives the result, or we keep playing. So to do this, the first thing we need to do is get player 1 moves. And the moves array that we're going to be passing is the entire game. So all we need to do is filter that and then check on each move whether the player ID is equal to 1. So that will give us player 1 moves, and then we can copy that down and change the ID to get player 2 moves. From there, we should be able to bring up our winning patterns. So this will now come up in that utility method. We'll paste that right there. And what we want to do is loop through each of these winning patterns and check if either of the player moves have all three of these within their array. And if all three of them match, then we know that one of the players has actually won the game. So the way we can do that is start out by saying the winner equals null. So we'll just assume to start that there's no winner. And what we'll do is map through the winning patterns. So we'll do a loop, a for each loop, and we'll call each of them a pattern because this variable will represent one of these arrays. And then we'll break that down into a function that will check for this condition. So we'll say player 1 wins, and that is only going to be true if every value within the pattern, so we'll just say v for value, we'll say player 1 moves includes that value. So again, we've got player 1's moves, the array of moves they've made, and then we have an individual pattern. And if there's 100% overlap between player 1's moves and a given pattern, we know that they've won. So the same thing can be said about player 2. So we can copy that down again and just update that array. And that should tell us whether each of the players have won. So then we can write an if statement, and we'll say if player 1 wins, then we just update the winner to be equal to 1. So that's their ID. And then if player 2 wins, we'll update the winner to be equal to. So in theory, this should only be one player that can win. And if we don't hit a true condition for either of these, then the winner will stay equal to null, and we'll just assume that's a tie if the game is complete. So we come down here, and instead of hard coding that, we can just remove that, and winner will be assigned to this variable right here. So that's either going to be null for a tie, 1 or 2. And then the status of the game is going to be in progress if there are either no winner or the game moves does not equal 9. So if we look at our game, there's 9 squares. So if all of them have a move, then we know that the game is over. So that will be our first check. We'll say if the moves.length is equal to 9, then we can say that it is going to be a complete game. Otherwise, it will be in progress. Now, we of course need one more check here. So if the moves.length equals 9, or the winner does not equal null. Yeah, so we're checking whether the winner does not equal null, because that would represent that someone has won before the game reached a final state of 9 plays, which would be a tie. So that will help us figure out what the status is. So now with this utility function, getGameStatus, we can come down here, and where we're checking if there's a winner or a tie game, let's just assign that to a variable called status. So we'll say app.getGameStatus, and then we will pass in the app.state.moves. And that's going to represent the newest array of moves that has been played. Let's console.log that status just to see what we're dealing with. And let's play a couple moves. So you can see the status is going to print every time. So our game's in progress, there's no winner, still in progress. And then this click right here should change the status. And you see that it doesn't, and we'll have to check out why, because that should have updated to complete and populated a winner of player 1. So let's go ahead and check that, see what is happening here. Just to debug this, let's go ahead and just do a classic console log. This will be quite a few logs because we're going to be printing on every pattern here. So let's just console log the pattern, and then player 1 moves and player 2 moves, just so we can get that in one big object. And then we'll play all these moves, and then right here, this is where we should be getting a different result than we're getting. Oh, and I can already see what's happening here. So what we did wrong, what I missed, is when I was filtering the player 1 moves, this is just going to give me the entire move. So if we print that out to the console, what you'll see is in this array, we're printing an object with a square ID and a player ID. And when we're comparing that down here in the every utility method, we're actually comparing a number, which is the key of the square, to that object, which will never equal each other. So what we really need to do is actually add a map utility at the end, and we're going to map that move to be a number value that is equal to the square ID of those moves. So now if we print this out into the console, player 1 moves, this should represent an array of numbers now, as you can see, representing the coordinate of the plays. So this should be 1, 2, and then 1, 2, 3. And now you can see that the status is complete and the winner is equal to player 1. So our utility method seems to be working. Let's reset the game and try to tie the game. So let's mix this up here. Oops, I accidentally won. It's kind of hard to tie this game. Okay, so now we've got a tie game, and you can see that the status is complete and the winner is null, so that should tell us that it was a tie game. So now we can implement that logic down in our event listener. So down here at the bottom, where we're just console logging the status, what we'll say is if the status equals complete, then what I'm going to do is just make an alert in the browser. So we'll say if the status, this should really be status.status. So we should probably rename this variable. We'll say game, and this will be game.status. And now we'll say if the game has a winner, then we're going to alert player winner wins. Otherwise, we know that it's a tie, so we'll say tie. Let's try this out. So let's go ahead and make player 1 a winner. It says winner's not defined for some reason. And that's because I'm not referencing it correctly. Try that one more time. And there we go, player 1 wins. So kind of small, but you can see now we've got the essential functionality hooked up. And at this point, I think the next step is to trigger that modal to open when someone has won the game or there's a tie. But before we do that, let's just recap what this big long event listener is doing. So first, we're looping through each of the squares on the game board, and we are adding a click listener to that square. When that square is clicked, all this code is going to run. So the first thing we'll do is check if there's a move already present within that square. If there is, we're going to exit early and not do anything because someone can never play twice in the same square. Once we get past that, we know that there is a valid move. So we're going to check who moved last based on the state. We're going to then get the opposite player of that last move and set the current player of the game. We will then take and create an icon, and based on the player who is up, we'll add an X or an O as an icon, and then we'll put that in the DOM and we'll add that icon to the square. We'll also push a move, a new move to the state so that we're tracking the history of moves in the game. We'll then check the game status after that move has happened, and if the status is complete, we then know we can do something and open a modal to explain whether someone has won or if the game was a tie. And now our goal is to open that modal and give the user an action to actually reset the game and start over. If you remember from our index.html, when we built this a couple hours ago, you'll see down here with the modal, we just have that hidden class sitting on there. And if we remove that and save the file, you'll see that we get this dialog to open, and it's going to cover the screen with a play again button. So the things that we have to do is, number one, we have to trigger this to actually open and then close when we're done with it. And number two, we have to add a click listener to this button right here so that when someone clicks play again, the game state has reset and everything goes back to the beginning. So let me add this hidden class back because that's our default state. And as I said, this is going to be refactored at some point. We've got a lot of code all sitting in one place, which is going to be hard to follow long term. But at the moment, we're just putting everything in one method, keeping it simple so that we don't have to refactor anything quite yet. So the way that we're going to do this is first add a selector to this modal. So just like we've done up here with, let's see, we've given data IDs to the elements that we're going to select and control with JavaScript. So we'll do the same thing with this modal. Let's just call it modal, and then the modal contents, we'll also give it a data ID. And we'll set that equal to modal contents. And what we're going to do here, let's see, we're not going to put it there because we don't really need to control that. We need to control this text element. So data ID equals modal text. And then this will be the data ID modal button. So you don't really need to add these data IDs to all of them because really you could just select the modal and then grab those elements dynamically. I'm just being pretty explicit about it just for clarity. So let's go ahead and select these within our app because that's kind of what we've been doing, just collecting all of these elements that we've selected. So let's copy this down and we'll name this one modal. This data ID will be modal, and then we'll say modal text and modal button. And as you can see, we're doing a lot of repetitive stuff here. So if you're thinking, this will be refactored too, to be a little bit simpler and to eliminate the need to write all of this boilerplate out, but I'm leaving it here now because it's pretty clear what's happening. So now that we've got these three, we can pretty much control them down here in this check on the game status. So if the game status is complete and we have a winner, the one thing that we know we need to do is print to the modal who has won that game. So let's just say app.$, because that's our namespace for all of those elements. Actually, first we need to open the modal. I'm sorry. So if the game's complete, we know that we need to open the modal. So modal, and then what we're going to do is look at the class list and toggle the hidden class on that. But to be a little bit more explicit, since we know that we're opening it here, rather than toggling the hidden class, which could work there, what we're going to do is actually remove, we should be able to say class list.remove that hidden class. So let's try that first. Let's make sure that that's working. So someone wins the game here, and it says modal.classList is undefined, so we messed something up here. Oh, and the problem is we're using query selector all, because that's what we had for squares. This should just be a basic query selector. So now I believe this part should work. So let's win the game for someone, and we get the alert, but we also get the modal. So let's remove this alert for the moment because it's kind of getting in the way. But now that we know there's a game winner, what we can do is we can say that the text is going to be equal to player, and then give the game.winner, so that'll be the ID. So that's the message that we want to put, so let's call that message actually. And here, our message is going to be tie game. And then all we have to do, we can actually extract that to a message up here. And then assign that there, and then no matter what, we're going to say app.$.modal text.inner text, or is it inner HTML? I can't remember. It's not inner anything, it's text content is equal to the message. So let's save that and see if that works. So someone's going to win the game here, and it's player 1. Now let's refresh the page, and this time let's let player 2 win. So player 2 wins, and you can see that dynamically will populate. Now the last thing that we need to do is put that click listener on the play again button. We're not going to do that in this method because remember, we're registering our event listeners all at the top level of this function. So let's just put that right here. We'll say app.$.modal button, add event listener. We're going to listen for a click event, and then with that event, all we're going to do is set the state.moves equal to an empty array because we want to reset the game. And then we also want to close the modal if it's open. So the way that we'll do that is app.$.modal, and then class list actually not remove. We want to add the hidden class back. So that will hide the modal. So now that should be hooked up. And if we go through the game, someone wins, and we click this button, it closes it, and you can see there's still game moves here because resetting the state doesn't actually change the UI quite yet. We will refactor that at some point, but at the moment it does not. So not only do we have to reset the state, but we also have to loop through each of those squares and empty out their contents. So let's see how we would do that. Is we would say app.$, squares, and then we'll say for each square, we're going to say square.replace children and just leave that empty. And that's just a shortcut to clear everything out of those squares. So now let's go back and try it one more time. Someone wins the game, we click play again, and everything has cleared. So we now have a functioning tic-tac-toe game. Player one wins again. Let's see if we can get a tie here. You have to really think about this one to get a tie. Let's see. That should work. Okay, there's a tie game. Play again, clears it out. The last thing that is not working here is this turn indicator. You can see that no matter what we play, it's just staying the same, and we obviously want to update that. Now, a great place to do that is going to be within this super long event listener for each of the square clicks, where we're updating the current player. So we'll actually do that in this if-else statement. But first, we have to grab those elements that we want to update. So let's find the turn indicator. And you can see right here, this is where we're doing it. And we've got an icon that we need to update and some text that we need to update. So here what we're going to do is add a data ID and call that turn. So we'll now go select that in our list of elements. So we'll say turn and then just copy this down again. And one thing that we need to do here that I kind of missed is we've got the turquoise class set on the individual icon, but we want these both to match. So it would be a little bit easier if we just put that up here on the turn element, and we also need to match things up. So the first player is player one, which we're just determining is going to be X, and that's going to be yellow. So we need to match those up. Let's save that and just make sure that this is matching now, which it is. So this is what we're looking for as a starting point. And now all we need to do is just toggle this from yellow to turquoise and back, and then we'll toggle the elements within it to indicate the turn. So we can do that here. One thing we'll need to check is get a little bit more clear on who's up next. So the current player represents who's actually clicking right now. Now the next player is going to be the one that we want to change the turn indicator for. So you've got the current player, and then we can say next player and reuse that get opposite player. I know we're a little redundant here, but we'll go ahead and use it. So this should represent it in the ID of the next player. Now we can come down here and say the turn label is going to be a new element. You could have replaced the element that's already there, but I'm just going to create a P element. And then that turn label dot inner text is going to be equal to player next player, is what we determined up there. You are up. And we'll copy that down. Actually, we can just put that right there. And then from here, we can just say app.$ and select the turn element. So remember, we're just selecting this entire div, and we want to replace the contents of it. So all we need to do is say replace children, and then we can pass, as it shows here, we can spread out parameters as individual nodes. So it will replace them in order. So if we want the icon to go first, we just pass that there, and then we'll pass the turn label. When we save this, let's see if we get the correct result. So I'll go here, and you can see that we're getting the correct text, but the color is not updating, and we're not getting the icon to also be added. I believe the problem here is we're actually adding this same icon to two different places, so we probably need to break that out into two separate elements. So we'll say turn icon, and then this will be the square icon. So those will be two separate elements. And down here, we'll pass the square icon. And then here, we'll pass the turn icon. And we, of course, want the same exact colors here, I believe. Or actually, no, these need to be opposite, because once again, we have the next player is going to be the opposite color of the current player. So we'll say the square icon and then we'll copy this down, and this will be the turn icon, and this will be the exact opposite. So this will be the O, and it will be turquoise. And this will be turn icon with an X that is yellow. Once again, we are going to refactor this. It's not going to be this confusing and verbose here in the future. So hopefully this works. Now we're getting a lot closer. We have everything correct except for it looks like this text is always yellow. And it's because we're not setting the color of that. So we need to say the turn label dot class list, and let's go ahead and do that down here. So turn label dot class list, and we'll set that equal to turquoise to match what we're making the turn icon right here. And then we'll copy that down and make this one yellow if it's player 2. So now it looks like we're getting everything correct. So if we play an O, now X, player 1 is up. If we play an X, well, we've got to play again, but you can see that that is updating correctly. Now, as you noticed, if we end the game and player 1 wins, you'll see up here player 2 is up next, and that's their turn. And if we click play again, that's not going to reset. So we need to remember to reset the turn. And since we've coupled all of that turn logic within this event listener, we have no easy way to do that up here when we're resetting everything. So at this point, we've reached a place in our code where we've got a lot of stuff going on right in this method that we would like to be able to reuse in different places to like reset the state and whatnot. But right now it's very hard to do that. So the next segment of this video is going to be taking this code and refactoring it to look a little bit cleaner and be more reusable and easy to follow. So we'll go through that. But as of right now, we have a working game for the most part, as long as we refresh things and we can determine who wins the game. So once again, we'll refactor things, then we'll start talking about keeping this state for the scoreboard and then moving into the MVC pattern. So as we talked about, we've got the naive approach all in one file. That's what we're still on. We've been refactoring, iterating as we go, and then we'll end up with something pretty clean that we can reuse and extend into the future. So we've reached a point where our code is getting a bit confusing, and if we continued to add this functionality, so if we were trying to reset this turn indicator when the game ends, remember we've got a problem here, it doesn't reset, and then we also have to be able to reset the whole game and reset the round, track all of this state, the history of the games. There's a lot to do here, and given our current code, it's going to be very confusing to do because we've got all this stuff in one method. There's all sorts of stuff. We're updating state, we're updating the view, all in one spot. So this is where a pattern comes in and helps us out a bit. I waited until this point to mainly simulate a real life scenario where generally you're going to start off in one file just to understand the logic that you need within your application. And then as you go, you have to refactor to keep things clear in your head and to make the code maintainable. So at this point, we understand what patterns we actually need here. And that makes it a lot easier to introduce something like an MVC or model view controller pattern. Just as a side note, the MVC pattern is really relevant to something like Ruby on Rails. So if you typed Ruby on Rails and you go to the documentation, you'll start to see a lot of these patterns. And if we were, I'm introducing this not because I think you need to use Ruby on Rails, but more so because it's kind of the premier example of a framework that leverages this model view controller pattern and has gained a lot of popularity. So if we go to the docs, let's see if we go to the API maybe. That's probably not where we want to go. So as we're scrolling through the docs, you can already see there's a header section called models, then there's views, and then there's controllers. So they very explicitly build out this pattern. So this is just a good reference. You don't need to check this out. I just wanted to point it out. So enough theory here. Let's get into this. The way that we're going to build this model view controller pattern is actually by breaking this single file out into those 3 different responsibilities. And that kind of brings us back to our best practices. So whether or not you're using a model view controller pattern, there's other patterns that you could use. The main point here is that we want to separate logic by responsibility. In other words, this is the separation of concerns principle that is just a good programming principle in general. It's something that you would always want to try to aim for no matter what pattern you're using. So let's jump back over. We've obviously got quite a bit of functionality here that we don't want to have to completely redo. A lot of this is good stuff that we've worked out, but we do need to refactor this into a couple files. So in our JS directory, I'm going to add a new file, one called the View.js, one is going to be called Store.js, and this will actually represent the model. I'm just calling it store because it kind of represents the storage that we're using. You could call it whatever you want. So we'll call that store. And then app.js, this is really going to be our quote-unquote controller. It's not a super explicit adherence to the pattern, but we're getting very close, and the goal of a design pattern is to make things easier for you, so you don't need to follow it so rigidly that everything matches up one-to-one. As long as it's useful, it is going to be okay. So as we go and build this out, I'm going to be kind of looking up here to my other screen because I've actually, as you know, I've already built this app out in preparation for this video, and I just want to make sure that this live build that we're doing matches up with the final code that you're going to see in the GitHub repository that is linked in the video description. So that's all I'm doing, just making sure that I'm naming the methods the same, so on and so forth. So what we need to start with, I think, is going to be, let's go ahead and do the view, because that is what most of this logic we have in our application is pertaining to at the moment. So let's open up View, and we're going to be jumping into some object-oriented programming concepts here. So that's just another way of saying we're going to be working with some JavaScript classes, and specifically ES6 syntax for classes. I'll try to point out some of the syntax that I'm using and what it means, but if you are not at all familiar with classes and what they are and how they work, I would recommend brushing up on that, pausing the video, and just reading a couple, overview guides just to get yourself a little bit up to speed. That said, I will try to explain things as we go, and I'm not going to assume that you have any sort of advanced knowledge here. So we'll walk through it together. So the first thing that we need to do in our view is define that class that we're going to be using. Now we can call this a class of view, and that's really all the syntax that we need. We of course will use a constructor. This is kind of the initialization of the class, and it belongs on, it's available on any class that you use. And then furthermore, we're going to start to bring over our methods. So there are things that are available on the class instances called class properties, and that's where we're going to store those elements that we had defined earlier. So we'll just initialize the $sign to an empty object, and we'll start populating that here in a second. So the first thing that we want to do in our class, and we'll do this in the constructor because we want all of these elements to be selected when the class is initialized. So we'll go back to our app.js and we'll take all of these selectors that we've used and we will assign them in the constructor. So we'll have to update some of the syntax here, but really we'll just click down and select a bunch at once. And what we'll say is this $sign dot whatever the variable is, because we are basically referencing, when we say this, we're referencing the class instance itself. And on that class instance, we have defined a property, which is the $sign. This could be any variable. We're just using a short namespace for easy way to access. And so what we're doing is we're saying the class instance, the property that we want, and then the another nested property that will represent the element itself. So now instead of colons, we'll need to set those to equal signs. And then we'll hit Command S to format things and save it, although we've got some commas here at the end that we need to get rid of first. Now we can save it, and Prettier will format this for us. Remember, as I mentioned earlier in the video, I've got format on save set up with the Prettier extension in VSCode, so that's why it's saving like that and formatting everything. So at this point, we've got our basic class, and when it initializes, we're going to select all the elements in the document. But just having this alone, it's not going to actually work quite yet. We need to connect this to our app.js. Furthermore, we're not going to really need this namespace anymore because we're going to be working with, or we may use the namespace, but we're going to be moving pretty much all of this code out. But in order to do that without completely breaking everything, I'm going to leave all the code intact. It's just a good way to do it when you're refactoring something. You want to leave the original code intact and just build the new code side by side, and then you'll replace it at the end. But since we're not going to have any of this code here anymore, what I'm going to do is build this side by side, and we're going to just make a standalone function called init. And yes, this is in the global namespace, but this should really be the only thing, this and maybe one other variable that we'll put in the global scope. So that should be fine. And what we'll do in the init method is basically initialize the class itself. So we'll say the view is going to be equal to new view. So that is going to make a class instance of this class right here. And then what I'm going to do just to test things is console.log view.$, and then let's just say turn, because that was one of the elements that we selected. In other words, we're just testing to make sure that this was initialized correctly. Furthermore, we want to duplicate this event listener. We will eventually remove this once we've refactored everything, but for now, we just want to use this init method when the window loads. So let's save that and then go back to our browser. Let me get these tabs organized again. Okay, so we'll go to our browser here and go to the console. And it's going to say uncaught reference error, the view is not defined. And there's a good reason for this. It's because we have not imported that script. Now, obviously, app.js has been imported right here at the bottom, but we would also need to import the view.js for that to be defined. And if we come back now, you'll see that our console log worked because that's now defined. But let's go back and flip these. Let's put them in a different order. So we first load the view and then we load the app. Does it still work? Well, the answer is yes, and I believe that's because of hoisting that happens with JavaScript. But what's confusing about this is we've got these two separate files with different variables, and they kind of reference each other, but that can get confusing when you have more and more files. So one solution to this that will help us out quite a bit and allow us to just import one script is to use ES6 modules. So instead of adding this additional script import, which gets messy once you have 5 or 6 scripts, we're just going to import app.js. And then we're going to set a type attribute on the script, and we're going to name it module. What this is going to do is it's going to tell the browser that this script is an ES6 module, and now in pretty much every major browser, ES6 syntax is supported as well as modules. So this is a nice way to handle imports and exports. So now in app.js, rather than just referencing this view class variable, we can import that. So at the very top of our file, what we'll do is we'll say import view from View.js. Now right now this is not going to work. And it's not going to work because we haven't exported anything from this module. What we need to do is put an export, and then we want to export this as the default export so that we can reference it in our file just like this. Now if we left out this keyword of default, we would need to put this in brackets and reference it just like this. So if we did that, this should work. If we go to the browser, you'll see that this is being printed out, which is what we're doing here at the bottom. Right here, that's the console log. But I think it's a little cleaner if we just export the default, go back to app, and then remove these brackets, save it, and then we'll check to make sure this console log is working, and it is. Now, another property or feature of using modules is that by default they use strict. So if you've ever seen use strict in JavaScript, use strict, we'll look that up. Strict mode is something in JavaScript that used to be really relevant, as you had different files that would have different modes. Nowadays, you'll pretty much see strict mode on every file that you ever write, but this has a lot of useful defaults to kind of protect your code from all sorts of problematic patterns. So by default, these ES6 modules are in strict mode, which means that in the View.js, you might say, well, oh, this view is in the global scope, but that's not the case. We haven't actually attached it to the window. So if we were to go to our console and type view, it's going to say view is not defined. The only way that that would be possible is if we explicitly attached it to the window like this. So window.view equals view. And now we should be able to see the class that we've defined. But this is not what we want. And I just wanted to point that out as a feature of ES6 modules. By default, they're going to behave this way, and we're going to protect the global scope that way. What this also means is that our init method, if you remember from earlier, scrolling up, we had defined this app variable as the namespace around our entire app so that we didn't litter the global scope with all of these variable declarations. But now, if we try to access app at all, we're not going to be able to because it's in an ES6 module, and by default, that is not exposed to the global namespace. So that's basically why I'm okay adding this init method in the global scope, because I know that's not going to be exposed in the browser unnecessarily. So that's just a little tidbit, but let's keep moving here on our refactor. So looking through our app, let's also find other things that relate to the view. One of those things that is very relevant to just a view class is these event listeners. We want the view to register event listeners initially, so we can copy all of this over And in my final code, I want to see which method I put this under. So in my final code, each of these event listeners has its own method in the view. So I'm going to open up two code windows here and make it a little bit smaller for us. Hopefully you can still see that. And what we'll do is we'll basically take each of these event listeners and make it its own method within the view class. So just to stay consistent with my naming, we will call the first one bind game reset event. So that is the game reset. And this is actually a new pattern that we're introducing. Rather than handling the event listeners within the view, we want to do that in the controller. And the reason being is because the controller is going to read the current state of the application, and based on that state, it may have to do different things to the view. So you don't want to leave it just to the view itself to handle these events. So we are going to put a handler callback function passed as an argument to each of these event listeners. So we'll use some ES6 syntax to define this function. And then here we're going to actually register those event listeners. So I'll type out the first one just so you can see it slowly, and then we'll copy things over. So for example, let's look at this one. Or no, that's not a good example. We'll use the reset game here. So all we're going to do is reference these initialized selected elements that we have. So this $, which one are we selecting here? Reset button. And then just like we're doing over here, we're going to add the event listener, listening for a click event. And then in the callback, we're going to do something. But the difference here is instead of handling this in the view, we're just going to pass the handler itself. So we can just pass that handler from here down to this event listener, and then all of that is going to be handled in app.js. So let me add the rest of them. So bind new round event, pass that handler, and then bind player move event with a handler. And here what we can do is basically just copy this over. So this is the move event. So we'll just copy this over. So this is the new round. So we just add this $, and that should work okay. But of course we want to handle this elsewhere, so we'll pass the handler from the function parameters, or arguments, I mean. And then for the player move event, this is the one where we're looping through each of the squares and adding those listeners. So at this point, I don't want to just copy everything over because we're going to do this a little bit differently moving forward. So we're going to start to diverge from our original implementation and just start to use it as a reference only, not trying to copy things verbatim. So what we want to do here is select those squares, and for each of those squares, similar to how we're doing it here, we'll want to bind an event listener. So we'll say square.add event listener, listening for a click, and then we're passing this handler right here. Now let's talk about event listeners that are going to be view only things. So you'll notice that I skipped over here on the left, I skipped over this one right here where we are clicking on the button to reset the game, although that should probably be added here. But specifically, let's look at this one where we're just toggling something in the UI. So remember, we just have this actions menu that's opening and closing. This is not going to affect the state of the game whatsoever. It's purely a view client only piece of state that we're tracking. And therefore, in terms of responsibilities, the view can handle 100% of that. It doesn't need to change any state or anything. So we can actually register that in the constructor and keep it entirely encapsulated here. So we'll call this section UI only event listeners. And here what we're going to say is this dot $ that menu items. I'm sorry, we need the modal button or menu button. Yeah, menu items. And then we're just going to toggle the class list. So we'll say menu items dot add event listener, listening for a click. And then we'll go back in that callback, and we're handling this in the view itself. So we'll say this dot $ dot menu items dot class list dot toggle hidden. And we're going to actually improve this handler just a little bit for some reusability, but let's start with that. And at this point, I think it's time to kind of comment out this app that we had before. So we're going to be resetting a good amount of functionality for the time being. Oops. So we'll just go through this whole app here, the whole thing, including the load event, and comment that out. We'll keep it here for reference, but it's all commented out at this point. So all we have now is just the view. So let me collapse all that because it's just going to be easier to see, and we'll save this. And now let's see what the UI looks like. So right now I can't really do anything. I can click stuff, but nothing is going to actually happen. Now the reason nothing is working is because I actually grabbed the wrong thing here on the right. Let's bring this over so we have a full screen. In our new view class, I'm actually adding a click listener on menu items. It should just be menu, because if we go back to our index.html and look for that, we want to register the listener on menu, or probably more specifically, we want to add a data ID and call this menu button. So let's go back to our view. We've got the menu items, and let's add one more, menu button. And then we'll add this selector here. And now we're listening for a click on the menu button. And then when that happens, we're toggling the hidden class on menu items. So going back, we should now be able to toggle the menu open and closed, but that's just about it. We can't do anything. Clicking the reset button, new round, a square, it doesn't do anything anymore. And we need to start wiring up those events. Just to show you the pattern that we'll be using, you can see that we have methods to bind these event listeners. But remember, by default, when this class is initialized or instantiated, these methods are not going to run because they're just methods of the class. Someone needs to actually call these for these event listeners to be added. So that's what we're going to do in the apps init method. So right here below the class initialization, we now have a class instance called view, which we should be able to bind all of these events. So we'll bind the game reset event, and you can see that our autocomplete tells us that we need to pass a handler in there. And that handler is going to give us an event. So we can stub it out just like this, and we can console.log the event. We'll also console.log the name. So reset event. So we'll copy this down for all of them. We just had 3 of them. So let's see what we called bind new round event, and then bind player move event. So now we're actually calling those methods that are registering the event listeners. So now when we go back to our UI, we should be able to at least click things and see things happening. So new round event, or if I click the first square, it says player move event, and you'll see the click target is the square with the ID of 1. So div ID equals 1. Or if we click down here, we'll see an ID of 9. Now with this pattern, we want to keep our controller logic, which is in this app, as simple as possible. We want this to really just orchestrate what happens to the state in the view, but we don't want to add a lot of logic to this file. Most of the logic needs to happen in View.js or Store.js, which we haven't created quite yet. I will get to this and show you why we have this, but let's continue with the view and start implementing some of these methods here. I think a good place to start is to go back to our app, open up our original implementation, and let's go ahead and go down to this big event listener that we have. Or no, we'll start with these littler ones. And just so that we can see this better, I'm going to uncomment everything, and we're just not going to initialize it. So I'll uncomment the whole app, but because we're not initializing it here, we can delete that. This is just going to be a variable that's initialized. It's not going to actually do anything or register any sort of event listeners. So this is just for reference. So if we go down and look at some of the code that we've already written, we've implemented this toggle method over here in View as a UI-only event. That doesn't need to happen anywhere else. Now, these have not been implemented. We have a click listener on the modal button, which allows us to hide the modal once the game ends. We'll get to that in a second. But really what we want to start looking at is all of this logic, because it's a little bit messy and we could probably create individual methods to achieve what we're doing here. Let's start by improving our menu toggle. Right now in the UI, what you'll see is that it opens and closes, but this little chevron down icon, it's not going to change. And generally when you have something like this, the icon will rotate 180 degrees and go up when it's open and down when it's closed, or vice versa. I can't even remember which one is the correct design, the correct way to do it from a design perspective. But anyways, we can improve this a little bit, and we can also add like a selected state so that there's like a border when it's open. So this will help us to kind of ease into this new pattern. So as you can see, I'm handling this UI only event in the constructor and directly toggling that hidden class. But what we'll do is break out this view into a couple sections. So this section is going to be register all the event listeners. Then the next section is going to be some utility methods. So DOM helper methods. And that just means we're going to have some methods to change the UI in some way. And the first one we'll define is toggle menu. And that's going to be called, we're going to move this logic into that method. And then we will just say this.toggle menu and call that. So we've just refactored it a little bit, and we're going to add some stuff to this. So let's make sure it works. If we click this, it toggles the menu OK, and we're set. But now we want to add something a little bit better to this. So what I want to do is first add a border when the menu is selected. So we're going to say this.menu button, because that's what we're going to put the border around. And then let's toggle on the class list a border, which if you remember from our styles index.css, we have the shared utility classes and we've got this border class. So we can just toggle that to get a border on it. So now if we click, you'll see that when it's open, we have a border, and when it's closed, there's no border. So that's just kind of a nice addition. You could probably achieve this with CSS, but I thought it'd be nice to just demonstrate some JavaScript. And then furthermore, we want that little icon to flip up and down depending on the open or closed state. So to do that, we need to actually create a different icon based on that state. And what I'll do is define that in a variable. And from here, I'm going to, let's see, I'm going to grab from the menu button. So the menu button is going to be this right here. And you can see that I've got an icon down here at the bottom. So basically what I'm doing is I'm selecting the button itself, and then I'm grabbing any I tag that is within it. So we'll say query selector, and we're going to look for any I tag that we can find, which should represent that icon. And then what we're going to do is look at the class list of that. And since we're using FontAwesome, we can just toggle FA chevron down and then also chevron up. And this should basically just flip it every time the menu's toggled. So if we click here, you'll see this little icon just flips every time it opens and closes. So that's just a nice addition to polish that up. But more importantly, it demonstrates in a pretty simple way how we can define all of these DOM helper methods. And then within our event listeners, we'll just call those to basically change the DOM and change what the user is seeing from a view perspective. Before we go to the next set of event listeners, I want to do one little refactor here and add a utility method for selecting elements. As you can see, we're using a lot of markup here just to select, kind of basically using the same syntax. And more importantly, this is the better reason to do this refactor. We're not entirely certain whether this is going to result in an element being selected. We can put these selectors in and check them over and over again, but we really have no assurances that what we have attached to this list of elements is going to actually be valid selected elements. So what we can do is at the very bottom of this class, we can add a few helper methods. What I'm going to call this is QS, that's short for query selector. And then you should be able to pass in a string selector to that method. And all I'm going to do is look for the element, and that's going to be on the document.querySelector, and then we'll pass in that selector that was in the parameters. And then what we're going to do is make a check. So we're going to say if there is no element that was selected, so in other words, we passed the wrong selector or something went wrong, we're going to throw a new error. And the reason for that is we don't really want to continue with our application and trying to perform all the additional logic if these selectors don't work in the first place, because that will just mess up everything. So we're going to say could not find elements, and this will just give us as the developer some confidence that we're passing in the right selectors. And here we can just return the element which we know is defined now. So there's a few improvements we'll make to this, but let's go ahead and try this out. So with the menu, we can just say this.qs, and then we pass in the data ID, and that should select the menu. So let's go back to the UI. You can see that there's no errors. I'm going to get rid of this for the moment because that was something left over from right here. So let's get rid of that so we're not confused. But this worked, and so now what we can do is go down with the query selectors and replace these. Now you'll notice we've got a query selector all, which will not work with our utility method, so we'll leave that one alone for the time being. So this.qs, and then we'll replace all of these and save. And as you'll see, it all works. There's no errors. Let's just demonstrate an error. So let's pass an invalid selector. Now you're going to see uncaught error, could not find elements. We want this error to happen so that we know that we should go back to our code and fix it. Now just a few improvements that we can make. With ES6 class syntax, the way that you define a private class method, which is something that we don't want to expose to the outside world of this class, you can put a $sign, or not a $sign, but a hashtag in front of the method. So let me just demonstrate the difference here. Right now we have this as a public method on the class. So if we go to app.js and we call the instance view.qs, you're going to see an autocomplete in VS Code because it thinks that this is a public method. but we really don't want to be calling this query selector from anywhere outside of the view. We don't want to be doing that from our controller. So to make that private, we'll put that hashtag, save it, and now when we try to grab this on the view, you won't see it as a possible method that we can use. Now I think you can override this. I'm not sure if it's enforced at runtime, but it's just a good practice to keep everything private that you don't need outside that class. We can also do that for the toggle menu. So we'll put a hashtag there, and we need to now update the calls to this. So this .toggle menu, or actually we may not. Let me check this. Let's go to the UI. Yep, okay, we need to update that. So we'll say hashtag toggle menu, don't know what just happened. And then query selector, so this .query selector. Just highlighting them all. And let's grab the right one there. And then the last thing we need to do is implement this query selector all as a safe method. So one thing I want to do with the query selector is enable us to add like a parent element that we can pass. So basically this will just give us some flexibility so we don't always have to search on the document. So we'll say if there's a parent argument, we're going to search from the parent. Otherwise, we're going to search from the document. So just a quick little refactor there. Then we're going to copy this whole method down. We probably don't need the parent for this one, but we'll call this query selector all. And in this one, it's going to be the same thing. We're passing a selector, but now we're just going to use a different DOM method. So if there's not an element list, we're going to throw could not find elements, otherwise we're going to return it. So now we can replace that query selector all with this query selector all. Save it and make sure we don't have any errors, which we don't. And then finally, let's just make a different namespace for squares because it represents a node list, while these just represent individual elements. So we'll just make another namespace, a double $sign, which will represent the ones that we're picking as a node list. So we'll assign the squares to that one, just so that we have some separation, a little bit of organization there. All right, let's continue our refactor. Looking at our app.js in the original implementation here, the next thing that I want to cover and break out into a more concise method is some of this stuff right here. So if you remember, what we're doing here is we are adding an icon with a certain color to the square that was clicked, and we're also updating this turn indicator up here in the top left. So I think what we can do, looks like we actually have an error here. This $squares is undefined. Let's fix that before we keep going. And the problem is we've reassigned the squares to that double $sign, but we did not update that down here in our event handler. So let's save that, and we should have that working again. All right, back to it. We need to update this turn indicator, and then of course when we click something, we need to turn that event into an element in the DOM. So we can break these out into two separate functions, I think. The first one is going to be setting a turn indicator. So down here in our helper methods, let's add a method called setTurnIndicator. And for right now, since we don't have the context of what player has actually made the move, we're just going to hard code something, and then we'll fill it in later with something more dynamic. So the first thing that we need to do is just look back at what we were doing before. We were basically creating a turn icon and a label, and then giving some inner text to the label and setting a color on the icon. So we'll do that same logic in the set turn indicator. I will put a player as an argument, but we're not going to leverage that just quite yet. It'll just be kind of a placeholder. So what we need to do is create an icon. We can say document.create element. We want an I element, and then we want a label, which is going to be a paragraph element. For now, let's just assume that player is going to be either equal to 1 or 2, and we'll style it according to that. We're going to update that in the future, but just for now, we'll assume that. So for the icon, we're going to look at the class list, and we're going to add a certain color class based on the player. So if player equals 1, we're going to call that yellow, otherwise it's going to be turquoise. That is similar to our logic here. So if the current player is 1, we were calling the square icon was the yellow, and we're doing the opposite for the turn icon. But this gets a bit simpler because right here we're tracking basically 2 pieces of state. We're trying to see who was the current player that made the move, and then for the next turn, we're trying to decide who's the player after that. So we're mixing a lot of things and it's a little confusing. Really, over here in the view, we want to be more declarative and explicit. We're just saying that player 1 is associated with yellow and player 2 is associated with turquoise. Same thing goes for the label. We'll add the class list, player equals 1, that's yellow, otherwise turquoise. Now I think in our original implementation we weren't updating the color of the label, or were we? Let's look at our HTML. You can see we have an element called turn, which we really could just select this and add the color class to that. So that's what we're already doing. So let's stay consistent and do that here. So instead of setting the color based on the player, let's just say player 1 is FAX. And then for the message that we're adding, we need to set the text content. So let's delete that. So if it's player 1, FAX, otherwise FAO, we need to select one more element. So turn div, and I think we already have this. It should be at the top here. So right here, we've selected the turn element. So we'll say this $$turn.classList, and we are going to add the color based on the player. Now there could be an existing color, so we'll have to do 2 calls here. So add and remove. So we'll say if the player equals 1, we're going to add a yellow color. Otherwise, we're going to add a turquoise. And then what we're going to remove is if it's the player is 1, then we want to remove any turquoise class. And otherwise, we want to remove any yellow class. So this just makes sure that we remove the unwanted one and add the wanted class. This down here, we're setting the actual icon that we're rendering. And then the label, we can set the inner text of that. And we'll basically say if it is player 1, we'll say player 1, you're up. Otherwise, we will say player 2, you're up. Now at this point, this isn't going to do anything because we just kind of created these elements in memory. We actually have to commit those to the DOM. So what we need to do is select the turn div that we had modified up here with the classes, and we need to replace children. So that will just replace the child elements with first the icon and then the label that we created right here. So let's save that. And right now, set turn indicator is not hooked up to anything, but let's put that in our controller logic. So if you remember, we are binding a player move event right here, and we're just printing that to the console at the moment. But what we can do now is reference the view and grab that utility method that we used. Now it is a private method by default, so let me check if we need to make that public. Yeah, let's go ahead, let's make that public for now so that we can use it here. So we'll say set turn indicator. And for now, we're just going to hard code the player ID. We're not tracking any state yet, so we're going to always say that we're going to pass in player 1. So let's save that and see what happens. If we click a square, it's not doing anything, and we need to find out why. So let's inspect the HTML. If we click this square, it just looks like it's not doing anything. Okay, so now every time we click one of the squares, we'd expect this to update to player 1. Now it's already player 1, so you won't see a change. So let's go back, and instead of setting it to player 1, we'll set it to player 2. And when we click, it now changes that to an O, but we're not getting the right colors. We're getting the right text, getting the right icon, but not the right colors. Oh, okay, so our problem here is that by default, our class of turn, so this one right here, is setting the color. And then we're adding this turquoise class later, which is not it's not overriding that. So a better way to probably approach this, we'll go back to our CSS. And instead of making that turn have this initial color, we will handle that with the class. So let me show you what I mean. So I'll remove that from turn in CSS. And then if we go to the HTML, you'll see I'm just passing yellow as a class to style the initial icon and message. And so now we're not coupling the color to the turn class. So this should work. You can see player 2, you're up. And it's going to set that every single time. Let's refresh. So player 1, you're up, and now we're going to hard code that to player 2. One other thing that you'll notice that I think I've kind of messed up is this icon has almost like italics to it. And that's because we're not adding the FA solid class. So with FontAwesome, you have to add FA solid. And when we hit enter on that, now it looks a lot better. So we need to remember to add that. Let's go to our view. And when we create this icon, let's make sure and add that class. So class list.add FA solid. And what you can actually do is pass this as 2 arguments. So instead of doing that twice, we can just pass FA solid and then give it a comma to do another argument, and then we'll give it the actual icon to render. So now you'll see we start with that X, it's yellow, it's player 1, and when we click, we are hard coding it to be player 2. So we click, and now it's an O, player 2, and everything is that turquoise color. So we know that our set turn indicator method is working correctly. The next thing that we need to do is actually populate the square. So we have to put an icon within the square. And you can see in our original app logic, somewhere right here, we are adding the square icon and doing something pretty similar. So let's go back to the view, and this one is going to be called handle player move. And for this function, we're going to pass the square element that was clicked, so the reference to that, and then the player that made the move so that we know which icon to put in there. So this one will be rather simple. We just need to create an icon similar to how we're doing here. So we'll copy that logic. So we're creating a new icon HTML element. We are then adding a class list, which we are going to put the FA solid. Remember, we did that right here. And then we can use the same logic to figure out whether it's going to be an X or an O, so depending on the player. And then finally, we're going to reference the square element, so whatever square was actually clicked, and we're going to replace children with that new icon that we have just set. Now, of course, we don't have a color specified, so we can just group that here. So if it's player 1, it's going to be an X, and that's going to be yellow. If it's player 2, it's going to be an O, and that will be turquoise. So let's save that, and now we will call handle player move in our controller. So now you can start to see what the controller is supposed to be doing. It's supposed to be kind of orchestrating the events that take place. So we're going to set the turn indicator, and then we are going to handle the player move. And let's hard code player 2 so those are synced up. So now when I click this square, we would expect that this turn indicator will turn turquoise with an O, and this square will, or actually, now that I'm thinking through this, we want the player move to be player 1, and then the turn will be set to the next player, which will be player 2. Once again, we will refactor this so it's dynamic in the future. We're just trying to get our view logic to work. So let's save that, and we'll click here, and this should be a yellow X, and then this will turn to a turquoise O. And you can see it has not done anything. And it says DOM token list add. The token cannot contain white space. So let's see what I did here. Okay, so I cannot do this. I actually messed that one up. We need to duplicate this logic so that we're just doing one token per argument. So just a little refactor there, and that should probably work. So make sure we're refreshed and click square element, replace children's not a function, because I'm just getting tired here. We can't just pass in that one. We need to pass in the event target. So this will represent the square that was clicked. And so we want to pass that into our method. And hopefully third time's a charm. As you can see, it did work finally. And it's just going to put X's everywhere, yellow X's, because we've hard-coded that. And player 2's O is going to be up. Obviously, we want to make this a little better experience. So at this point, we have reached a place where we need to address this file, Store.js, because we are doing some, view logic, but right now we're hard-coding which player is up. And if you remember from the earlier implementation, we had this state variable right here where we're tracking the moves. And then based on those moves, we're getting a game status if there's a winner. And we're also using that information to determine, what's the current player and which, icon and which colors am I going to add. Looking at our previous implementation, this is kind of a critical moment in the refactor where we start to see things separating into different concerns. So separation of concerns, as you can see in our event listener for the player move, we're doing multiple things. We are changing what the user is seeing in the DOM. So we're updating classes, HTML elements, so on and so forth. And that's happening in logic just like this, where we're replacing the children with some new elements. Now we're also doing something completely separate, and that is reading and updating the state of our game. So as you can see, sprinkled throughout this listener, we are doing things like checking if the square has a move, and we're reading the state of the application to figure that out. Furthermore, we're coming down here and we're actually mutating or changing the state of the application right alongside the changes to the view. These two things are separate concerns, and that's why we need this store.js file. So similar to the view.js, we're going to create a default class and export it. So we'll copy this syntax, and this one's going to be called the store. We of course need a constructor. And now one new thing that I'm going to introduce, we're going to set two private methods. We're going to add a getState method and a saveState method. And what these are going to represent for us is a way to get a read-only copy of our current game state, and then saveState is going to change and basically transition to the next state of the application. Now, there's some really good articles online about state management. One of those is the Redux documentation. Redux is, I guess probably better to say, it was the leading state management solution for client-side apps for a long time. Now that React has kind of refactored and moved towards a functional component approach with use state and stuff like that, it hasn't been used quite as much. But there are some best practices that they have written over years of managing state within an application, and they're very good to read through. The one that I'm going to point us to is the do not mutate state best practice. So mutating state is the most common cause of bugs in Redux applications, or in applications in general, including components failing to re-render properly, and will also break time travel debugging in the Redux dev tools. So that's kind of specific to Redux. But actual mutation of state values should be avoided. And we're going to stick to this approach because it's generally just a good idea and reduces the surface area for bugs to occur. If you see from our original implementation, we are directly mutating state. So we're reading it up here where we're checking for something like the last move, and then we're directly updating it here. There's nothing terribly wrong with this for the size of our application, but it's just better to make sure that we're not doing that. So what we're going to do here is actually add a private state variable, and that's going to be equal to an array of moves. So that's very similar to what we had up here, right here. But it's going to be private, so only this class itself can read the state and write to it. And we have to use an intermediate method to actually retrieve the state, as I'll show in just a second. So when we get the state, all we're going to do is return this dot state. Now, this is kind of a redundant method. You'll see why this is useful for us later in this video when we refactor this to use a little bit more persistent state storage. So we'll be looking into local storage. Right now, that's not needed, so we're going to keep it like this. But the get state method will just return this private state variable or property, and then the save state is going to set it. So we'll say this dot hashtag state, and then that's going to be equal to whatever new state is passed in. Now, something that's very useful when you have a save state method is being able to reference the prior state within that method. So rather than just passing a hard-coded object as new state, I'm going to make a parameter called state or function. And this can be passed as one of two things. You can pass just a raw object, or you can pass a callback function that we are going to give the previous value of state to. So let me just walk through this. It's a little bit confusing if you're not familiar, but this will really help us out later. So we'll say the previous state is equal to this dot get state. So that's the previous state we're dealing with. That's reading here. And then we need to check what kind of argument that we're actually dealing with. So we'll say let new state. That's going to be just a variable that we're going to initialize but not assign yet. And now we're going to say switch on the type of state or function. So we've got a switch statement, and we're going to look for a function type, and we'll break from that, or a object type, because our state is an object, and we'll break from that. And then the default is going to be throw a new error, invalid param, or invalid argument passed to save state, because we only want to handle these two cases. So it's pretty simple from here. If it's a function, all we're going to do is say the new state is equal to the state or function, which we know is a function here, and then we're going to pass in the previous state so that whoever calls this has access to that. Now, if it's an object, we're just going to set the new state is equal to the, not the previous state, but the state or function. So in this case, we've just passed a literal object and we just want to assign that to state. Then from here, all we're going to do is basically, later we'll save this to local storage, but for now it's all good. So we'll just say this dot state is equal to the new state that we had just assigned right here. So let's save that. Now we've got our get state and save state functions implemented, and now we need to actually initialize this. So we'll have a default value that we're passing into this store, and this default value is going to, we'll just call it initial value, and we'll set that equal to moves, and that will be an empty array. So as you can see, we've initialized it right there, but really we can just refactor that to say initial value. Once again, I know this is a bit contrived. We're doing a little bit of indirect stuff, but you'll see later why this makes sense once we start getting into local storage. At this point, if you're paying attention, you'll probably notice that everything that we've defined here is a private method or property, and therefore this class is not very useful. So what we want to do is expose a getter method that allows us to read the state, and then our application can take that state that we've read and do something with it. So if you'll see in app.js, one of the things that we had defined was get game status, and we just passed in the moves that was, in state, and that's going to give us things like the status of the game, if it's complete or in progress, and then if there's a winner, it will define that. So this is something that we'll need, and we can define that in the store. Now, something I like to use when we're just reading a read-only value from a class is to add a getter method. So if we add the get keyword followed by something like game, and then we define a method, this is going to be evaluated at runtime. And basically what we can do here, where we initialize the store, which we still need to do. So store equals new store, and that should have auto imported things for us. So import store from store.js. So when we initialize that, now store.game is a property that is available. So let's just console.log store.game right now, and we'll just return dummy value. So let's go back to our UI, and you can see that it prints dummy value. Now, just to demonstrate, if we remove that getter, it's going to break. We're just going to get a function called game. So we would need to go over here and actually call that as a function to get the dummy value that we're looking for. So that's why I like to just use a getter, because you don't have to call anything. You can just add that get keyword, and then this acts as a property on the class instance. So as you can see in our handler for a player move, we are hard coding right now the player that is up. So we obviously want to get that from the state of our game or from the store. So to do that, we're going to update this class property to basically derive some state. So the goal with saving state, as we talked about earlier, is to keep it as simple as humanly possible, and then we're going to derive as much as we can at runtime from that. So that just makes it so that we only have to update a small piece of state, and then we can just dynamically get the rest. So I'm going to basically take this method that we had defined earlier, get game status, and I'm going to kind of refactor this, make it a little bit simpler. And the first thing that I'll do here is define our list of players. This is going to make things a lot easier for us. And I'm just going to copy in from the completed app so we don't have to type things out, and then I'll explain what we're doing here. So down here, I think at this point I'm going to collapse our app because we're, once again, not using this. We're just using it as a reference. So here we're going to define the players of the game. How I've decided to represent these players is just a tuple or an array of players, and we'll just know that the 0 index is player 1 and the 1 index is player 2. Now, what we're doing is basically adding some configuration here. So this is a configuration array that's saying we have got 2 players. This is the name of player 1. They are going to be the X icon, and they're going to have a color class of turquoise. Likewise, player 2, O, in color of yellow. So this is going to help us with our internal logic quite a bit, and I'll show you what I mean here in a second. So before we even touch the store anymore, let me just pass in players and then the first index. So that would represent player 2. Obviously, this is going to break that method because we're not expecting an object. So if we click stuff, it's just not going to work correctly. But if we go to the view and go down to that method that we had defined, so set turn indicator, this player now represents that object. So now that we're passing an object as the player, this logic here gets a bit simpler. But the problem is, if you look at our index.html, we're defining the color on that top level, which means we have to add and remove classes. So really we would need to pass in player and then opponent. And then here, what we would do is say player dot, let's see, color class. And then this one would be opponent dot color class. So we're adding the current player's color class, and then we're removing the opponent's color class. Now, a bit simpler way to handle this, I know I'm kind of going back and forth here, but let's go back to index.html and remove the color property from this outer div. And instead, let's just initialize the color property of this each element within. So to start the game out, we're going to have a yellow X for player 1 because that will be O as the first player. So let's save that. And then here in the view, that means that we no longer have to remove classes. And instead of looking at the turn, we can just directly add these to the icon. So icon.ClassList.add, and then we'll say player.color_class. And then label.ClassList will also be color class. We can remove the opponent here. And then if we come down here, let's just kind of group these icon classes together. This is where we're defining which icon it is. And rather than doing this switch here, we can just say player.icon class. So remember, we defined an icon class and a color class on each player. So here we're adding the color class, here we're adding the icon class. And since we're doing this to the same icon, we can actually combine all of this. So we'll say FA solid, then a color class, and then an icon class, and we can delete this line. So this will pass all 3 of those. Then finally, the label gets a color class, and then we need to update the label inner text. But instead of these static strings, once again, we've made it easy for ourselves in our configuration. So we can just say player.name. As you can see right here, we've defined a player name. So we can just add some string interpolation here. And we'll say player 1, you're up. And then finally, we're getting the container and we're replacing it with the icon and the label. So now that we've done that, we should be able to see this working. So we don't need to pass that opponent anymore, just the player. So let's go back and click something. So this should be turquoise, not yellow. So let's see what's happening here. We're passing in players index of 1. So we're basically passing this object. We'll bring that over to the view just so that we have a reference to see what we're passing. So that's the object that is being passed in this case. And we are grabbing the color class, which is defined as yellow, and the icon class, which is O. So that's our problem. Our configuration object is actually different. Let's check the final implementation, so the vanilla refactor. you can see that the X is turquoise and the O is yellow. So I actually had things backwards this whole time. I apologize. The O should be yellow and the X should be turquoise. So I think this is intended behavior. Let's delete that. And then instead of player 2, we'll pass in player 1. And let's see, that is working a little bit better. We've got a blue X, and then if we load by default, we need to update that as well. So this should start as turquoise. This should start as turquoise. So player 1, you're up. A turquoise X, is that the same thing we get here? Let's reset. Yep, we get a turquoise X. So we're starting in the right state, and then as we click something, we should be getting that to change. So let's click for player 2, and there we go. We've got a yellow O with player 2 text added in there. And then the last thing we can kind of refactor here is the handle player move. Instead of just hard coding in 1, we can hard code in players at 1. So we'll go back to handle player move. And this player is now an object. So we can replace this here with player.icon class and then player.color class. Save that, make sure our icons are going in correctly, and it looks like they are. So that is refactored. That makes things a little bit easier for us to handle. And now we can go to the store and start defining this read-only game state variable. Right now we're just returning a dummy value, which is not useful to us, but the purpose of this getter method is to basically take the raw state object, which is just an array of game moves, and calculate all sorts of useful information from that. You can already see we've done that with our get game stats right here, or get game status. So the things that we're really doing here is checking for a winner, and then also at some point we're going to have to figure out who's the current move or who's up to play. So we can encompass all of that within a single method here. And we're going to build this kind of piece by piece until we have something to read from, so that we can determine down here in our controller method where we're setting the turn indicator and handling the player move. That way we can just pass in that derived state so that these methods know what to actually do with the UI. So let's start out by getting the current player. So we will first grab state, which can be read with the getState method. So this is just a assignment. We could just read this directly, but nice to have a variable to work with here. So that is the first step, and then we're going to derive the current player with a little trick. And I believe the original creators of this game that I'm refactoring here already had this little trick, and they were using it, but we can use the modulus operator to basically determine the current player. So what that looks like is we'll say the current player is equal to the list of players, which we do not have access to here, but really just a list of players, and then we can grab the index of that based on how many moves have been made within the game. But like I said, we don't have the list of players, so one thing that we need to do is pass that to the store so that it has access to that. So we'll pass that array of players, and then we'll set a player's property on the class, and so that way we can access it right here and then grab whichever player we want. So we'll put in 0 for now as a hard-coded value. Let's go back to app, and where we initialize the store, since we have the list of players right here, we can just pass that array down to the store via the constructor. So at this point, what we can do is we can say state.moves.length, so that will tell us how many moves are in this current game, and we can use the modulus operator and use it modulo 2, which will basically give us either a 1 or a 0 based on the number of moves. So if we just open up a terminal here and open up a little playground with Node.js, you can see that if we have, let's say, an array of moves, and let's just say it's 1, 2, 1, 2, just to fill it up. So we currently have a moves.length of 4. So based on this, if player 1 is the starting player, then we know that player 1 made this move, player 2 made this move, 1 made this move, and 2 made this move. So who's up next? Well, the way that we can determine that is basically just doing moves.length modulo 2. And that will give us a 0. And since our players array is just 2 objects, the 0 index is going to be player 1, and the 1 index is going to be player 2. So if we were to push a new move to that array, so let's say player 1 moves, now if we do moves.length modulo 2, we get 1, which is the index of player 2. So you can see how based on the length of this array, we can quickly determine who the current move belongs to. So we'll go to the store and we will do this operation to get the current player. And then from there, we can also derive the next player in the game. So we'll say, but we actually might not need that. Let's hold off on that one for the moment. So let's go ahead and return the current player as part of an object. So we now have that as part of our game state. And then we can come down here to the set turn indicator, and we're going to reverse this because first we need to actually handle the player move. And I'm going to make a variable to keep things clear. We will say that the clicked square is equal to the event.target because that's what that actually represents. If you go back to the view where we are binding that move, we're just looping through the squares and adding that event listener, which is going to pass the individual square to that handler that was clicked. So that's what that represents. And just for clarity, we can pass it like that. And then for the current player that we want to move, now we have some game state. So we can say store.game.currentPlayer, and that should satisfy the stub of this method. So we are now passing the current player in, and at this point, we need to update some of our state because we, of course, have made a move by this player, and now we want to set the turn indicator, but we don't want to set that for the current player because they have just moved. We want to do it for the next player. So we need a way to update the state to advance it to the next play. So the way we can do that is make a method in store, a public method called, let's see what I called it in the final project. I think I just called it player move. And what we're doing here is passing a square ID. So that's 1 through 9 based on which one was clicked. And to follow our convention of not mutating state directly, we first need to grab state from the getter method that we've defined right here. So we're returning that private variable. Then we need to make a clone of it. So we're going to go ahead and call that state clone. And there's a built-in method to browsers called structured clone, which you can pass an array, an object, pretty much anything, and it will give you a clone of that object. So we're no longer referencing, we're no longer passing a value by reference. We've got a completely different object that we're able to mutate here. So from this point, we can go ahead and take the state clone and push a new move to this array. Actually, we don't want to push it directly there because the state object has an array of moves, but that is a property. So what we're really saying is state clone.moves.push, and then we need to pass in the square ID right here, and then also the player ID. So, or not the ID, we'll just pass in the player that is currently up. So that would be state, or not state, but this.game Remember, we just derived that up here, so we can actually access that property within the class, and we can pass it the current player. So when we call player move, it's going to take the square ID that was clicked and the current player that was up and push that as a move to the state object. So that's going to actually update our state for us. But the last step we need to call is this .saveState. In this case, our state object's pretty simple, so we can just pass in that literal object rather than a callback function. But we'll come back and refactor this as we develop our state handling a little bit further later on. So let's save that. And then back in app.js, all we need to do now is call store.playerMove. And here we just need to pass the click square, but we need to pass an ID. So really what that is going to be .id, and we need to cast that to a number because the event ID or the event target's ID will come as a string by default. So we're passing in a number ID and we're updating state. So at this point, we're allowed to now set the turn indicator to the current player because that has been updated with this method. So we can go back to the store.game.currentPlayer and set the turn indicator. Now the important thing to notice here is that this store.game.currentPlayer is a different player than this store.game.currentPlayer. And that is because we have made a state change happen in between the two. And every time that state changes, that getter value that we've defined right here is going to automatically reevaluate and update. So if all worked, when we click a square, it should update things dynamically. So it says player 1, you're up, and we click, and now we've played with player 1 with that X, and you can see player 2 is now up. Now we should be able to click and we get an O, and now player 1 is up. So now we have this working again. But if you remember from the original implementation, we had one big problem, and that's if you click twice on a square. So we need to make sure that we are not updating a square twice, and that should be relatively simple to handle. So let me comment some things in here. We will say place an icon of the current player in a square, advance to the next state by pushing a move to the moves array, and then set the next player's turn indicator. Now up here at the top, this is where we need to check whether there's an existing move. So you can see in our original implementation, what we did here was we made a little helper method that says whether a square ID has an existing move. And then we checked if that current target matched that, and if it did, we returned early. So we can actually, we could make a helper method to do this within the store, or we could just check it inline. I'm going to go ahead and just check this inline, as you'll see in just a second. So let's collapse the app. And let's say the existing move is going to be equal to the store.game.moves.find. And so we're looking for a specific move that has a square ID equal to the clicked square.id, and we need to make sure that that is a number. So we're comparing the same thing. So if there's an existing move, if that's not undefined, basically, we're going to return early, and we're not going to handle that player move, save the state, or set the turn indicator. Let's save that, and now let's play, and it looks like we've got a problem, and you can see that we're getting an error here by reading the store.game.moves. It says that it is undefined. And that makes sense because we have not actually added that to our getter. So let's go back to the store, and remember, game is only returning the current player. So it'd be nice if we also just gave it the moves array, just so we have access to that. So we'll save that, and now things should work a lot better. So now if we click something twice, it's actually still messing up, and I believe this is because of the same reason we ran into earlier that I failed to recognize once again. When we're binding to this player move event, if you look in the view, we are basically just passing the event to the handler, and that event could have been an icon that was clicked. So instead of just blindly passing the handler right here, what we really need to do is break this out into a function and pass the square itself that we are setting the event listener on, rather than the event target, which was the default that was passed. So let's update that, go back and see if that fixed things for us. Square element is undefined. We just need to make one adjustment here. It is no longer an event that's being passed. It's a square reference. So this is actually more expressive anyways. So we will check square and then update these references. And hopefully, finally, this will work. So we're clicking, click it again, and it does not do anything as we expected. So now we've got a lot more stable behavior, and we're almost back to where we started. But of course, we've got a tic-tac-toe in 2 places, and the game has not recognized that yet. And that's because we need to, once again, build up our derived state, which is in this method right here. The last piece of state that we need to derive in this game property, or getter, is who has won the game. We've already done this in our previous implementation. We did this right here, where we were checking the player moves, the winning patterns, and then checking the player moves against those winning patterns. We were then deriving it as a status and a winner. So I'm going to do something similar to this, but we're going to simplify just a little bit in this new derived state method. So the first thing we'll do is copy in those winning patterns, because those are just static. And then we'll initialize the winner to be equal to null, just to get a variable in place. And then what we're going to say is we're going to do a for loop. We're going to loop through each player. So for player of this dot players, so remember we initialized the list of players, which is just 2 people in the constructor. So we can loop through each player, and then within that loop, we can get the selected square IDs of that player. So we'll say this dot game dot moves. And remember, this is just the current state of the game. So this.game.moves, or I'm sorry, we should probably not do that because we're referencing this method from itself. So what we need to reference is this state variable right here, where we're getting the raw state. So we'll say state.moves, and we're going to filter those moves to only be the moves of the current player that we are looking at. So just walking through this logic a little bit, we've got the array of raw state of moves, and we're going to filter out any player that does not match the current player in our loop. Furthermore, we're going to map that resulting array and just grab the square ID off of the individual move. So if you remember, we're pushing a square ID and a player to that moves array. So that's basically what we're reading off of this right here. So we've got a list of selected square IDs for the current user. And now we're going to do an inner loop, and we're going to say for pattern of winning patterns. Now we're going to check if the pattern matches every one of those selected square IDs. Or actually, I should probably say if the square IDs has every element of the pattern. So we'll say selected square IDs includes that value. And so this will check if there is a winning pattern. And if that's the case, we're going to set that winner variable that we initialized up here to whatever player we're in during that loop. In other words, we're going to go through this loop, and if no winning patterns are found, the winner is going to be left equal to null, which is going to tell us that this was a tie game, along with the status of the game. So we'll come down here and add a status property, and we're going to say, is the game complete? This is going to be true if the winner does not equal null. So if there is a winner populated, we know the game's complete. Or if the state.moves.length is equal to 9, because we know that that's the maximum number of moves that can be played in a given game. And then finally, we'll pass the winner variable right here, which will either be null or set equal to some player. So now we have some derived state, and I'll just remind you that we are deriving all of this information, the current player, the status, whether it's complete, whether there's a winner, we're deriving all that off of one simple array of game moves. So that's going along with our pattern of trying to keep state as simple as possible and then deriving what we need to know from it later on dynamically. Now that we have this information populated, we should be able to come back to our app.js or our controller, and this is where we will check whether there's a winner. And if there is, we're going to open up some sort of modal to show that status to the user. If you remember from our first implementation, we had, let me collapse some of this stuff we're not using. So if you remember from here, at the very bottom, this is where we're checking the game status. And if the game is complete, we're going to remove the hidden class on that modal so that it opens up. And then we're going to set a message. So we can make some utility classes or some DOM helper methods within our view class to achieve this. So let's go back to the view class and hook up some of those methods. We can put them pretty much anywhere. I'll just put them at the top here. The first one that we'll want is an open modal method, and we're gonna pass in a message. And what we'll do with that is select the modal itself, and that's going to be the one that we remove the class from. So there's the modal in our index.html. That is this entire div that's got hidden on it. So let's remove that real quick, and you can see how it pops that up. So really what we're trying to do is just toggle that class. And the way we'll do that is we'll come down to our helper method, and we'll look at the class list, and we will remove the hidden class. So very similar to what we were doing before. So let's just try this little helper out right now to make sure that it's working, and then we'll come back and improve it with an actual message that we can show. So we're coming down here, we've set the turn indicator for the next player, and now it's probably time to check whether someone has won the game. So really, we need to do this before we set the turn indicator, because this will update that text up here, and if the game's over, we don't really want that to change. So here's where we check that state. We're going to say if the store.game.status is complete, this is where we're going to perform this logic. And we're going to add a return statement here, because if it's complete, we know we don't want to run this logic. So we always want to return. At this point, we'll call view.openModal, and that should open things up for us. So let's go to the game and play it and see if it recognizes this winning pattern, and it does. So we see player 1 wins. If we click play again, it's not going to do anything because we haven't updated that event listener. So let's refresh the game, start over. And at this point, we need to pass in a message to say who won the game. And we can go ahead and derive that. So we'll put in a variable here or actually we should probably not do that yet. We want to say if the store.game.status.is complete, or no, we already know that, .winner. If there is a winner, then we want to say store.game.status.winner.name, because that's a player that we're referring to, and then we'll say wins. Otherwise, it's going to be tie. So that should be the correct logic for opening the message in the modal. We still don't have any listener for resetting the game, but player 1 wins. Let's reset real quick. In this case, let's make sure that player 2 wins, and it's still saying that player 1 has won the game. So we've got a little bit of a problem here. And it's actually not a problem. I'm just getting tired and forgetting things. In our view, when we're opening the modal, we have to actually update the text within it. So this .modal text .inner text is going to be equal to the message. So let's try that again. Let's make sure player 2 wins. So here we go. We got player 2 wins, refresh, and then if we have player 1 wins, that'll show up there. So the last thing we need to do is register an event listener on this play again button, which will reset the game state. Since we're resetting the state, we need to do this event listener outside of the view. This bind game reset event is meant to be a handler for whenever we click this reset button, but we can also overlap and use it for when the game is complete. So not only do we want to register that on the reset button, we also want to register that on the modal button, because that is going to also reset the game and do the same exact thing. So we'll pass in the same event and the same handler and make sure that's hooked up. Then when we go back to app and we go to the bind game reset event, this is what we need to now fill in. So whenever this pops up and we have an end state, when we click this, we want everything to close and reset. So one thing we need to implement is the close modal helper method. So right next to open modal, we'll make one that says close modal, and this will be very simple. We will just add the hidden class this time. So let's go ahead and call that close modal and see if that works. So we should be bound to this button here, and when we click it, it should now close the modal, which it does. But you can see the state has not reset, which we want to have happen. So this is a job for the store class, and we need to just implement a method. Let's put it under player move, and I think I called this just reset in the final implementation. So we'll say reset. Within this method, we're basically going to read, or we're going to just set the state to be empty. So we can just call save state, and we'll set it to the initial value. So initial value is referencing this right here. So this is basically resetting the game. Now, if you'll notice, we're not saving any history of past games. We'll eventually add that, but for right now, we just want to get things to reset correctly. So over in app.js, we are closing the modal, and then we're calling from the store. We want to reset the game. And then the one last thing we need to do, just to make sure that player 1 is going to be up at the beginning of the next game, is say view.setTurnIndicator. And you remember we can just pass a player there. So we should be able to just pass players 0 because that represents player 1, and we always want to reset to player 1. Now another way to do this is we know that after we've reset the state, we know that if we access store.game.currentPlayer, that's going to also give us player 1. So that's probably a more semantic way to do that. So let's Command S to save. So we're going to close the modal, reset the state, and set the next turn indicator. So everything should be cleared out at that point. The only thing that we're probably missing is we don't have a method to clear the game board. So we're resetting the state itself, but we're not clearing the game board. So let's go to the view and we'll say clear moves. And what we're going to do is just look at these squares. How did I access this? Hold on. Yep, so I'm just accessing it like this. So for each square, I just want to clear things out. So square.replace children and leave that empty to basically just clear everything out. So we need to clear the moves after we've reset the store. So view.clearMoves, and then we'll set the turn indicator. And this should pretty sufficiently clear everything from the state and the view. So let's refresh and play the game. Player 1 wins, and when we click play again, everything clears and player 1 is going to be up. So if we do the same thing for player 2 wins. You can see player 2 is up, but that will reset to player 1, you're up at the end. But obviously at this point we have a working game, but if we started to play and then we refresh the browser, it's going to reset. If we play and player 1 wins and we click play again, none of this stuff is being tracked down here. We have no history of games of the past. So if we wanted to implement that, that's going to basically be the next phase of this video. And it's going to get into some really cool concepts with local storage. And finally, we will kind of refactor this to be a little bit more declarative so that we can just kind of react to all of these state changes and render whatever UI should be based on that current state. One last thing I wanted to test. Let's make a move on the game board. And I believe we should be able to click reset and everything resets okay. Now this does not close, which we're going to want to implement, but just wanted to show you that because we actually indirectly implemented this reset method when we were working on handling a winning game. And how we did that, remember when we binded to the game reset event, that is actually linked to both the reset button and the modal reset button. So it's running the same handler regardless. Now, as you saw, that doesn't close everything. So in app.js, where we are closing the modal, let's refactor this to not do close modal, but close all. And we need to implement that method. We'll put that right under close modal, and we'll say close all. And this is basically going to call the close modal. So we're going to close the modal, and then we want to close the menu. We currently have a toggle menu method, but we also want to have a close menu method. So this is going to look pretty similar to this method. We're just going to say this $.menu items. And then on that class list, we're going to add hidden to make sure that it's closed. We're going to also remove the border. So remove the border on the menu button, because when that's closed, we know that should not be there. And then we'll reselect the icon because we always want to make sure that that is going to be the icon that points down. So let's just copy these two. And instead of toggle, we're going to add this one and remove this one. So when we call close menu, it's just going to make sure that everything is in its closed state. And then we'll add that to the close all method. And at this point, we can make this close menu a private method because that's only being called here. We can also make close modal. Let's put that down here and make that a private method because it's only being called here. So now we have a helper method, close all, that is being called when the game is reset, and that should clear all the state. So if we make a move, open this actions and reset, it's going to say close modal is not a function, and that's because we are not referencing it from its private declaration. So now that should work. So make a move, reset, that closes, this resets, game board is cleared, and everything is working great. So as I mentioned, we're not tracking down here the history of all the games that have been played. And we also don't have anything happening here when we click New Round. So in order to track that, we need to update our state object. So right now, this is the initial value. We're just tracking an array of moves. But really what we need to be doing is tracking an array of moves and a history object that has the current round games, and that should be an array, and then all games, which is just basically all the history from, all of time. So with this information right here, we should be able to calculate some statistics of how many wins each player has. So just for clarity, I'm going to also update this to current game moves. So this will still represent the same thing. We just need to update our references to here. So current game moves. Current game moves. Do we have it anywhere else? Okay, I think that's it. So if that worked, we should be able to see the same functionality. Things should still be working, and it looks like it is. And so now all we need to do to start tracking this is when we reset the game, instead of just saving the state back to the initial value, we should update the state to basically take that finished game that we just completed, push that to the history, and then start a new game. So what does that look like? So to start tracking the history here, let's just refactor a little bit right up here. So we don't really need two variables. Let's just pass get state into structured clone, and we'll just call this one state clone. So that's for the player move, and that should remain the same. The reset method is where we're really going to do some updating. In the reset method, we're going to have to check for a very specific condition. And that is if this.game, so we're reading that getter up here that we've defined, .status is complete. If it's complete, we want to push this game that we're resetting to the history object or the history array. And if it's not complete, then we just want to reset it totally. Because remember, in the view, we're adding this reset to two different places. We're adding it to this dropdown right here, which could reset the game even if it's incomplete. We're also adding it to this button right here when the game is complete. So we need to make sure that we're checking that before we push an incomplete game to the history. So all we need to do is check for the moves. We can destructure that from this.game. Really, we should just destructure all of this stuff. So we'll say status moves, and then I think that's it. So now we can reference status.isComplete, and we should also make a state clone because we're not going to mutate state directly. So in here we'll say state clone, and then remember our state now looks like this. So we can grab the history, and then current round games array is where we want to target this. So state clone.history.current round games, and we're going to push the final game here. So I believe that would just look like, let's see, we probably just want to push the moves and the status. We don't want to just push the moves because we want an easy way to loop through all the history of games and see the status on those, which is that derived state right here. So we want to kind of archive that as well. Now, after we get past this block, this is where we're going to look at the state clone and set the current game moves equal to an empty array, because we want to reset that. And then instead of saving it to the initial value, we're going to save it to the state clone that we've just mutated here in these two places. So at this point, if we've done everything correctly here, we should be able to add a new getter. So we've got the current game, and then let's also make a stats getter. So this will be responsible for getting us the total number of wins by player. And to start us off, let's just console log this dot get state. So we'll go back to our game. Let's play at least one round and reset. And so right there, that should have pushed it should have pushed a game to history. And since we're not actually calling this anywhere, it's not showing up. So we need to call that somewhere. We'll just call it at the end of the game reset. So console log store.stats. We'll remove that in just a second, but let's play one more game. So I think player one should have 2 wins at this point when we reset. So you can see in history, we have current round games is an array of 1, and it shows all the moves from that game, and then the status showing that the winner was player 1. And if we play this again, I'm hoping things will update correctly. Yep, so now in history we have 2 games in history. So if we keep playing these, that's basically what's going to happen. So at this point, player 1 has won 3 games, and you can retrieve all of those in history right here. So now our job is to go back to this stats method on our store class and actually derive some useful state that we can use to update that scoreboard down here at the bottom. So what I want to return from this, it should be pretty simple. So player with stats. What I'm going to do here is map through the players array, which remember, we initialized the constructor with players and then assigned that as a property of the class. So we have that, and we can map through and look at each player, and then all we're going to do is add whether they have a win, or add how many wins they have. So we'll calculate wins by looking at the current state, so this dot game, or I'm sorry, not this dot game, but we will look at the history. So we need to grab the current state, which is this dot, get state. So we'll say state.history. We're looking in the history of the current round games, and we're going to filter that, and we're going to look at the game and check for the status of that and see if there's a winner. And if there's a winner, we'll use an operator here that JavaScript has available to basically coalesce any undefined values when we're accessing this property. So we can pass ID and check if that's equal to the current player.id. So we're checking the player we're mapping through against the game status of the current game we're mapping. And at the end of that, we should be able to get the length of that array. So that will give us the number of wins that this player has. We will then, from this map function, we will then spread the player object to this object, and then we'll pass the number of wins. So essentially, this is giving us a list of players where it has this additional property called wins that will tell us later how many wins that player has. Furthermore, we then have ties, and that one's pretty easy. We'll just look through the history again, and this time we're going to filter it for games where the game.status.winner is equal to null. So that will tell us when we have a tie, if there's no winner, and we'll give it the length there as well. So now when we read the stats object, we should be getting a much different picture. So let's go ahead and play another game, And now we've got the stats object. We've got player with stats, and you can see that's an array of 2 players. And if we open up those players, we get all of their attributes, of course, and then we also get how many wins that they've had so far in history. We get the ties is equal to 0, and you can already see that we can basically take this information and just update the HTML to show that in these 3 boxes down here. So populating these will be relatively quick, I think. We just need to go to View and make one more helper method. I'll just keep putting it here at the top. Let's go ahead and say update scoreboard is the method that we're going to use. And I think we might need to put a data ID on some of these. Yep, so I'm going to put a data ID, and we're going to call this one player1 scoreboard. Or let's actually just make it shorter. P1 wins. So we'll copy that one down to player 2. So P2 wins. And then we already have a data ID because I guess I forgot to pull that out during our HTML build. So that's already there for ties. So if we go to our view, we just need to select these elements. We could just do it in this method. We really could do all of this in that method. I just like to consolidate stuff up here. So we're going to select the player1 wins, and this is going to be selected P1 wins. Let's make sure that's right. Okay. Then let's copy that down. Player 2 wins, and then ties. And then now we have these 3 elements to work with. So we can update the scoreboard by saying this $.$.player1 wins. And we'll set the inner text equal to, and then we'll get the number there, and we'll say that number of wins. So that'll be this.game, or I'm sorry, this.stats. Nope, never mind. We are in the view. I was gotta be careful where you're putting stuff. We don't have access to that information yet, so we're just going to pass that information directly to the method. So player 1 wins, player 2 wins, and ties. So we'll just pass that in, and then we'll take care of actually getting these values into this method later. Okay, so that method should update the scoreboard. We just need to call it from somewhere. So just checking, looks good. So we just need to call that from somewhere, and I think the best place to do that at the moment is to do it in the game reset event, because that's the only place that we are actually cataloging the end of a game. So after we have set the turn indicator, we're going to call from the view to update the scoreboard. And at this point, we're going to pass in store.stats.player with stats. We're going to select the first player and pass the number of wins. We'll do the same thing for player 2. And then finally, with the ties. We can get rid of this console log, and hopefully if that worked correctly, this will update things and our game will be sort of done. We've got an error. It says it cannot find elements, and that's because we did not save the index.html. So now it's finding it. And you can see player 1 has 1 win. Let's get player 2 to win 1. There's a win, and then if we can somehow get a tie going here, I guess that one's not going to work. I can't get a tie going. So we got player 2 with 3 wins, player 1 with 1 win. So that is the current history. Now the very last thing that we need to do, when we reset right here, it's not going to clear any of this. The only thing that's going to clear this scoreboard is the new round. So we need to implement that method. And let's go ahead and do that in the store first, because that's pretty close to the reset. So we'll say new round. And what we want to do with the new round is basically take all of the games that are in the current round games and push them to this all games array. And we're basically going to clear out this one and clear this one. So one way that we can do that, since we know that a new round is going to also be a reset, what we can first do is call this.reset. So that will take any completed games, put them into the current round games, and clear everything out. And after we've reset, we need a state clone, because we can't update state directly, just a best practice as we talked about. And what we're going to do is take the state clone, grab the history, and we're going to populate the all games with the most recent current round games. So one quick way that we can do this, because this is going to be an array, is we can spread that out to the push method. So state clone.history.current round games. So that will just push that to all games. And then at last we will take that current round games and set that to an empty array. And then finally we will save the state and pass in that state clone that we have modified. Now there's one thing that's going to be messed up, and it's probably not super apparent. So if we go through and play some games, and then we go and reset everything, let me see. And at this point, we really just need to hook this up to the view. So we have bound the new round event. And in app.js, we just have a placeholder here. So what we need to do is basically call the store, call for a new round, and then I think we'll want to clear everything. So similar to the reset, we'll want to close everything. We will want to clear the moves. So this is the UI, not the store. We'll want to set the turn indicator. And then we'll want to update the scoreboard. So this call actually needs to go first so that the state is updated, and then all of these will read from that state to appropriately populate the UI. So let's go try this. We've got so far, let's populate some state. So player 1 has 2 wins. If we click something and reset, it'll just clear the board, but keep this. If we go and hit new round, you can see that it clears everything, and now the scoreboard is also cleared. So at this point, we have a fully functioning game, and everything works, everything's being updated. The last thing that we're going to look at here is persisting state across refreshes. As you can see, if we play a game, and you get player 1 having 1 win, and then you refresh the page, this is all cleared out. And ideally, we would want to be able to refresh the page and still keep a record of the games in history. And the only way that we can really do that is by using local storage. Now, to make our game more persistent across browser refreshes, and additionally to allow 2 users to basically play at the same time in different browser tabs, we can use local storage. So if we go to the documentation for local storage, you can see that it is a property of the window interface, allows you to access a storage object for the document's origin. So it's similar to session storage, except that while local storage data has no expiration, session storage data gets cleared when the page session ends, that is when the page is closed. Local storage does not do that. So you can actually close the page entirely and reopen it. It will still be there. So it's just a little bit more persistent, and it's also available across browser tabs. So if we go to the event reference, let me see if I can find that. Let's click on storage maybe, and then look at storage event. All right, so this is what we're looking for, and we'll eventually implement this. But the storage event is implemented by, or the storage event interface is implemented by the storage event, which is sent to a window when a storage area the window has access to is changed within the context of another document. That is a long way of saying that basically you can add an event listener on the window for this storage event. And if you have one tab sitting open with our Tic Tac Toe game and a player is clicking in it, then that's going to trigger this event, and you can have another tab listening for this event, and it will recognize when that player has played in a different tab. So that will allow us to sync the two tabs together and allow us to basically have two players and simulate a more realistic game. So we're going to implement local storage, but as we know with local storage, you need a key. So we will implement that, but first let's get rid of our previous app. We can finally hit the delete button on that because everything's working in our refactor. Everything's a lot cleaner. And now it's time to go over to the store. And in the constructor to this store, rather than just passing players, we're going to also pass a key. And this key is going to represent the key of local storage that we're going to actually keep the data. So if we go to storage and we go to the local storage right there, you'll see I've already populated this because it's happening in the finished game over here. But the key is what's going to be referenced to get it and save it. And then here's all the game state that we're tracking. So let's go ahead and go back to our app, and we will give this a special key. So in app.js, where we initialize the store right here, we'll say live Tic Tac Toe, so T3 storage key. It could literally be anything. So we're passing that key, and now what we need to do is save that. So we'll say this.storage key is equal to key. And then this.players is equal to players. So that should be working. And then the last thing that we need to actually do is go down to our get state and save state. And now instead of saving this in memory on a property of the class instance, we're going to replace this with local storage. So that's why, as I was talking about earlier, this seemed a little redundant. Why would we access this through another method? Well, it's so that we can refactor it to this a lot easier. So we'll get rid of that instance property. And in the get state, this is where we're going to retrieve from local storage. But as we know, if the local storage is empty, it's going to give us undefined. So remember, at the top, we have this initial value, and that's what we'll return if there's nothing found within local storage for that key. So what we'll do is we'll first try to grab an item, and we'll say window.localStorage.getItem. That's a built-in method. And then we will pass the storage key that we initialized in the constructor of this class. So this is going to return us either undefined or the string representation of this value. So basically what we're going to return here is we're going to say, if we have found an item that is defined, we're going to parse it because it's a string. Otherwise, we're going to return the initial value as a JavaScript object. So in other words, we're going to return the same type. We're just falling back to this value. So that's the get state implementation. And then for the save state, we'll replace this call down here, and we will say window.localStorage.setItem, and this is going to be the storage key. and then we need to actually do the opposite of JSON.parse, and we need to stringify our object. So you can see here, this is where we're storing the new state after we've saved it. So we can just pass that raw object right here, and that should persist things to local storage just fine. Let's go back to our game and see if things are working better. So we'll play the game. Player 1 wins. You can see it's tracked down here in the scoreboard. Let's get player 2 to win a game. That's tracked down here. And now for the big tell-all. Let's refresh the browser. When we refresh the browser, it looks like there's 0 wins, but in reality, we're actually tracking this state. We just have one big problem here. And that problem is that on the initialization of the page, so let's go to our app. At the bottom, when we are waiting for the load event, we are not actually updating the DOM with the latest state. So you can see in the reset, the reset and the new round, we're calling all of these changes to the view. Well, we really need to call this on the first load of the page as well. And as you can see, we're repeating things quite a lot. So it would be best to put this in a little helper method. So we'll say init view. We can put that right there. And basically, when we init the view, let's make sure everything's closed. Let's clear all the moves. Let's set the turn indicator to whatever the current player is in state, and that state value is now coming from local storage. So we have some things that we need to update in addition to this in a second. So last, we'll update the scoreboard to be the current stats. And now we can basically call this down here in the reset. So we can get rid of all this and init view after we've reset the store. So that's just a little helper method for us. Let's check to make sure we didn't break anything. So we're playing the game, someone wins, and we reset. So it looks like everything worked. Now we've got 2 wins for player 1, 1 win for player 2, and if we refresh the page, still nothing is going to happen. But if we go down to, basically if we call this init view from the scope of the init method, then that's going to populate things because we're doing that on page load. So now the next time we refresh, we're going to stick with those 2 wins and 1 wins. We can refresh it as many times as we want. It's always going to end up in the same thing. But we have one last problem to really solve here, and that is what happens if there's like 3 moves on the game board. When we refresh the page, it's going to clear that, but you can see in state player 2 is up, not player 1. So we need a way to actually reconstruct the moves that have been made on the game board on the initialization of the page. So if you remember from our view, we had some helper methods, and one of those helper methods was handle a player move. And what that does is creates an icon and it replaces the square that belongs in. And all you have to do is pass it the square element that you want to replace. So one thing that we could do is we could loop through all the squares and basically update it in state. So we really need to implement this method. So initialize moves. And what we're going to be doing is calling this dot squares. So let's take a look at a previous implementation. So we're clearing the moves here. So let's move this up closer to that because it kind of relates. So when we're clearing the moves, we're just replacing children like that. But when we're adding the moves, we need to go through each square, and we basically need to check if there's an existing move in state. So this needs to pass a moves array of the current game moves, And then what we'll do is we'll check moves.find, and we'll look on that move for a square ID that is equal to the square.id, which is what we're looping through right here. And if there is an existing move, we're going to call this.handlePlayerMove, and now we can pass in the square, and then we can pass in the player that made the move, which is going to be the existing move.player. So that should initialize the moves. Let's go back to our app, and right after we init the view, we want to call view.initializeMoves. And these seem pretty similar, but when we init the view in the reset, we don't want to, actually it should be okay because the state would be cleared. So let's go ahead and put that as the last method here. So we'll reinitialize the moves, and since we've cleared the moves right here, or I'm sorry, not because of that, but in the reset event, we're resetting the store or new round on the store, so that should clear all the current moves, and this will basically be an empty call because it's not going to find any existing elements. So let's go ahead and save that, and let's refresh the page. Looks like we've broken something. Moves is undefined. Oh, because I haven't passed in the current state. So we cannot just call this with an empty function call. We need to pass in the store.game.moves. And now you can see that it's initialized. So no matter how many times we refresh, it's always going to reconstruct the latest moves of the game. Let's reset that. So it resets up here, and now we refresh and it's empty. Let's put a play down here, refresh, keeps that there, and you can see how we can just recreate the state every single time. So let's set this to a new round, which clears everything, including the scoreboard, and just play through one more time. Player 1 wins, player 2 wins, got 1 win on each side, and then play something there, refresh, reset, refresh, everything looks like it's working great. Now the real test, as I talked about earlier, is we should be able to play this in 2 separate tabs. So let me copy this URL and paste it here. So we are now looking at the same exact game running. But if we update in this tab and put an X there and then go to this tab, you will not see it update. And that's going to cause all sorts of problems because when we click here, it's really going to be out of sync with the other tab, and you don't really have a way to play this game. We have a pretty quick way to fix this. As I mentioned with this storage event, we just need to go to the app.js, and in our initialization, we can just listen for that event. So let's go ahead, let's find a good spot for that. So right here, this is where we're listening for the view events. We're initializing the view here. Let's put this at the very top, or actually let's put it right here next to init view. So we'll say window.addEventListener, and we're listening for the storage event. So this is when the other tab updates. It's not when the current tab updates, where the other tab updates. We'll put a console log in here. We'll say state changed from another tab. Let's just see what that looks like first. Okay, so we click and go to the other tab, and you can see the state changed from another tab. We'll click here and then see that state changed from another tab over here. So basically, every time the opposite tab changes, you'll get this event fired. We'll leave that there, and what we basically need to do is when that happens, we need to initialize the view again. So we're initializing the view on the first page load, and we're initializing the view when the storage changes. Let's go back, refresh the page, and reset everything. So we'll make a move. Let's first look at this board. This is empty. This tab is empty. And if we make a move in the top left corner, what I would expect now is that we'll get a console log on this tab, and we'll also see this X recreated. And you can see when I clicked there, we got it. Let's put an O in the bottom right. And you'll see when I clicked over to this tab, it showed up here and we got that console log. So that's just a cool little trick so that you can play in multiple tabs. Now, the last thing that I want to do before we go into the optional TypeScript refactor, that's totally optional. This has been obviously a long enough video at this point, but hopefully you've learned a lot, and maybe give a subscribe to the channel or something. But if you're still here, we're going to now kind of connect some dots. If you have not used React, you've probably heard of it. And React is what they call a reactive UI framework, although that is only partially true if you really look under the hood. But the idea, the overarching idea, is that in React, you program declaratively. I have a blog post on my website. So let's go to my website and go search for some concepts. And I've written about imperative versus declarative programming. And if you come down to the middle of this, you'll see a section called React Declarative versus jQuery Imperative. So far, what we have done is been programming imperatively. In other words, what that means, you can go ahead and read over these examples, but I'm about to explain it here in this video. When we program imperatively, that means that we are saying, okay, here's the outcome that I want, and here are the 7 different steps that you have to take to get to that outcome. Now, declarative programming is basically saying, here's the outcome I want, go figure out how to make that happen. And I think I have an example in this blog post about building a house imperatively versus declaratively. So if you're doing this imperatively, you're going to specify the steps. You build the foundation, you put in the framework, install the utilities, add the walls, finishing touches, so on and so forth. If you're building a house declaratively, the only step is basically saying, I don't care how you build it, but I want a nice fireplace, a lakefront view, and a big kitchen. So these are the outcomes that you are declaring that you want, and you let the builder of that house determine the best way to make that happen. So the same thing happens with the React library. Some people would call it a framework even. React is basically looking at the state of your application, and based on that state and based on the view that you have defined that links that state, it's going to figure out how to render the page to the screen. And if we look back at our program, we have a lot of imperative stuff going on. So we are binding to all of these different clicks. So when these buttons are clicked, we have a lot of very explicit steps written out of how we want the UI and the state to actually update. Now we can do a rather small, it's not going to be huge, refactor where we can basically take all of these individual steps and we can wrap them in a render method. From there, then the idea is that the render method is all that you need to call on the view, and then you need to pass the state of the application. So remember, the store gives us that state of the game right here, and then the stats. So that's basically our state, and all we need to do is pass all of that information to the view's render method, and then we can basically define all those steps to figure out how to show the page to the user. So let's try to do that. I think this will be a really nice way to clean this thing up for once and for all, and will kind of get us to our final state of this application, finally. Believe it or not, this init view method actually represents a lot of what we're trying to do. So we will be copying a lot of this stuff. So let's make this a little smaller, open up the view over here to the right. Actually, we'll make it a little bigger. That's kind of tough to see. So now that I've, talked about all this stuff in the render method, basically what we can do at this point is we can put a hashtag in front of pretty much all of these methods because they're all going to be called from within the render method. So these are all internal implementation details of our view class, and nobody needs to know about them except for the view itself. So you can think of all of these methods as basically just DOM helpers that we're going to call from the main render method. So these event listeners are going to be public methods that can be called from the app or the controller. And then we will have one render method here at the top. So we're going to call that render. Nothing significant about this name necessarily, other than convention. This is generally what you would call it, and when React was using class-based components, that was the method that you had to put all of your JSX into and whatnot. So this is more of a convention, naming convention than anything. So what we're going to pass into this is the store itself. And that store, as we know, has those getter methods on it. But I'm going to be more explicit, actually. I want to pass the game and the stats. You could pass the entire store object, and I think maybe in the final implementation that's what I've done. But we'll be explicit with this so that we know exactly what we're dealing with. So in other words, the game and the stats are represented by this method, stats, and this method, the game. And based on this information, we should be able to build our UI entirely. So let's start building this up. The first thing that we know needs to happen, no matter what the state of this application, we know that we want to populate this scoreboard based on the current state of the game. So that'll be the first thing we'll do. We'll call this .update scoreboard, and we have to pass in player 1 wins, player 2 wins, and number of ties. And as we know, we have all of that state available to the render method. So we'll come back to app.js, and you can see this is where we're extracting that stuff. But we can actually do some destructuring to make this a little easier to deal with. So from the stats, we can grab the player with stats and the ties. And then from the game, what can we grab? We can grab, let's take a look. We can grab moves, the current player, and the status, which we can also destructure, the is complete, and the winner property. So that's from the game. So all of these, this is just destructuring with ES6 to get these variable references so we don't have to define all of them or have this nested object property access going on. So with the update scoreboard, let's go back to our app and see how we did that. We basically just looked at the stats .player with stats. So this will be the first player, and we're finding the first player's number of wins. Player with stats 1, so that would be the second player, their wins, and then the ties will pass straight into that. So right there, we are rendering the scoreboard, and we can go ahead and start pulling all of this initialize functionality out of this method. So we can remove this, or actually we're going to replace init view with view.render, and this is where we're going to pass the store.game and store.stats. We will also pass this right here to that storage event listener, and now we can also pass it down here in these event listeners. So let's save that, and let's go back to our app, and refresh the page, and you can see that at least the scoreboard has been updated because we implemented that one method within render. So the next thing that we need to do, let's see, is probably reconstruct the game board. We can really just follow this init view. So we're updating the scoreboard. We need to close everything and clear the moves. So let's actually put that right above this. So this dot close all, this dot clear all the moves. We're going to update the scoreboard. Then we're going to initialize the moves. So that's going to cover a lot of ground just there. We need to set the turn indicator. I missed that one. So that one will come right here. And that one takes a player. So we need to pass in the current player that we're grabbing from the state. So that will grab the current player and set that. So now if we refresh and go back, we should see a good amount of stuff being updated. I don't think we'll be able to play quite yet, and we've got a moves is undefined. And once again, I've forgotten to pass the correct data to this. So we need to pass the moves from here down to the initialize method. Let's make sure we're not missing anything here. Okay, we'll save that. And right now we can't click anything because we have removed all of the functionality from the main app, but we can get rid of this. We'll keep this event listener because that's going to listen for changes on a different tab. This is our initialization, where on the first page load, it's going to render the view. Then on each of our reset and new round events, we're going to update the store and then render the new view. Our last thing to handle is that click event that happens on each square. So I think this logic can stay because this is just a check against the state, and it's going to return early if it finds there's an existing move on the square. So that's not view related at all. But right here, we are handling the player move, which this should be covered every time we call render, because all we have to do now is update the state, and then the render method will then figure out how to recreate the moves that the next state represents. So we can actually comment this out. We can also comment out the player move, I believe. Or I'm sorry, we should not do that. This is where we are updating state. This is very important. We need to update state with that player move so that the render method gets the latest version of state to actually recreate the game with. So we can remove this view.handle player move. This is fine. Then we check if the game is complete, and if it is, we'll open the modal. But we can actually do this check within the render method. So let's see, where's the best place to do that though. So we're closing everything, clearing moves, setting the turn indicator, update the scoreboard. So we can really just do this at the end. So we're really just checking to see if the status, let's see, we can just grab that is complete variable that we've destructured. So if everything is complete, the game's complete, we will call this dot open modal. And then from there, we will grab the winner and check if there's a winner. And if there is, we will pass in this string. Otherwise, we will pass in a tie. So this check right here basically takes care of all of this right here. And then at the end, we're setting the turn indicator. So maybe we should bring this one down to the very end of this render method, because we don't want to set the turn indicator until we know that the game is not complete. So we're going to return early if we see that the game is complete. Okay, so I think we can remove all of this from our method. So at this point, the player move event is really just checking state and updating it. So we're checking for an existing move. If we find it, we're not going to do anything with the UI. We're not going to re-render it. If that doesn't, if there is not an existing move, that means it's a valid play. And we're going to update state by making a player move. And then once we have updated state, we can render the view with the new state that we have retrieved. Let's go back to our game. It says this.handlePlayerMove is not a function, so let's figure out where we're trying to call that. I believe that's happening in the initialize moves. Yep, so right here, we just need, since we made this a private method, we just need to add that hashtag so that it can handle the player move, just like this. Let's go back, see if we got any errors, and it looks like things are being populated. So let's try to play again. All right, so when it detected a win, it says the store is not defined. So we're referencing something here incorrectly. Oh, okay, so over here in the render method, you can see I'm grabbing the winner name from the store, except that's not available to us. We really just need to grab this value right here. So we can get rid of all this and just grab winner.name. And so now we don't have any invalid references. And it looks like player one wins. So we can play again and it clears things. Let's play through the game once more. And you can see player one is racking up the wins here. We can reset to a new round. That works. We can reset the game board. That seems to work. And I think we should see everything populating across these two tabs, which appears to be the case. So that is also working. I know it's been a complete marathon here, but we just have two more things to improve on this application. I think they're just really cool additions to this app. The first one is somewhat easy to grasp. The second one is maybe not so easy. So you can feel free to kind of skip over either of these, but I wanted to add them in as a supplement to this video. As you can see in our app.js, we are calling view.render in a lot of different places. So you can see we're calling this like, what, 5 times? There's probably an easier way to do this. And one thing that we can do is go back to our store class and make one little update to this, and it will make our lives a lot easier and automate a lot. So right now this is just a plain ES6 class, but if we put the keyword extends, we can extend an event target. So if we go and look on MDN for event target, you can look and see that this is an interface that's implemented by objects that can receive events and may have listeners for them. In other words, any target of events implements the three methods associated with this interface. And if you look at the instance methods, we have add event listener, remove event listener, and dispatch event. This is basically what we've been doing with all of our elements. And by default, all of these DOM elements are going to inherit this class from this class. So we can also create a store that extends this, and that way we can send a custom event every time that store changes. So the first thing we need to do is, and I'm sorry, I think I extended the view, which is, I'm getting tired here. Let's remove this from the view, and instead we're putting this on store. So this becomes an event target. And then at the top of the constructor, we just need to call super. And super is the keyword that will basically allow us to inherit from this event target. So this is kind of some object-oriented programming concepts. But in other words, once we add super, we should be able to get access to those three methods. So let's comment out super and go to app.js and go to store. Let's see. It says that we can add add an event listener, but I think that's probably just confused. Let's reload. Oh, I'm sorry. That's because we called super there, but we need to remove this. So if we remove this for 1 second and then go to store, you're going to see that these are the available properties and methods, and you don't see add event listener anywhere because VS Code has not detected that as part of the interface. But the second we add this back and extend the event target and then call super, we will now have access to an event listener. And we want to listen to a specific event, and this event we're going to define as a state change. So we'll say state change is the custom event we're going to be listening for, and then in the callback to that, we're going to render the view. So we'll render the view with the store.game and store.stats, and that will allow us to basically remove the view.render from pretty much all of these. So we can remove it from here because when we call store.reset, that's going to trigger this event and it's going to call view.render. We can remove it from here. Same thing, we're updating the store, so it's going to trigger this event. And then finally, down here, we are updating the store, so it will trigger that event. As we stand right now, it's not going to do anything because we haven't actually dispatched any sort of event. But since we've consolidated everything into the save state method, we know that this is the only place in the entire class where state is actually being updated. So if we come down to the set item call for local storage, all we have to do is call this, which represents the store, which extends an event emitter, which has these properties available. We can dispatch an event. And what we can do is pass a new event. So event right here is just, let's go to the reference. Let me just type this in, mdn event. So the event interface represents an event which takes place in the DOM. An event can be triggered by the user action, clicking the mouse, blah, blah, blah. And you can basically customize this with whatever method you want. So let's look at the constructor. The event constructor creates a new event object, and you can pass a type to it, which is a string with the name of the event. So that's what we're doing, and we're calling it state change. So when state has changed, we're going to dispatch this new event, and therefore our event listener for the state change key is going to be fired, and we're going to render the view. Now, of course, we need to keep view.render in this event listener because that's not going to be fired here. These are two very separate events. This one is when the current tab state changes, and this is when a different tab state changes. And then finally, this one is the first load of the document. So let's save this and see if things are working correctly. So we refresh. It looks like we've got a problem. I don't know what happened. It looks like our live server timed out or something. So let's refresh that page, reset the game, and you can see on all of these actions that we're clicking, it's re-rendering the page. So clicking all of these actions, player one wins, we play again, it resets, we get a scoreboard update, and let's keep playing, player one wins again, and now we can reset the game, we can reset the round, and then if we click here, we can see that populated in the other tab. Actually, we cannot. It says must call super constructor before using this in the derived class constructor. Let's see what that's all about. Okay, I think that might have just been old. I just needed to refresh. Yeah, okay, that was just old. That was from when live server cut out. So now things are being kept in sync and we can play from multiple tabs. So let's win the game from this tab. player 2 wins, and we should see over in this tab the same message. When we reset, this is reset as well. So at this point, everything is pretty much complete. There's just one helper method that we can refactor that will make things a little more performant, and I'm going to just plug this in and you can kind of study it on your own time. So let's go ahead and look at the view. So I'm going back to the view here, and at the very bottom I'm going to add something called delegate. Now this is a pattern that I did not come up with on my own. This is kind of a well-known pattern when you're working with the DOM, and the purpose of this helper method is so that we don't have to do what we're doing up here, and that is looping through each of the squares. Not those specifically, but right here where we're binding an event listener to every single square element. This results in a lot of event listeners, and it's a little bit more performant and efficient to just register an event listener on the parent element, and then we can kind of match up which child element was clicked on that event and figure out which square we're dealing with for this. So if we look at the index.html, you can see that we have this entire grid, and then we have these squares. So wouldn't it be nice if we could just register an event listener on this grid, and then we can basically figure out which element was clicked within it based on that, helper method. So we can go back to view, and instead of doing this dot squares for each, we can just call this dot delegate, and the element that we pass is going to be this dot $grid. Let's see if we've selected that. It looks like we have not. So we'll say this dot $grid, and we will select the data ID of grid. Let's make sure that we add that right here. So now we're adding the event listener to this parent div. The selector that we're looking for is going to be a class called square or a data ID called square. So this will be a little bit more stable. So we'll use that. So we'll just grab an example here and then pass this as a square. And then the event that we're listening to is a click event, and the handler is going to be handled by the controller. So instead of looping through all of them, adding an event listener to each, we're just going to do it once with the delegate method. And I believe this should work for us. Let's go back to app.js and just get a sense of what's being passed here. So console log square. And when we click, it's going to give us a div with an ID equal to the square that we have clicked. So as we're clicking through this, everything works just the same. And that little refactor just made things a little bit more performant. And we're using kind of a pattern that you'll see quite often, is kind of the main reason I wanted to expose it here, is you'll see this out in the wild, and it's just good to know kind of what it's trying to achieve. All right, we're going to take a brief intermission here. Congrats on getting to the second part of this course. Be sure to like the video, subscribe to the channel. It really helps me out, make more free content like this. But anyways, we are now getting to the TypeScript section. And this is not going to be a complete beginner's tutorial to TypeScript. I'm not going to be walking you step by step to understand all the different features of TypeScript, but rather we're going to take the previous project that we just built and we're going to be refactoring it or migrating it to the TypeScript language. And by doing that, you're going to start to see how we use TypeScript and what the differences are. And I'm going to give you a hint. The biggest difference here is the JavaScript that we wrote previously could be shipped to the browser and run natively. The browsers know how to run JavaScript. It's built into the spec. But TypeScript and other high-level languages, it's a little bit different. We're going to need a transpilation step. So transpile, compile, kind of similar terms. Compiling is when we take a high-level language and compile it down to assembly language or ones and zeros. And transpiling is when we take a high-level language like TypeScript and transpile it to another high-level language like JavaScript. So to do this, we'll be introducing what we call a build step, where we have to run the build to transpile TypeScript to JavaScript, and then we can ship that to the browser and it will run natively. So that'll be a really important concept to learn and understand, and you're going to see that play out through this next part of the course. So once again, not going to be going through step by step with TypeScript. I'll try to include a couple beginner level kind of tutorials and tips, but think of this as more of a preview of TypeScript. Kind of here's what you're getting into as you learn this, and here's why it's important. So with that, I'm going to jump into the lesson and we'll get this thing refactored to TypeScript. All right, so the first thing I'm going to do is just copy this entire folder. So let's see, paste. All right, and then we're gonna call this a TypeScript, actually let's say live TS refactor. Okay, so here, forget about this for 1 second. We'll get to that. That's very important for this refactor. It was just in my git ignore. So just to overview, we've got an index.html file that's got some styles, and it has this script down here that connects to the app store and view. So the MVC pattern that we talked about in that prior video, once again linked in the video description. And here's the CSS file, nothing crazy going on here. Like I said, you need to be familiar with this application because I'm not going to explain it in any detail here. So the question is, if you want to move towards a TypeScript code base and you've got a vanilla JS code base to start with, how do you go about migrating it? If you are dealing with a very large vanilla JavaScript code base, this is not the video to teach you how to migrate that. This video is basically going to walk you through the most simple steps, the initial setup of a TypeScript app. So the first thing that we need to do and to understand is that when we're writing TypeScript, we will now need developer dependencies. So talking about like a package.json, if you notice in our original build, we don't have a package.json or node modules or anything like that because we don't need them. We can just write vanilla JavaScript ES6 syntax and run that directly in the browser. So there's no developer dependencies, there's no build steps, transpiling, any of that stuff. So the biggest thing you need to understand to start out is that we need some dependencies, and the dependency we need is TypeScript itself as well as the TypeScript compiler. Now, I'll be honest, I don't set up blank TypeScript projects from scratch every day. It's not a very common thing because once you get your stuff set up, you don't really think about it. So I'm going to imagine that you're starting from scratch trying to figure out how to get this started. And we're going to just use documentation to get ourselves there. So let's go to the TypeScript documentation. This is the first place that you would obviously go to figure this out. So there's a get started, a handbook, and a reference. These are going to come in once you're kind of well into things. The get started is where we want to start. So let's go ahead and look maybe TypeScript tooling in 5 minutes. Looks like a good starting place. So if we look at this page, it's going to tell us how to get started. So we can install TypeScript in two main ways, through NPM or Yarn or PNPM or whatever we're using, or by installing the Visual Studio plugins. Now I believe this is talking about Visual Studio, the full-on IDE, not necessarily Visual Studio Code. I think there's a big difference between those two. We'll get to that though. And it says you can install it just like this. But what I want to find out, VSCode TypeScript, let's see how it pairs with Visual Studio Code, which is what we are using here. It says, you know, TypeScript is a superset of JavaScript, blah, blah, blah. And it says it comes with the language support, but it does not come with the TSC or TypeScript compiler. So just zooming out for a second, remember, TypeScript is a superset of JavaScript. It does not natively run in any browser. In other words, you have a build step, or not necessarily a build step, but a compile step, where you have to transpile that TypeScript syntax to plain JavaScript. And once it's compiled to plain JavaScript, then it can run in a browser. So that's kind of our goal here. And to do that, we need the TypeScript compiler, or TSC. So here it's telling us to do the same thing as over here. So if we go back to Visual Studio Code, I am using the Yarn package manager. You can also use NPM, but we'll just say yarn global add. This is the same as npm-g or npm install-g. And I'm going to add TypeScript. And I already have it installed, but it will install the latest version. And there's the compiler and then the TS server as well. Now, Visual Studio Code, I believe, comes with this server. So if you hit Command P and you hit the little caret and then type TypeScript, let's see. It's not going to show up quite yet because we don't have a TypeScript file open. So let's just try something here. Okay, so we've created a TS file and I've added a basic type just to fill something up. And what you'll see down here in the bottom right is that VS Code has detected that we're using TypeScript, and it's kind of kicked off the TS server. I believe that's how it works. Leave a comment if I'm wrong on that. But if we hit Command P and then type a little caret, you can see that we can search for TypeScript and restart the TS server or reload the project. So just know that in the background, TypeScript, VS Code is working and actively looking through your code and recognizing the different types that are added. So let's go back to the documentation. It says building your first TypeScript file, and it's giving you basic TypeScript, and then it's saying you can compile it by passing the file name to the TypeScript compiler. And then I think it just goes through some like basic introduction to TypeScript, which this tutorial is not going to be necessarily an introduction to TypeScript, but more of a like, why would I need TypeScript and what does it solve for me? So it'll be a light introduction, but we're not going to really get into the meat of TypeScript. So let's go back and clear the terminal here. And with our index.ts, let's just define some variable equal to 20, and then let's give it a custom object type. Okay, so we'll say that some variable is a number, another variable is a string, and then if we assign this type to our object, now TypeScript is going to kick in and it's going to start telling you, that you've missed certain typings. So we've got these red squigglies because VS Code has detected that you are typing this object as a custom object type, which has these two properties. So we need to actually fill these in with their matching types. So if we put these in just like that and then finish off the object, now this is matching the type that we've assigned it. And if we tried to add an extra prop, it's going to yell at us because that does not exist in the type that we gave it. So anyways, the point of this is to just give a bare bones introduction to what TypeScript is doing and we'll see how this kind of plays out to benefit us in the refactor. For right now, I'm just going to compile this. So we've got the TSC, or the TypeScript compiler, installed globally. Let's go ahead and check. So we'll pass the version. It gives us 4.9.5. And now let's go and call for help. So this will basically give you all the options, which is pretty overwhelming to start with. But you can see that if we just run TSC, it compiles the current project. So let's pass this file to it. So tsc JS, and then no, we need to get into our live TS refactor first. Now we'll say tsc js index.ts, and you can see that we ran that command, and now we have an index.js sitting over here, which is the compiled version of index.ts. So let's open up the two files next to each other. And what you're going to see here is TypeScript in action. Over on the left is our .ts file. This is what we're writing our source code in. And we're able to use custom typings and assigning those typings to a variable. Now, looks like something is going wrong here. And it looks like the two files are actually conflicting. So let's name this, let's put something at the end there, and it will solve this error for us. So just know that because they're in the same directory and VSCode is pretty smart, it's detecting that we have two variables that are the same name. Now, this is not going to happen in our final code because we're going to configure it not to, but just know that that's what's happening here. But anyways, the point is that we've got a type here which is actually not valid JavaScript code. You can't run that in a browser or Node.js or any JavaScript runtime. So what the TypeScript compiler does is it removes this type, and it removes this type annotation right here, and it gets us to this just vanilla JavaScript object that can actually run in the browser. So there's really two questions that come out of this. Number one, why would we want to do this? What is the purpose of adding these types? And then number two, how do we get more control over how this compiles to this? Because there's going to be different options that we can use to make that transformation happen. And furthermore, we don't want them going in the same directory, because obviously that screws things up with, variable declarations happening twice and so on and so forth. So there's some configuration that we can do to make this better for us. So let's go back to Excalidraw here and come down here and say benefits of TypeScript. So you could definitely go through a laundry list of things that TypeScript helps with, and there's plenty of people that go and do that, but I'm going to keep it simple here and just give one or two reasons why it is beneficial for your code base. The first one is just code checking in general. So in other words, it's going to, if you're using Visual Studio Code and you're using TypeScript, Visual Studio Code is basically walking through all of your code base and making sure that everything talks to each other appropriately. So we will see this in action as we start to refactor. But if we go back to our original application, let me delete this index.ts file and then the index.js. If we go back to our original project, which once again, if you haven't seen this already, if you didn't watch the prior video, at least make sure that you've skimmed over the code and know what's there. If we go to app.js, and let's try to find a good example of this. So here's a good one. When we are calling view.render and we are passing in all of our state of the application, these state objects have a certain type. And as you can see, Visual Studio Code is giving you some, suggestions as to what types these are already, even though we're not using TypeScript. And it's just inferring this from the function definitions over here in Store. So it can read through the functions and it can see, what we are returning. So the return type here, and then it kind of infers, okay, what properties are on this object that was returned, so on and so forth. But if we go back to app.js, it doesn't really know what type anything really is. It can figure out the Boolean type, but the moves and the current player and the winner, these are all any types because it can't really figure that out with plain vanilla JavaScript. And what's difficult about this and hard to maintain as your project grows is as you're typing things, quite literally, as you're like typing on the keyboard and passing variables around in your application, it's very useful to know, are you passing something valid into a function? And TypeScript allows you to do this very easily. You'll really start to see this benefit as we start to refactor. So the second benefit that I have personally found with TypeScript is refactoring. So very suiting, for this video since we're refactoring stuff. But if you have a big code base and you're trying to go through and refactor an entire feature, it is extremely difficult to do so if you just have vanilla JavaScript and you don't have any strong typings throughout your application. With TypeScript, it's a lot easier because as you change things, Visual Studio Code or your editor that runs the TypeScript server is going to be able to tell, hey, did you move things around correctly? And are you passing, is your refactor going to break the compilation of the code? But enough talk, let's get started. So the first thing that we need to do, now that we've got TypeScript installed and we kind of understand the general concept of what's going on, is get it set up for this specific application. So I know we've got it installed globally. If you use TSC and type the version, that binary is installed on our computer globally. But it's always a good practice to install it as a developer dependency within your project. And the reason being is, the global version is going to be different on each developer's computer. So if you're collaborating on a project, it's good to pin that TypeScript version for the application so that you have predictable builds and compiles when you compile that code to plain JavaScript. So to do that, I'm going to type yarn init and pass the -y flag just to say yes to all the options and just get a package.json file created. So here's our package.json and we've got live TS refactor, blah, blah, blah. And the first thing we'll do is yarn add and then pass a -d for developer dependency. And then I want to install TypeScript. So now you can see dev dependencies has TypeScript. Now, why is this a developer dependency and not a regular dependency? Well, this is super important, and the reason being is because, as we talked about, TypeScript is only going to happen before you deploy your application. So you write all your code in TypeScript, but obviously that's not correct, or it is correct. It's not valid for running in the browser or a Node.js runtime. So before you deploy your application, out on some server like AWS or Render or DigitalOcean, what have you, you need to first build it to the appropriate runtime that you're using, which is probably going to be CommonJS or ES6. So the point of having this as a dev dependency is to express the fact that you're not going to need this to actually run the application. You just need it to build the application to the point where then it can run. The next thing that we need to do is initialize a tsconfig. So this file is going to be a special file that sits in the root directory of your project, and it tells this compiler. So remember, TSC is the compiler. We don't want to use the global version anymore. So in this case, we can run yarn tsc to grab it specifically from the project, and then just run that, and it's going to try to compile stuff, but it doesn't find any TypeScript files to actually compile. So anyways, we need to set up a tsconfig to tell it how to compile things. So how we do that is we say yarn tsc, I think init is the right thing. So let's go to help and let's read through the options. Okay, so here's the start of the options, and you can see tsc --init creates a tsconfig.json with the recommended settings in the working directory. So that is what we want to do. So we'll run yarn tsc --init, and you can see that it created a new tsconfig.json, which we can open up here. And these are the options that it gave it by default. So let's go read through this. And right off the bat, you can see that there's quite a lot going on. So by default, it's going to have everything commented out. And we're going to get rid of all of this. These are just kind of all the different options. And you can go to this link here to view the reference for this. So the tsconfig. And it basically just takes you through all the different compiler options. You can click on these links to figure out what they do. But most of these options are not going to be relevant to, starting out, especially for a beginner. These are more of just options to control, your developer experience as you're building in a TypeScript code base. And also, of course, how it actually builds and compiles the TypeScript to JavaScript. So let's go ahead and get rid of all the comments just to see what it gave us. So these are the defaults that you're going to get, and we'll go from the kind of least important to most. Starting from the bottom, skip libcheck. This just tells TypeScript to ignore kind of the node modules .d.ts files. That's not super relevant here. Strict true, this is always going to be a good thing to turn on, because as you go through your code and write TypeScript, the IntelliSense that's provided by Visual Studio Code will make sure that everything checks out and all the types are consistent. So this is always good to have on. These two options are just related to some maintenance of your code base. So forces, file naming consistency. This allows you to have interoperability between CommonJS modules and ES6 modules. So I actually wrote a whole post on this. If you go to my site, scripts versus CommonJS versus UMD, AMD, and ES6 modules. So this is a mouthful, but this kind of explains what that is talking about. And then most importantly is the target and the module options. So this is telling the TypeScript compiler what kind of code that needs to be output into, code that can actually run within a browser. And that's our goal, is to get our TypeScript files to run regular JavaScript files so that we can just write our code in TypeScript, and then the compiler deals with getting that to a place where it can run in the browser. So let's go to the reference. We'll go to the reference guide here. So we'll start with the first one, which is the target. Now, I believe this is going to be in the, let's see, where is this? So just to orient ourselves, this is the compiler options field. So if you'll notice, all of this is defined in compiler options. And here in the language and environment section, you'll find target right here. Let's click on that. It'll scroll down, and it says modern browsers support all ES6 features, as we've been talking about, and we wrote our original project in. So ES6 is a good choice. You might choose to set a lower target if your code is deployed to older environments, or a higher target if your code is guaranteed to run in newer ones. So in other words, what target represents is the end state of the code that is going to be compiled. So We are going to target ES6 because that is going to mirror what we did the original refactor, the vanilla.js one. So you can see we've already got that ES 2016. You can pass a couple different options. I think it gives you all the options right here. But ES6, ES 2015, ES 2016, all the way up to ES Next. So let's just grab ES6 because we know that that's available in all browsers. I'm not sure why they did ES 2016 when they say ES6 is a good choice. Kind of mismatch in their defaults. But anyways, this is what the code compiles to. The next one is module. So let's go look at that. We'll go back to the top, and if you see modules, you will find the module property. This sets the module system for the program. And see the modules reference, you very likely want CommonJS for Node projects. So not to backtrack at all, but going back to that post that I wrote here, scripts, CommonJS, ES6 modules, this really talks about these different module systems. But basically, if we look at, let me do a sample file. So sample.ts. Basically, if we look at, this syntax, import something from some library. This is what we would consider ES6 module syntax. Now, if we did something like this, const something equals require some lib. This is going to be CommonJS syntax. So the require syntax and then also module.exports at the bottom of your file, this is all going to be CommonJS syntax. Now, if we do ES6, once again, it's import something from some lib, and then you can come down and you can export, some object or export default, and this will export things from your file, which is one-to-one with a module. So that's what that is talking about. And you'll see that it defaults to CommonJS, which again is a little bit of a mismatch. It says the default is CommonJS if the target is ES3 or ES5, ES6 otherwise. I'm not really sure, given this documentation and the fact that we're on the latest version of TypeScript, why it defaulted to that, but we really want to just have ES6 because we want to deal with that nice module syntax that ES6 comes with. And then going down the list, ES module interoperability, as I said, is the ability to basically combine the syntax that we just went through and have files from multiple module systems being able to compile together. This is going to be important, especially if you have certain, libraries that still use old CommonJS module systems, or newer ones that, use ES6 modules and don't support CommonJS. So having that interoperability is really nice, especially in larger projects. So at this point, we've gone through most of this, and once again, you can read through the documentation if you have questions on any other properties. But for now, I want to build a sample project just to get our bearings here. So let's make a folder called test.ts. And this is just going to have a test.ts file, just something to work with. And in this file, we're going to just, define a sample type. And the sample type is going to have a name, which is a string, and an age, which is a number. And then we will say, let's actually call this a person type. And then we'll say const person is a variable, and this will be of person type. And then we will just give it a string, so Bob, and then age 50, something like that. So this is our basic TS file. Let's save our tsconfig. And now we should be able to compile some things. So the first question is, well, how does it know where to look? How does it know that we want to compile that test.ts file? Well, let's go ahead and try it. So yarn tsc and run it. And it says done in 0.73 seconds, and it obviously found the correct file to compile. So the question is, how did it actually know that? Well, let's go to the documentation and look outside of the compiler options at the top level options. Let's go to include. And this is an array that specifies an array of file names or patterns to include in the program. And then over here in the default, the array if files is specified, all otherwise. So as you can see in our code base, we ran the tsc compiler and it automatically just looked for any .ts file in the entire folder and compiled it. And that's because it's got this default glob that is including everything. So given that behavior, I think we're fine. Now the problem with compiling your TS files in the same directory as where they're written is it just starts to get really messy. And then furthermore, you really want to output them into their own build folder. Now there's a lot more to this subject in general, like creating a bundle, and that involves things like Webpack or Parcel or whatever have you. Now there's a lot more to this specific subject. We could talk all day about, how things are compiled, where they're stored, all that kind of stuff. This gets into bundling and code splitting and, build tools like Webpack or Rollup or Parcel or whatever. We're not going to get into that because we don't need it for this simple of a project. Our goal is to basically take all of our TS files and put them in one spot, and then that will be imported to the index.html, and it will run just like our vanilla project would. So to do that, we have a option that we can specify, and let's see where it is. So looking under emit, this is probably where we want to look. And yes, here's the out directory. This is, if it's specified, .js files will be emitted into this directory. The directory structure of the original source files is preserved. See root directory if the computed root is not what you intended. So that's probably not going to apply for us. But you can see it gives an example where it outputs to a dist directory or distribution, which is a very common directory to output compiled files. So that's what we're going to do. We'll come back to compiler options and give it a out directory. You can see VS Code knows all these options, gives you some autocomplete. So if we specify out directory, gives us the documentation, which is very useful. And we're going to say that we want to put this to the dist folder. So we're getting some errors here, and that's because we need a comma. And once we save this and we rerun the compilation, now it's going to output everything into dist. And there's our test.js file. So you can see use strict is put in there, and we've got a person compiled. You'll notice that from earlier in the video, this is a different syntax than we saw earlier. Earlier we saw this was a var and there wasn't any use strict going on at the top. And that's because we didn't have a tsconfig. We didn't have all of these targets and modules that were specifying how we wanted things to be output. So anyways, this is the basics of compiling a TypeScript project. Now, our next order of business here is to look in our JS directory from our original refactor and convert these files to TypeScript. So I'll leave this test.ts folder for us. Let me get rid of the .js compiled file because that's now going to be over in dist. One thing that you would want to do here before we get too far is add a git ignore if you're working with Git, and put the dist directory as well as node modules because we've added both of those. Neither of those need to be uploaded to source control because Node modules obviously can be installed by yarn, and then the dist directory is the build itself, which is going to be created with yarn tsc. So let's close out tsconfig, and let's start in the app.js file. So now that we're working with TypeScript, we can just rename this to .ts, and now VSCode is going to automatically recognize that this is a TypeScript file, and it's going to start underlining things, and it's going to yell at us for all sorts of stuff because nothing is typed here. Now, there are some strategies that you can use to migrate a JS project to TypeScript, but in our case, things are small enough that the best strategy here is to just rename all of these to TS so that we're dealing with TypeScript across the board. Now, if we were to go through and just try to compile this right now, it's going to throw all sorts of errors. And the reason that it does that is kind of the whole purpose of TypeScript. And that is, it's going to check the types and make sure that they're all compatible across all the files with the imports, exports, function calls, parameters, all of that stuff. And that's a good thing. That's what you want. But when we first start out and everything has these red squiggly underlines and TypeScript is really mad at us, it's not so fun. But I'm going to work through this. It's not as intimidating as you'll think. And we'll get this thing worked out shortly. So just as a reminder, the current project is no longer going to work because in index.html, we are importing app.js, and that does not exist any longer. We have app.ts. If we tried to replace this, it's just not going to work because TypeScript is not valid in our JS runtimes. So what we really need to adjust here, I'm just going to do this right off the bat so that we don't forget, is now that everything's being compiled to the dist directory, we need to now specify, instead of JS, we're going to look in the dist directory and import app.js. So same thing as the original project, it's just going and looking in a different directory. Instead of the source code that, in our prior refactor was able to run in the browser, now we have to use the compiled code. And you can see in dist, it's going to maintain that folder structure. So we actually need to say dist/js/app.js. And you can see that it will, this has been compiled. It threw a bunch of errors, but it still compiled it. So we could probably get this to work actually. Let's just see real quick. The way that we'll do this is we already have live server running. I had this before the video. So it's on port 5500 and we're looking in dist JS app.js. So let's go to the vanilla refactor, and instead we'll go to the live TS, or let's go to localhost 5500 live TS refactor, and let's see, it seems to be working. So even though there was all those type errors, it still compiled the JavaScript, and this makes sense because TypeScript is just a superset of JavaScript. So while not all TypeScript is valid JavaScript, all JavaScript is valid TypeScript. So in other words, when we went to compile these vanilla JS files just in a different form, it still knew how to do it. It just was complaining about all the types. So in this case where we're migrating an existing vanilla JS project, this behavior is actually good because we can, gradually migrate our code over and not break everything from the start. So there are some options though once we get to a more final state. If we go to the documentation, let's close some things out here. If we go back to this reference, there should be some sort of configuration property that allows us to basically fail the build if there are any errors. So we ran yarn tsc and it's going to give us all of these errors if we just look through them. But it's going to still compile all those files to our output directory. But just to demonstrate how you can change this behavior, I'm going to get rid of the test TS directory now, just so that that's not clouding anything up. And then I'm going to completely delete the dist directory. So that's okay, because remember, we can just run yarn tsc and it's going to create the dist directory. Interestingly enough, now that we deleted that other directory that had TypeScript, this now does not maintain the JS directory structure. So before I forget, I'm sure there's an option to change that. But before I forget, let's go and remove that path. And if we go back to our browser, let me get rid of this. Let's refresh and we can still play our game. So this is looking at the live TS refactor. So it's still working, but if we go to the options reference, there should be some options in the emit. So if we're scrolling through, there's this option called no emit on air. And I think that's what we want. Let's just scroll through a few more things. Okay, so let's click on no emit on air. This says do not emit compiler output files like JavaScript source code, source maps, or declarations if any errors were reported. This defaults to false, making it easier to work with TypeScript in a watch-like environment where you may want to see results of changes to your code in another environment before making sure all errors are resolved. So let's just take this property, no emit on air. We'll open up our tsconfig, and we'll throw this at the end. So no emit on air, and this defaults to false, but we're going to say true. Now let's once again delete the dist directory, and let's try the yarn tsc to compile our TypeScript files. And now you'll see that even though we ran this, there's no dist directory, because we've said if there are errors, do not emit any output files. Now once again, we don't really want this, because when we are converting our project over, we want the ability to just compile the TypeScript files with errors so that we get a build output. And then in a final state, you might, once you've converted your project over, you might add that back or have other sort of build checks to make sure that you get a clean build before you deploy your application. So now that we have everything set up and we've got the app working with this dist directory, we will just jump into this JS folder. It's probably not the best name for it anymore, JS, but technically TypeScript is a superset of JavaScript, so it's somewhat valid. But what we'll do is we will start, I think rather than starting an app, which kind of consumes both the store and the view, let's just start with the store, because it's always good to define the types of your state at the beginning. That just kind of helps you inform, the rest of the files and the project design in general. So this is just in general a good place to start. Now in this folder, I'm also going to make a new file called types.ts. And this is going to be a module that exports a bunch of types that the rest of our files are going to consume and pass around to keep things more clear in our heads and to also satisfy the compiler. So let me just reference my final to make sure I'm getting the right types here. Okay, so let's close this out. Our types will go on the left, and then we'll put our store on the right. So the first thing that we'll see as we're going through, aside from all the red squigglies, is this initial state. So this is the shape of the object that we're storing in local storage, as you can see here. So if we open up our app and inspect, and we go over to storage and local storage, you'll see that I've already played the game, and you can see this updates on every move. And if we open this up, you can see the parsed value. So we've got the current game moves, the history, all games, current round games, And then you can go through and just see all of the moves that have been made by the different players. So that is the shape of that object that we're storing in state. Now, the benefit of TypeScript is to just have confidence over, the types we're passing around. So it would be a great idea to define that state. So in TypeScript, you define a typing with either the type keyword or the interface keyword. The difference between the two is a discussion for another day. I generally prefer types, but some people will get very heated with a discussion about which one is better in which situation. But we'll start with just a type, and I'm going to call this the game state. So game state is an arbitrary name I'm giving this type, similar to how we would define a variable name. And the type is defined using, basic object syntax. So I'm just going to match this. So let me copy this shape over and get rid of this comment. So right now, this is not really a valid type. It's not really complaining about anything, but this is not a valid type. Let's go ahead and give this a type of, let's see, current game moves. Let's just say it's any for right now, and it's going to be an array. So it's going to be an array that has objects that have any shape. So this is just our starting point. Now we need to define all of these types right here. So this is kind of our final thing that we need to get to, but we need to decompose our types into smaller units so that we can pass them around our files a little bit easier. So the first thing I want to do is define a player. So you can see that we've got squiggly lines under the player's param or argument that we're passing into the class constructor. And if we were to open up the app.ts, you can see the players array that we've defined. So let's give a type to these objects. You can see that they have the same exact object shape. So we can give this a representation of player. And a player is going to have an ID, a name, an icon class, and a color class. Now these are the actual values, but we want to give these a type. So a 1 is going to be a number type. Player 1 is going to be a string type. The icon class is also a string type, and the color class is a string type. So here we have defined a player type. Now you'll notice that all of these just have regular, primitive typings, and they don't have anything crazy going on here. Now with TypeScript, you can make a property optional by adding a little question mark after the property, or I guess I'm not sure if you'd call that a property, but you put this question mark here, and now the color class would be an optional property. So you can hover over it and it says it's either a string or undefined. And if we remove that, it is just going to be a string. For our game, since this is a configuration property, we want this to be all required properties. So this is the correct shape. So now what we can do is go back to Store.js and move on to the next type that we'll need. This does not satisfy anything that we've got going on here, but it will be a building block for us to work from. So the first thing I want to do is define the current game moves. So what is a move in our game? If we scroll down to player move, you can see that what we're pushing to state is a property with a square ID and a player. So we just defined the player interface or type, but what is square ID? Well, this is just going to be a number, and we can define this as a move. So let's call it a move, and it's going to have a square ID, which is a number, and then a player, which will basically be this type right here. So if we hover over move, you can see that this is the type that we've given it. We can now take this move type and replace the any type in the current game moves with move. So now the current game moves is an array of moves, And that lines up with what we've done here, where we are pushing a move to the array of current game moves, which is our state. Now, to figure out what we're going to type the history object with, we need to go down into the store class and figure out what we're doing. So in the reset method, what we are doing is pushing games to the history object under the current round games property. So this is the type that we're looking for. We are pushing an object that has a moves property and a status property. Now, it's pretty clear what moves represents. Moves is going to be what we just defined, an array of moves. So we can start with that, and we're going to call this a game. So a game is going to be represented by an array of moves, and then we have a status property. We don't really know what that is yet, so let's give it a type of any to start with. And now we can kind of go look through our code base and define what that type is. So if we track backwards and look at status, it's coming from a destructured property off of this.game. And if we look what this.game is, that is a getter method on the class, and the return type of that getter method is all of this stuff. So we have a moves array, we have a current player, and we have a status. This object right here, the status, is what we are trying to define. So let's make one more type called game status, and that's going to be an object with an isComplete property, which is going to be a Boolean value, as you can see. And then the winner is going to be a player. So the winner is going to be represented by a player, which we defined right up here. So now we can take this game status, and this is going to be the representation of status within the game type. So once again, we're coming down here, and this is where we're pushing a game to the history of current round games. We've got a moves property, which is now represented by an array of moves, and we have a status property, which is now represented by a game status, which has this type. And now we're finally ready to replace some things here. So we have a game and a game status. Let's put game right here for current round games. Now the last thing we have to fill in is the all games. We have to figure out what type of array that is. And I'll just save us some pain of looking through this and just say it's going to be the same thing. So the current round games and all games going to have the same exact type. At this point, we have defined all of these supporting types for our game. And in this case, we had just looked at our reference code, our JavaScript, and we are basically just looking at, what kind of objects are we passing around? What are we returning from our different functions? And we're just looking and analyzing our code to see that information. If you were starting this project from scratch and you intended to use TypeScript all the way through, this is actually a great exercise to go through before you even write any code. Defining the types of your game is a great way to define the functionality behind it without writing any code. It's actually one of the first things that I will do when I'm building a new feature, is just map out the different types that I'm going to be dealing with. And then I'll figure out what functions do I need, what types are going to be accepted as arguments to each of these functions, what are the return types of these functions, so on and so forth. So as you can see, TypeScript is already making us think a lot more clearly about what types of objects we're passing, objects, arrays, so on and so forth, what types we're passing through our code. And it makes us a lot more explicit about that and more organized. So if we go back to our Excalidraw, where I was briefly listing out the benefits of TypeScript, I think one of the other benefits is makes you think more clearly and explicitly about your code. So that's what we just experienced. We're having to explicitly type out our game. Now, at this point, we still have squiggly lines, and that is because we have not assigned these types to anything here. So I will keep both of these open. I'm going to just collapse this a little bit. And let's just start working from the top of our file. So the first thing let's look at is the constructor. With TypeScript, we can add types to things by adding a colon and then giving it a type. In this case, the key is our local storage key, and that's just a primitive string type. So we can just pass that in directly. We don't need to do anything over in our types file because, we don't need to redefine a string. Now, players is going to be an array of players. So we'll give it a colon, and then we will say player and then array. So that is going to be the type we're dealing with. Now you can see that it figured out that type already, even though we didn't import it. Now, this is not always going to be the case. It works okay here, but generally what you'd want to do is import that type explicitly. So with ES6 modules, what we can do is import a type, and then that type will be called player, and that type will come from the types file. So types.ts is what we're looking for. Now you're going to see an import path cannot end with a ts extension. Consider importing types.js instead. Let's Google this. It's probably some configuration property that we missed. This person is just saying that we can just remove the extension. Let's just try that. I don't think that worked. Now it's saying that types.ts is not a module. Oh, I actually know what's going on here. I'm sorry, I messed this up. So these are all just scoped to the types.ts file, and it's also not saved. So that would be a big problem that we cannot import that. So the first thing we do is save this file. That will help us out quite a bit. It will not solve this error because we have not exported any of these from the file. So to use them throughout our code, we need to export them just like we would export, if we had some variable equals 20, and then we export some variable or export default, something like that. Or we could just export it like this, and it would do the same thing. And now we can, import some variable from the types file. So that's just a regular JavaScript variable. I will get rid of this, and let's keep exporting all of these. Okay, so we've exported all of our types. Let's save it. And now we should not get so much grief from the TypeScript server. Now there's no red squigglies. We've got the player type, and you can see we can hover over it, and you can see that type, which is really nice to just be able to hover over this. You can also hover over it down here. And now we have a strongly typed constructor, and it knows exactly what's being passed in. But at this point, we get these problems. Storage key and players. These are instance properties of the store class, and since we have not explicitly typed those, it's complaining. Now, one way that we could do this is come up here at the top and say that storage key is a string, and that will satisfy it because we're passing in this key, and then in the constructor we are assigning this to a string. So there's actually a shortcut to doing this, a more concise way to do it. And instead of calling this key and then this storage key and having that mismatch there, we can short circuit this, delete that, rename this to storage key. And so far it's not going to do anything. So if we tried to assign this .storage key equal to storage key, it's not going to work. We can remove that entirely. Now this is not going to work, but if we say this is a read-only property of the class, it will define it so that we can access it later in the class. So if we go to the bottom where we are saving the state, you can see we're accessing this .storage key in these two places, And if we hover over that, it's going to know that it's a string. Now, if we come to the top and we get rid of that read only and just leave it to storage key, it will complain about that because it says it does not exist on the type store. So all we need to do is give it a read only, and you can also give it either a public or private just to define whether it's accessible from outside the class or not. We'll call it private because only the internal methods of this class can access this. And then same goes with players. So once again, we can delete all of this, and this can just become a private read-only array of players. And so right here, this is basically the shortcut for passing in these parameters and then assigning it to the class all in one step. And you can see if we look for this.players, it knows that it's of type player. All right, so we're getting closer. We're seeing a lot less little squiggly red lines. We just have a few more things to work out in this file. Let's go ahead and start here at the bottom. This is pretty isolated. So this state or function has an implicit any type, which basically means TypeScript is yelling at us because we haven't defined any type. One thing that we could do if we really wanted to, as we are refactoring this and migrating our code base, if we change strict to false and save that and then restart the TS server, you'll see that this no longer complains about this at all. We can define this as an any type and TypeScript's not going to be mad about it. This, of course, comes with the detriment that now you don't have any red squiggly lines to tell you where you've messed up. That is why most people would encourage you to put on strict mode. Restart the TS server here. But I just wanted to show you that just so you can see. Now let's start at the bottom here. Again, state or function. This is a great use case for TypeScript. This is where your life becomes a lot easier. And that is because in this case, we are allowing someone that is using this function to pass either an object that represents state or a function that we will pass the previous state to, and then it returns a new state. So two different types of parameters that you can expect here. And so we can type this a lot better now that we know, or now that we're using TypeScript. So saving the state, we are going to be passing game state. So that is the type that we're looking to pass in there. So we'll say game state, and it's going to complain about this because it cannot find that name. Let's go to the top and let's import game state from our types. So we're importing that type. Now it's not complaining anymore, but it complains right here because it thinks, this function thinks that state or function is just an object that is represented by game state. And right here, we are trying to call it as a function. So the problem here is that we've only defined one of the possible types. So here we can define a TypeScript union. Let's go to the documentation and briefly look at this. So let me make a new tab and TypeScript docs. Let's start over. And let's go to either the reference or the handbook. I'm a little surprised that we don't see unions starting out, but let's go to the basics. That's not what we're looking for. Let's just search the docs. So union. TypeScript unions, looks like TypeScript for functional programmers is where we found that one. But anyways, in TypeScript, union types are untagged. In other words, they're not discriminated unions like data and Haskell. I don't use Haskell, so I don't know what that means. But what this is trying to basically say is that if you put this little pipe character, that means that the type can be, either this or that. So it's kind of like an or an or operator, but for types. So you can read more about that, but let me just show you what this looks like. It's going to be game state or, and then this is where we define our function that we're looking for. So the function is going to be a separate type, and I'm going to actually add this to, let's add it to the top of the file. So since we're in TypeScript, we can just add types within our files. So we'll say save state CB for callback. And to define a function, there's a couple ways you can do it, but one quick way is to basically just give it an arrow function and tell it what it needs to return. So in this case, we want to return the game state, and we're going to pass the previous state, which is going to be a game state. So basically, I talked about this in the previous video when we did this build, but it's always nice in your save state function to be able to access the previous state so that you can derive that next state. So that's why we're passing this, but this is the type that we can define. And if we took this key right here, the type, and we passed it right here, save state callback, you'll see that there's no more complaints from the TypeScript server compiler because state or function matches the type that we gave, and previous state is not typed yet, but it satisfies that constraint. So I can actually take this to be a little more concise and copy that type itself and just pass it in right here. And then you need to put some parentheses around it, and that should work just fine. Now we can get rid of this. I just wanted to break it out so that it was more clear. Now everything's working here, but if we hover over previous state, that's going to have an any type, which no one's complaining about this here with TypeScript, but it would be nice to know what that is. One way that we can do this, and this is a little bit tricky with TypeScript, it's not super obvious, but when we do localStorage.getItem and setItem, it's not going to return a type. So getItem is going to, by default, return an any type, or actually, sorry, a string or null. And the JSON parse method, this is where it's going to return an any type. So what we want to do, if we want to actually give this a strong typing, is we will cast the type. So we can say json.parse item, and then this is going to be as game state. So now getState is going to have a return type of game state, and you can actually explicitly define that on the function itself. And if we remove this now and we say as string or something like that, it's going to yell at us because we're not returning the correct type that this function was declared as. Now that's for a whole nother day. We're not going to be typing all of our functions explicitly with return types. Some programmers really like that, to be explicit about typing all the functions. This is just a refactor, and I just want to get this working. So for the moment, I'm not going to worry about that. But just know that you can define the return types on your functions. So now that we have done this, we can come back here, and previous state will be a type of game state, and it still works to pass it into state or function. The game state can go into state or function because that is what we typed it as. All right, let's keep scrolling up. I think we have one or two more errors. The square ID, this should be very easy. Let's just give this a number. That's the expected type. Now, if we hover over current game moves, we would expect that to have the move type, but it does not. It has an any type, and I believe we can fix that. Where would we fix that? One thing we can do is give this initial state a game state type. So now anywhere we pass that, it's going to recognize it. So right here, the initial state is of type game state. So if we look here, the structured clone method is actually similar to localStorage, where it's a browser API, and by default it's not going to type anything. So in this case, we're going to cast this to a game state object because we know that this state is going to be represented there. So now where we're pushing to all games, it's going to recognize that current round games is of type game. So you can start to see how this comes together and how we are starting to get stronger types across our code. Okay, so I think the only thing we have left here is that red squiggly. Not saying that the red squiggles are your map necessarily. You obviously need to check other things, but just given the fact that we know that this code worked before and we have strict mode on, we can really use those as a guide for our refactor to find areas that we have not strongly typed things. So let's dig into this error. It says property includes does not exist on type number array. Do you need to change your target library? Try changing the lib compiler option to ES 2016 or later. All right, so it's gonna say 2016 or later. So this is ES 7, I believe. So let's target ES 2016 and then restart the TS server. And now you can see that will go away because that built-in method on an array is available in the ECMAScript 2016 spec. So we are, let me be clear about this, we are using ES6 modules, which tells us how we can export and import things from modules. And then we are compiling our TypeScript code to this standard of JavaScript. So that standard of JavaScript has this method. And at this point, we have completed this file. We've imported our types that we need, and there are no red squiggly lines, so that's a good indication that we're pretty much done with this file. Let's save that and go to the next one. So we are done with the store. Let's go to the view. This one will be slightly more difficult because we're going to have to deal with DOM element types, which are a little bit more confusing. So we've got a bunch of red squiggly lines here, but they're all coming from this query selector helper method that we defined. Let's go straight down to that. And let's start typing it. So the selector itself is just going to be a string. That's like the class or selector that we're passing into the query selector method. And then when we're typing things with TypeScript, something useful you can do is just hover over these methods. It's not going to work because we're using it on the parent, but if we go to the document, there's some built-in types for the DOM methods and global types. So document is of type document, and query selector, this will give you a stub giving you the types that are available here. You can see the selectors are of string. That's how I knew to give that a string. And then element is what's going to be returned from it. So we are going to pass a parent, which is of type element. And now we should see that's of element, and then query selector is now available on that. And we're passing in a string. So let's retype this to a number real quick, and you'll see that that's an invalid thing to pass to a query selector. So that's how we know that string is going to be the correct thing. And then furthermore, we can go to query selector all and just give that a string type as well. So these two methods are now strongly typed. And if we come to the top, it's still going to be yelling at us just a little bit. It's saying it expected 2 arguments, but it got 1. So what we have to do is come down to our methods. And in this case, the parent element is totally optional. So what we can do is pass a question mark right after that, and that will now make this an element or undefined. And that's okay because we are first checking with our ternary operator whether that parent argument has a value, and if it does have a value, we're going to use it. Otherwise, we're going to fall back to the document. So if we were to refactor this a little bit and intentionally break it, if we just tried to access the parent element and grab a query selector off of it and then pass the selector, it's going to work because Visual Studio Code already knew what we were trying to do. But if we remove that right there, it's going to yell at us because it says parent is possibly undefined, and you can't access a method like this on an undefined parameter. Now, you'll see that VS Code added this question mark here, which is the optional chaining. So let's type that in, optional chaining. This is actually not a TypeScript concept. This is an operator in newer versions of JavaScript, which we're using, that accesses an object's property or calls a function. And if it cannot find what it's looking for, if the type is undefined or null, as shown here, it will short circuit and evaluate to undefined. So the reason that works to do this is because this operator right here is just checking, hey, is the parent element defined? If it is, let me call this method. Otherwise, let's turn element to undefined. And then as you can see here, we're checking if element is defined, throwing an error. And if it's not, or if it is defined, we're returning it. So that technically does work. But in this case, we want to use this logic just to be explicit and say, if it exists, grab from the parent, otherwise fall back to the document. And that gives us assurance that we're going to find that element. So we've fixed all these red squiggly lines, but now we have a problem here. And it says property menu does not exist on type object. And you can see here we've defined this as an object. What we really want to do is retype this, and we're going to use a built-in TypeScript utility. Let me make sure I'm doing this the same as my example, or my final. So if we go to the documentation for TypeScript, let's go back and find ourselves the utility types. So in the reference, there's this utility types. And if you come over here to record, this constructs an object type whose property keys are keys right here, and whose property values are type right here. So this is actually leveraging something called generics in TypeScript, which is kind of beyond the scope of this video. You can look it up and read about it. But keys and type are going to be generics, and record is going to be the type that allows us to define something. So in other words, this is just basically defining a basic object. So right here, this is where we will type this. So remember, $sign is just a property, an instance property of the class. You could have named this pretty much anything. So you could have named this element, object, store, or something like that, but we're just doing this for a shortcut. And if we want to type it, we can type record, and then this is where we pass our generic values. So we want to pass a string because we're defining arbitrary strings as the properties of this object, and then the value is all going to be the same. It's going to be an element type. So if we pass in element, now things are satisfied here because we are passing an arbitrary string property name right here, and then the value is going to return an element, which, as you can see down here, we are returning a type of element, so that is satisfied. So all these are happy now, but we need to type the double $sign, which is the node list. Now, if you come down here to query selector all, let's just take a peek at what this element list is. It is typed as a node list of elements. So that is the native typing that the query selector all built-in method is returning. And you can see that's defined right here. So let's just copy that because we'll need it. Come back to the top, and now let's define this as a record where we can give it an arbitrary string. So squares is an arbitrary string property name. And then the type that we're going to give it, we'll just paste that in. So it's a node list of elements. And we'll initialize that to an empty object. And now the element list is happy because query selector all returns that node list of, and squares is that arbitrary property value. So it satisfies this type. So that's just a use of a built-in utility type in TypeScript using some generics. I just want to show you another way that you could have done this. So if you wanted to not use a utility type, what you could do is define a custom type. So let's say element object dictionary. That's just our type name that we're giving it. And here what we can do is pass in a key of string, and this can be an element value. And then we'll pass this element object dictionary. I'm sorry, it should not be of, it should be in string. So what this is basically saying is I want an object that can have an arbitrary number of properties, and the key of that property, so menu, menu button, menu items, is a string, and then the value of that property is an element as assigned here. So this type right here is really the equivalent to what we did earlier, where we said record string element and then closed it off. And if you really wanted to get fancy, you could do this with generics. So sorry, I'm going on a little bit of a tangent here, but this is just to give you an idea of the power of TypeScript. So we could say custom record utility. So what we're trying to produce here is the built-in utility record and just recreating that from scratch. What we can do is pass in a generic, so a key and a value. And usually with generics, you're going to put a T in front of it. That's just kind of a convention that I use to kind of signify or express this as a generic. And then we'll use the same syntax. So the key is in T key, and then the value is T value. Now we know in JavaScript the only valid type of property you can give an object is really a string. You can't just define an object like this and start adding numbers to it. Like this is, I guess this might be valid. Is this valid JavaScript? Oh, that's funny. I guess I don't know. I don't think this is valid, but let's just try it out because now I'm curious. I wouldn't be surprised. So we'll say this is a test. And it looks like it is. That is interesting. I didn't know that you could do that. I don't know why you would ever do this other than maybe a map, which is kind of similar to what that does. But anyways, I guess I learned something new today while making a tutorial about coding. That's probably not the best thing, but anyways, let's just be honest. So anyways, we want this to be a string. So let's just say it extends a string type, and now that's going to be fine. And then we can just replace this record with custom record utility, and it's going to work fine. Everything's going to be happy because we've basically just implemented that built-in utility type that TypeScript provides. So just an interesting tidbit that you can kind of mull over a little bit. So let's get rid of that because that is unnecessarily complex. You can see at the top here, I had imported the store just for JS doc typings when we had the vanilla JavaScript project. So now that we're using TypeScript, we really don't need to do that. So we'll get rid of that. So moving down, we can now implement the rest of these. Okay, so we'll move on to the render method. The render method takes two state objects And the reason I originally passed this as two separate objects is because we were not working in TypeScript. Now that we are working in TypeScript, I probably would just pass the entire state object as one parameter, but we'll stay consistent here. So if we look at our types that we've defined, we have a game type. So that one's pretty easy. We'll just type that as a game. And we need to import that, but instead of going to the top of the file and doing it there, I'll show you a little trick. So if you hold down on a Mac or on a command or on Windows Control, so command and then period, and VS Code will give you a suggestion, and usually it can find out where it's looking. Now it's looking for types.js, not types.ts. I'm not quite sure what's going on there, why it's saying that. I don't even know if there isn't a types.js. I'm not sure what it did there. But anyways, we'll add the type import just so it's not importing anything but TypeScript types. And then we can remove that extension and that should work. So now that's working. Let's see if it works on this one. So we need to do stats where I don't know if we have typed that yet. Okay, so I've actually, in my final copy of this that you'll see on GitHub, I've used a slightly different strategy. So we do not have a type already defined for stats. If we go to store.ts, the object we're looking for is this one. And specifically, we're looking for this return type, which has a player with stats, which is an array of players with this wins property added. And then we have ties, which is just a number. Now, if we hover over stats, it will give us this inferred type, which is correct. And furthermore, the store class has an inferred type that has all of the methods on it. So something that we can do is derive types from other types. And in this case, since we don't have a stats type, what we can do is go back to the view and we can import type store from store, and that will give us the store class that we had defined. And then here, what we can do is say store, and then we can actually access properties on that. So you can scroll down, just like we're accessing, properties of an array. We can scroll down and see all the methods and properties that we can grab from the store. And stats is one of those. So now stats is defined because we derived it from the store. Now, some would argue that this is maybe not the best way to do this. And I would probably recommend having stronger types and actually defining a stats type. But for now, this does work, and it's an easy way to get that type without having to define it. We can also grab the game getter from the store, which will properly type our game. And that is going to give us the correct types for the render method. And again, I'm using this to demonstrate something. In reality, you'd probably want to define these as actual types over here. And we do have that for game. So we could use game right. Oops. Scrolling around. We could just use game right there. But actually, it will yell at us because this game is slightly different. This is derived state. So this game is the state that we're storing in local storage. And then the game that we're trying to represent in this method is derived state. So in our store, remember we have this method called game, and we are reading the state, the raw state, and we are deriving some useful properties that we're returning for our game to use right here at the bottom. So obviously current player is not saved in local storage and not represented in this type. So I guess that's another reason why just using the store game is a good way to do it. But yeah, basically I would say that you'd want to type this function. Now coming down to the bind events, all these methods, the handler is of type any right now, but basically what we're passing to the handler is the callback of add event listener. So if you look at the stub for this add event listener, you'll see it's got some overloads, which is kind of an advanced TypeScript concept. But one thing you can do to kind of zoom in on some types, let's command click on add event listener, and this will take us to lib.dom.d.ts. These are the typings for the DOM that are basically provided already to us. And if we open up this in the file pane, I don't even think you're going to see it because this is kind of, I believe this is built into VSCode just to give you these typings. I could be wrong on that. But anyways, add event listener, it gives you a couple types that you can deal with here. And then you can hit command click on this, and then you just kind of go until you find the type that you're looking for. So event listener. And now you can see event listener is actually a type that we can use. So we don't even need to define it. We can just use event listener, which you can see is populated, and pass that right there. So event listener. It's always best to use built-in types if you can. If they're not defined, then you obviously have to type them yourself. But with something as common as an event listener handler like this, you can always expect that there's going to be a type already defined for you that you can use. So those are done. Update scoreboard. I believe these are all just numbers. So say number, number, and number. Here it's going to tell us something. Inner text does not exist on type element. I might have used this wrong in my original, actually. I think this should be text content. Yeah, so that's actually the right thing to use. I don't know why I was using inner text. It seemed to work though. So let's update all those. Open modal. Message is just going to be a string because we're passing a string of who won. And then we have the same error here that needs to be changed to text content. Coming down to initialize moves. This one is somewhat simple. We've already defined the move type over here. So it's going to be a move, but right now it's going to complain because it cannot find it. So hit command period and we'll update the import. And you can see that that actually added the move right there. And we're not using game anymore, so we can get rid of that. But now it's going to complain right here. And that's because I've intentionally messed this type up. We want an array of moves, not just a move. So to specify that, we can either say array, which is a helper utility of TypeScript, or you can just do it shorthand and pass the brackets at the end of it, which specifies that moves is now a moves array. So now this is valid and you can see everything's working. Just to start demonstrating the value of TypeScript, let's say that we removed this plus sign. So in the original build, I remembered to do this, but it's pretty easy to forget to cast the ID that you extract from the element target to a number. So what if I got rid of that? Now it's going to yell at me because it's an unintentional, because types number and string have no overlap. And what that's saying is we are doing a triple equals equality, which checks the type and the value. And we're looking at a move which has a square ID of number, and then the default event target ID is going to be a string. So element.id is going to type to a string. So these will never evaluate to true. Now we could of course remove the triple equals, and that would technically work because things would be cast, but you always want to use triple equals if you can. So here, that's just a very explicit example of where TypeScript comes in handy, is it reminds you of these little details that you might have kind of glossed over before. All right, so let's keep going. You can see that it's complaining here about icon possibly being null. And this is just a case where we could do better. So remember earlier in the prior video, actually, not this video, we defined query selector. And this is like a safe query selector where we are checking whether the element exists. And if it doesn't, we're throwing an error, which is kind of the behavior that we want. We don't want to proceed if we can't find the element. So one solution to this problem is to put a question mark there, because that will be the optional chaining that we talked about earlier, where we're saying, hey, let's check the icon, and if it's an element, grab the class list and add this to the class list. If it's not an element and it's null, let's just evaluate this to undefined and not throw any errors. Now that works. You could add that there and it solves your problems. But this is kind of an anti-pattern a little bit, because you throw this in here and all of a sudden your app is not grabbing this correctly and you're clicking your toggle menu and it's not working. Well, how do you find that error? It's better to be explicit about this kind of thing. So let's leave that and take some clues from TypeScript and refactor this to instead, let's comment this out and say icon is equal to this, and we'll use our safe query selector method. In this case, we're going to look for an I tag, and the parent is going to be this $.menu button. And that is basically how we can safely select that. And now icon is definitely an element because we're going to throw an error if it's not. So these calls down here are now valid. This is actually a concept called type narrowing that you can read more about in the TypeScript documentation. So I wonder if this is actually somewhere I can show you. Okay, yeah, so narrowing. And this whole page kind of describes that process of narrowing the types that I just explained here. Same thing goes right here. We can just copy this down and replace this. Let's get rid of this, and these two functions are good. Now, a couple more. The square element, you can see that we are replacing the children on it, so we know that that should be an element. And then the player is going to be a player, and command period to update that import at the top. Same thing here, this is going to be a player. And then finally, we get this fun delegate method that we really, it's tough to understand in the first place, and now we have to type it. But let's just walk, parameter by parameter and get this done. So element, pretty self-explanatory. This is going to be an element. The selector is going to be a string. The event key is going to be a string. And then the handler is going to be an event, what do we call this? We have an example of this right up here. Event listener. Now we've got a little bit of a tricky situation. So you can see right here, event target is possibly null. So okay, let's put that question mark, the optional chaining. But we still have this problem. Property matches does not exist on type event target. So we're going to use this narrowing concept again to narrow these types and get rid of these errors. So this is where TypeScript is actually helping us in a way. It's kind of making us more explicitly check things that we otherwise probably wouldn't. So the first thing that I want to do, let's get rid of this question mark. Or no, we'll leave it there for now. And we'll say if the event.target is an instance of element. So this is a way that we can check if the target is an element. So if that's an instance of the element, and we actually want to negate this, so if it's not an instance of an element, then we want to throw a new error. And we say event target not found. So this is just a guard that basically says, hey, the purpose of the delegate method is to delegate an event target and find something within it. And if we can't find that in the first place and it's not an element, then the rest of this method is useless. Like, we can't really proceed safely. So we might as well throw an error, exit early, and then the developer is, responsible for fixing that. So that solves one of our problems. The matches keyword or function now does not complain about anything. Now in the handler, it says argument of type element is not assignable to parameter of type event. And that is actually because I typed this incorrectly. In this handler, we're actually passing the element itself. So I have typed this as if we were passing the event, but really what we're passing is the element. So I need to type it accordingly. So we're just passing a function that is called with the element as the first argument, and it doesn't return anything. So now there's nothing wrong here and we're okay. But let's remove this question mark and see what happens. So looks like we're okay. All right, so we're good here. This works. It's typed okay. And I think this whole file is now strongly typed, and we're ready to move on to the final one, app.ts, and we're going to tie it all together and get it working. Now, just as a reminder, this app, really we haven't done anything structurally to it other than a few things, so it should still be working. And if we open things up and ran yarn tsc, let's look at the dist directory. It outputs everything. And then if we go to our page, let's inspect the page and go to the end of the body. And you can see the script is looking in dist-app.js. And if we click things, we can play the game still. So there's really nothing that we've changed, and it's been working this whole time. We're just trying to make our project more maintainable with TypeScript so that if we want to extend it in the future, it's easier to do so. Want to debug it, easier to debug, all that kind of stuff. Okay, at this point, by fixing those other files, we basically fixed a lot of the typings here in these files. Now, it's always nice to just be pretty explicit about your typings. Some would argue that you want to infer types as much as possible, but let's just go ahead and add a player type to this array. And once again, it's trying to go to types.js for some reason. So we've got type player, and this is an array of players. Now, remember the store, we've typed that, so you can hover over it. And you can see the storage key should be a string, and the players should be a player array. So this is a player array, and this is a string. Let's say that we passed in a number. It's not going to be happy with that. It'll say number's not assignable to type string. So that's kind of the assurance that we're getting here. Now coming down here, let's see what it says. Property ID does not exist on type event. So this is actually, I think, a mistyping that we had from the bind player move event. Let's go back to the view. And you can see this is where we're using our delegate. And then our handler, we've typed that as an event listener. And if you remember down here, I made that same mistake where I was incorrectly typing the handler. So let's copy this handler type. And instead of event listener, for the handler, it's just going to pass a function with the element that it selected. So now we come back and these type errors are fixed. So this, fixing type errors is really about just reading the error message and being able to, respond to it and know what it's trying to say, which comes with time. It's not easy to start and figure that out when you're first starting with TypeScript. All right, so at this point, everything is strongly typed and our app is working. So our last step here is to compile things. Let's make sure that we're not getting any errors. So yarn tsc, and there's no errors. We're done in a second. And the dist directory now has our compiled code. And as you'll see, as you read through this, none of it's really minified or anything like that. And our target was ES 2016. So you'll actually see all of these methods that we are using. Let's see if we can find the includes method. Here's some interesting stuff. This is TypeScript dealing with like the class syntax and private fields and properties. It has like a helper method to deal with that. So that is kind of interesting. So let me just show you, if we downgraded this to like ES3, a prior spec of JavaScript as our target, I just want to show you how that plays out with the output. It'll be tough to see, so let's open up View.js and just kind of watch the code as we recompile this to a different target. You can see that all of this stuff changed. And if we go back to ES 2016 and then recompile, and you can also see we get all these errors because we're using language features that were not available back in that ES3 spec. So the compiler is going to give errors. So now let's go back to our valid syntax, and you'll see like this will update. So you can see the modules that we're using. But anyways, that's just a kind of fun little tidbit to kind of explain that tsconfig a little bit more. But I want to wrap this up by just walking through why this was so important to refactor to TypeScript and why someone would go to the effort to do this. The value in TypeScript does not really come as you are, retyping things. It comes when you're trying to refactor things or add new features. So if we went to the JS folder and we went to, let's say, the store, and let's say that we came down and we wanted to, change the type that stats returned or something like that. Well, if we went through here and let's say we updated this property wins to like win count. Okay, so it's not going to complain at all right here. But what you'll see is that if we try to recompile this, so yarn tsc, it's going to give us errors that were no longer there. And the reason being is in our view on line 59, so let's open the view and go to line 59, you'll see that we have this underline because we are referencing the output of this stats getter from another place in the code base, and we are using the original property. So we would need to update that to win count before it's going to stop complaining. And what TypeScript has done for us there is, as the developer, you're going through and you're changing a method. And this method is depended on by other methods in other parts of the code base. And so TypeScript is smart enough to know, like, hey, if you change this and it does not match up with the rest of the code base, we're going to not compile this code base because it's just not going to work. So otherwise, if you had a vanilla JavaScript code base and you try to do something like this, nothing would happen. You would just think, oh, I'm okay, I changed that, that's fine. And then you would find out that you had errors in your project once you started playing the game and it was not working as intended. So that's kind of the benefit of TypeScript, is you get that proactive checking of your code and you find out about errors a lot sooner. So rather than pushing a bunch of code up to GitHub and deploying it and finding out that something's broken in your app, you just don't, it just does not get deployed correctly, and it doesn't build correctly if it's not correct code. So that's kind of the appeal of TypeScript. I'm going to put this back to wins now. Now, like I was saying, you would probably want to type this a little bit stronger. So if you were going back to this stats getter, what you can also do is set a return type on this. So if we wanted to open up our types.ts file, let's bring that over here to the right. And maybe we wanted to actually annotate the expected return of this function, which is usually a good idea with functions. It's better to be explicit, and I'll show you exactly why in a second. So let's say this type is called derived game state or something like that. And you don't have to define this here. You could define it in this file itself. And I would actually say that that's probably the better place for it because it's specific to this file. So let's actually get rid of types.ts, and we'll open this same file twice just so we can edit it in different places. And I'll usually throw types at the top of the file. So derived game state, and that is what, or actually we don't want to call it that. We'll say derived stats is what we want to call it. And now I'm going to assign the return value of stats to derived stats. And as we see it right now, looks like nobody's complaining, and that's because we've defined this as an empty object. But let's say that we defined it as a string. Now this is going to complain because our return type does not match the explicitly annotated return type that we had assigned it. So now our job is to define this, and we can see that ties is an easy one. That's going to be a number. So you can see that immediately we get this feedback where this looks okay, but player with stats does not. So we can come up and say player with stats, and you could just say any. That satisfies it, but what does that get you? It doesn't really help you throughout your code base because now anything can be passed here. You don't get that explicit type checking. So what we want to do is say that this is going to be a player array. Now let's see, it doesn't seem to be complaining about that because this does satisfy player array. It also has this wins property, so we need to document that too. So really what we need to do is make another type that is player with wins. And that is going to be an intersection type, or a union type, I should say. And we can actually use this and symbol to add properties. So we can say wins, and that will be a number. So now player with wins represents what we're returning here, and we can pass that in right here. Now if we would call this, once again, win count, now it's going to be mad because we're calling this wins here, but our actual type is win count. So let's match this back up. And now let me show you why explicitly making these types is advantageous. The first thing is if we go over to the View.ts where we had originally referenced these stats, you can see that we can now import the derived stats, and we'll import that from the store. So we no longer need this right here. We'll get rid of that entirely, and then we'll add a type annotation, so we're just importing the types. So now stats is derived stats, and then let's also say derived game. This has not been defined yet, but we can export that as derived game. And then we'll import that from the store. Now it's complaining because we're trying to destructure properties off of derived game, which at the moment is just an empty object. Now we know, looking at the store, that what we're returning from the game method is going to be the derived game. And if we look at the return type here, it has an array of moves, so we can import that here. It has a current player, so we can assign it a player, and then a status, which is an object that has, we've actually already defined that too. So that is the game status from our types. So remember, if we go to types.ts, we had the move type already defined, so we just used that there. We had the player type right here, so we defined it here. And then we had the game status right here, which we passed to status. So using these types, we composed a derived game, which is returned from this game getter method. We've explicitly typed that as well. And you can see winner is not correct here because I think we have a mismatch. And I think I pointed this out earlier, but I don't know. Let's see. So explicitly typing this actually exposed, I believe, a little problem here. It says player or null is not assignable to type player. So we're allowing the winner to be equal to null. So if we go to our original types and go to game status, this should actually be player or null. It should not just be player, because if it's null, that means we have a tie game. So that was something that we fixed by being more explicit, which is a good thing, and why you should always explicitly, define your types where appropriate. So now it's not yelling at us for this anymore. We're looking good. Let's see if that broke anything elsewhere. So now we have explicitly typed the render method to pass in a derived game and derived stats. And now the benefit of doing this, if we come back to store and we go back to this game method, or let's say stats. Earlier we were looking at stats and we changed a property on stats. So remember, we previously had no explicit return type. So we just passed win count, just like that, and nothing highlighted here. So if I was a developer and this was a big project and someone else had written this function, it's not very clear to me what the contract of this function is, how it's being used outside or anything like that. So I could come in and change this name to win count and not have any clue that that affected something in another file until I compile it. So if we explicitly say derived stats, now when we change it, it's going to complain because the wins is declared here, but we are calling that win count. So if we put that back to wins, now it's going to be happy, and it gives us the assurance that we didn't break something elsewhere within our code base. So having done these additional typings, let's close things out and run TSC. And everything compiled, and if we come back, our game is working just fine. All right, the moment that we have all been waiting for. We are going to now take that app that we built in JavaScript, vanilla JavaScript, and refactored to TypeScript, and we're going to now refactor it one more time to React. React and TypeScript is a tool stack or tech stack that a lot of companies are using in production today. It's a very marketable set of skills on the front end, and I want to show you how we get from that vanilla build to this one at the end. And you're going to learn a ton of awesome stuff here. One of those things being, how do we set up a React app from scratch? Oftentimes you're going to use a tool that will kind of bootstrap your application, like the Create React app or Create Next app if you're using the Next.js meta framework on top of React. But generally that's how you're going to set up a project. But that kind of skips over a lot of important parts of, how do we get this all configured? So to really make these concepts crystal clear of why we're using React in the first place and how we're setting it up, I'm going to build it from complete scratch. So you can look forward to that. We're also going to be doing a very light introduction to React, including, what does state management look like in React? What do hooks do? And that is kind of coinciding with state management, and a couple other things. But before we get into that, I want to say that this is not a complete beginner's tutorial to React. I recommend pausing the video right now, going to the React documentation, and just kind of skimming through the documentation to get an idea of what you're about to look at. And once you have at least some familiarity of what it's all about, you don't need to be an expert or anything, then you can jump back into this tutorial, and I'm going to be building this out so you can kind of watch as I do this, and I'll try to point things out that would be suitable for beginners along the way. So with that, we're going to jump in and refactor this TypeScript app to React. Okay, so we're going to look at React here, and specifically, where do we start? So as a beginner, or honestly even as an intermediate level developer, the question of where do you start when you're building a React application is actually more valid than you might think. Seems like a silly question, but there's a lot of ways that you can start building a React application. You could start as simple as just including a script tag in your HTML and using React like that. You could even include Babel, or Babel, however you say that, which takes the JSX and turns it into JavaScript. And you could use that all within the HTML document. So if we went over to our refactor here, what I'm talking about is literally just putting scripts right here, and you could serve React from a CDN, and you have React in your project. So that's one option. Another option is you could use like a code sandbox. So if we went to code sandbox, and here you can go new from template, and you've got these templates, React TypeScript or React. And if you click React, it will just spin up React application for you. It's working, and you can go ahead and add additional things to it. So hello again, and you're already programming in React. So this is probably the quickest way. Now you could also go to things like JS, which is kind of a meta framework sitting around React. You can go to create React app. I'm not even going to go through all of the possibilities. Just know that there's a lot of different options here. And the one that I'm going to choose is actually not recommended by really any documentation that you would see. If you go to the React Quick Start, it's going to give you an idea of where to start. So start a new React project. And if you go down to this section, it says, if you're learning React, we recommend create React app. Now, the unfortunate thing about create React app and other alternatives that kind of just spin it up for you is that you don't get to understand what's happening behind the scenes. You don't really understand what React really is at its core. So the approach that I'm going to take here is actually a lot more similar to how Code Sandbox sets this up. So as you can see in Code Sandbox, if you go to index.js, you'll see this file right here where we're actually creating a root element in the DOM, and then we're using some React helper methods to basically render that React application in the root element that we've specified for React to use. This gets us a lot closer to what React is doing at its core, and so this is where I'm going to start. Now you might notice over here in the files pane, I know this is kind of small, let me make it bigger. You're not going to see any sort of build tools going on. So you're not going to see Webpack or anything like that. It just works. And unfortunately, this also makes an abstraction over React that makes you not really understand what's going on. So not only are we going to start right here at its most basic level, we're also going to kind of spin up our own build tools so that we understand how we're taking the JSX, converting it to JavaScript, bundling it into one file, and then including that in our index.html. Again, the purpose of this video is primarily to show you how you take a vanilla JavaScript application and port that over to React, and to show the problems that React is solving for you. And to do that, we need to basically do everything from scratch. So consider this a learning opportunity, not so much, hey, how do I most quickly get a React application working? Furthermore, the approach we're going to take in this video is not what I would recommend you use to create a production-ready app that you're going to, deploy and work on with a ton of people. This is kind of the most minimal setup that you could possibly have and is great for smaller projects. Some people would probably disagree, but I think Next.js is probably your best bet in terms of a production-ready React framework. This is basically a React meta framework that takes a lot of the common things that you might have to do in React, such as like managing images and routing and all that kind of stuff, different rendering methods, and it just comes out of the box ready to go. So this is what I would check out if you're wanting to build something in production. Anyways, not going to get too distracted there. Let's get started building our React app. So the first step with any project is to set up the initial, index.html and get it working in development mode, so that you can basically just go over to the browser, and anytime the code changes, it will update the application. So that is the first step. And the way that we'll do that with React is, let's go ahead and create a new folder called Live React Refactor. And then our folder structure here is going to be the public folder, which is going to have like public static assets that we'll serve. And then we'll also have an SRC or source folder. This is where our React application and components are going to go. So in the public folder, this is actually where the index.html file is going to go, because this is a static file. There's really nothing dynamic about HTML, so we can just serve that directly. So let's go ahead and just copy that. We'll go back to the vanilla refactor. Once again, you should be familiar with this before watching this video. So we'll copy index.html and we will paste it over to the public directory. Now with React, we are building things with different paradigms. We are not including all of this HTML in this index file. We're going to be creating components to deal with this HTML. So therefore, we can actually strip a lot of this stuff out. So let's take pretty much all of the body content and delete it. The second thing that we're going to do is change the title. This is going to be the React Refactor. And then just for the moment, we're going to comment out the script and save this. We'll put a little text in here, hello world. So this should be a basic HTML document. Now you'll see in the bottom right corner, I'm using Live Server. So I talked about this in prior videos. It's a VS Code extension that you can set up. It's running on port 5500. And that's actually what we're looking at here with the vanilla refactor. But if we go back to the base of this, you'll see that we now can look at the live React refactor and go to the public directory. And now we have a hello world document. Now, if we wanted to connect some styles to this, you can see we have this style sheet left over from the previous project, but it is referencing the CSS directory index.css. Now for this React refactor, I'm going to name this something a little differently. We're going to put a new file in here called globals.css. And the reason that I call it globals is because with React, we're able to kind of scope our CSS per component rather than per the whole project. And so this is just a naming convention that I'm using to make it explicit that anything that we put in globals CSS is going to apply to everything that we use and every component that we make. And that's because we're putting it in the index.html. To start us out, I'm going to go to the vanilla refactor and just copy everything from that index.css and paste it here. And we will eventually move some of this stuff out of this globals file into component specific CSS files. But for now, it's just going to all be there. And now we have to update our path. And this is going to be globals.css. And if we save this and go back to the browser, you can see that here's our hello world. pretty small there. But then we also have the correct background color. So we know that the CSS file is connected. Now, if we're just looking at this document, this is not a React application yet. There's nothing here that tells us that this is React. In order to actually convert this to a React application, we need the JavaScript to be controlled by React, and therefore we need a script tag. So what we're going to do is create something called an entry point. You might see this called index.js or entry point, or it could be named pretty much whatever. But in our source folder, I'm going to be very explicit and just call this entrypoint.js. And in this file, this is where we're going to initialize React. Now, going back to the code sandbox that I had shown you a little bit earlier, you can see this pattern right here where the code sandbox is basically importing React and importing the React DOM client, and then doing something. You can actually find this in the React documentation if you go to add React to a website, and then I think at the bottom, run the JSX preprocessor. Let's see. So somewhere right here, you can see where it's calling create root and then root.render. It's not really called out explicitly, which is a little bit unfortunate, but it kind of shows you how you might know to do this. But anyways, we're going to write this out in our file. So the first thing that we'll do is we will import the strict mode for React. And the reason we'll do this is because it basically parses through your code and it finds all sorts of mistakes that you might make when writing a React application. It's just a good practice to get into to have that in strict mode. But you might say, well, how are we importing from React when we don't even have that included in our index.html or node modules? And the answer is we're really not. If we tried this, it's going to break. So at this point, we're going to install some dependencies for our project. So let's cd into the live React refactor. Then I'm going to run yarn init-y to accept all the defaults. This will save a package JSON to our folder here. Now what I'm going to do is add the required React dependencies. So really the only things that you need from React, yarn add React and then React DOM. So let's go ahead and add those. You'll see those populate in our dependencies. This is all we need to create a React application. So now we can go back to our entry point, and this should work. Okay, now we need to import the create root method, and this will be from React DOM/client. And now here is where we basically insert React into our HTML document. Remember, React is just a bunch of JavaScript that knows how to basically manipulate the DOM and render things. It doesn't actually, create HTML files for you. You have to have an index.html to put it in. So what we'll do is we will define a root element, and this is going to be an element that we select from the DOM. So if you remember from our vanilla refactor, if we go to the JS and go to View.js, where we are selecting all of these elements via the query selector, and then we're in the query selector, we're basically just looking at the document and selecting an element. Well, we're going to do the same exact thing here. We're going to say document.getElementById. This is the same as doing query selector with a hashtag in front to select an ID. It's just a little bit more specific if you have an ID assigned to an element. So we're going to get an element by ID, and we're going to call this the React root. Now, where did I get this name? Well, I made it up, and we're going to connect it here over in the body. So what you need to do is make a div, and then you're going to give it an ID and call it React root. So what this is doing is it's saying, hey, here's a container div. Now React, find this container div and put all of your application code right here inside of it. So basically we're giving it a container to render into. And at this point, we've just selected the root element. This is just going to be an element. Now we have to create the React root. So we'll call that root, and we will call the create root function that we imported from the React DOM client. And we're going to pass in that root element that we had selected. So that is the React root. And then finally, we can now call a React DOM specific method called render. And what we're going to render is a strict mode container. So now we're using JSX, and we're going to render strict mode, and then we're going to say hello world React. And this is just arbitrary JSX code. Now what you might notice is that this is a .js file. We could call this .jsx because we're using JSX in here, and then we'll get JavaScript React down here in the VSCode language mode. So it will just give us some better syntax highlighting. In addition to that, when we go to basically transpile these from JSX to JS, this file extension will allow us to kind of target this file to do that for. So let's save this entry point. Now let's go to index.html. We will, for now, keep this script out of here and save this. At this point, you might say, well, okay, all right, we're done with the initial setup for React. We've got this React root div, and then we've got this entry point.jsx, which is selecting it and rendering the React application within it. But if we were to go to the index.html in the browser, so our live refactor, and let's inspect this. If you inspect this, it's just going to show you the React root, but there's not going to be anything within it. And this makes sense if you really think about it, because what's happening when we request this right here from like some server, in this case, our local computer is the server that is serving that index.html file to the browser. But basically what's going to happen is the browser is going to load some path, and that path is going to make a GET request to some server. The server is going to send back an index.html document. Then what the browser is going to do is it's going to read through the document, and it's going to parse through all of the HTML, and it's going to also parse through any script tag that it sees. You can see that we've got a script tag here, but that's just injected by live server. That's not anything to do with the application that we've built. So what's missing? Well, as you can see in our HTML document, aside from this live server script, we don't have any script. So this code that we wrote in the entry point.jsx, this is just living in isolation right now. It's not actually imported and run within our index.html document yet. And so therefore it has no way to select that root and render anything. So your next option, your next guess might be, okay, let's just uncomment this script, and then we'll go to the source/entry point.jsx. All right, so we're trying to import that script, but if we go to the browser, that's obviously not going to work. If you go to the console, you're going to get loading module from blah, 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 because the MIME type was wrong. There's just going to be all sorts of problems here. And the reason is because a JSX file, one that has actual JSX in it, is not going to natively run inside the browser. You might get this stuff to run. We could probably see if that worked. So let's console log the root element. Looks like even that's not going to work, and I don't really care to debug that because we know that this is just not a good strategy in the first place. So pause the video and just ask yourself, if we can't do this, then what can we do? How do we actually get that JavaScript to run inside the browser in a script tag? And the answer is that we need to transform the code that we have written, the JSX code, into vanilla JavaScript, and then put that into another file, and then import that other file right here. If you watched the prior video, also linked in the description, where we took the vanilla JavaScript build and we refactored it to TypeScript, you might remember that we had some sort of build step where we had to take the TypeScript code that was not valid in the browser, and we had to compile that with the TypeScript compiler into valid JavaScript that we could run in the browser. This is no different. What we have to do here is we have to not necessarily compile. I think the correct term here is to transpile. So let's actually go look that up. So transpile versus compile. I should know this. So compiling is the process of taking source code written in one language and transforming it to another. Transpiling is the process of taking source code written in one language and transforming it into another language that has a similar level of abstraction. So in other words, it's not a real huge difference, and we don't need to get hung up on the differences there. But what I want to take you to now is a website, some documentation for Babel or Babel. I never know how to say this. And on the home page, if we just zoom in a little bit, what you'll see is that it gives you an example of how you put in some next generation JavaScript and then you get browser compatible JavaScript out. In other words, Babel, I'm just going to go with Babel, is a tool that will take some sort of JavaScript, some flavor of it that doesn't work in a browser, and make it work in a browser. One of those things that it can do is JSX. So if we come down to the presets, this is just the playground. You can see that it's using the React preset, so it knows, that we can write JSX code. And if we were to write, something like just a regular p tag, hello world, and then close that p tag off, what you'll see on the right is that it's using the React library to create a new element in the DOM and then render the hello world text within it. We could also wrap this in, say, a div. So we're just writing what looks like HTML, but really this is JSX. So now we're creating elements, and we could probably, I think in this playground, even write a component. So this will be a function component, and instead of just this isolated JSX, we will return that from the function. And oops, let's format this a little bit better. So you can see that worked, and it's returning a JavaScript function that returns these create element calls, and then we could even render that. So let's make our app, and then we want to return the component as a JSX component. And now you can see that all of this is going to be valid JavaScript. So this is just a .js file that we could include in that index.html file. So this right here is totally valid to put in this script tag. This right here is not valid, and it will not work. Now, Babel, under the hood, is running a bunch of code against this to get it to this state. And therefore, we're going to need some intermediate step to get it to this point. Now, once again, just like there's many ways to create a React application, there's also many ways to transpile code. And Babel is not your only option. Another option is you could use, if you're writing this in TypeScript, which hint, hint, we are actually going to convert this to TypeScript in just a few minutes. You could use the TypeScript compiler to do this because the TypeScript compiler actually supports JSX. You could use Babel, and you could also use something like Webpack, which is a build tool. So that's what we're going to do. I know this is not the latest and greatest tool chain. This is mainly for educational purposes. But if we go to some more documentation, let's go to Webpack docs. And now we're dealing with a bundler. So it does more than just bundle code, but the purpose of using Webpack is to take a bunch of different JavaScript files and squash them into one JavaScript file that we call a bundle. If you really want to understand why we need a bundler, I've written a post that I've referenced a couple times at this point throughout this video series, and it's the scripts versus CommonJS, UMD, AMD, ES6 modules. And if you come down to the bottom, let's see. So the last step, module bundlers. This is where I go through and explain why do we need a module bundler in the first place. So I'd recommend reading this short post just to get a better understanding there. But our goal is to basically take this entry point JSX file And then we're going to have many other JSX files that will have all our different components. And instead of coming to index.html and copying this down and importing every single script that's been transpiled from JSX to JS, this is going to get very confusing. Our goal is to just do this. We're going to have one file, and it's going to come from the public directory, and it's going to be called bundle.js. And we don't need the type module anymore because we're using React code and we don't need to worry about that. But this is our end state. And I actually need to update this because remember, index.html is actually in the public directory. So we just need to reference it relatively. So the bundle.js will be output, keyword output, it's not created yet, into this public folder, and will sit next to globals.css and index.html. So the question becomes, how do we get it there? How do we get this bundle.js to compile into the public folder? The answer is Webpack or something similar. Once again, this has kind of gone a little bit out of style, but that doesn't matter. Our purposes here are educational to understand what's going on under the hood of React when we set it up in the first place. And you'll hear all sorts of things like, oh, Webpack's so outdated, but ultimately tons of projects are still highly dependent on this and will be for many years to come. So don't get spooked by anyone saying that this is irrelevant. This is very relevant, and the concepts that we'll learn through it are even more relevant. So let's get started. There's a lot to this documentation, lots of different configuration concepts, and I'm not going to go through these because you really don't need 90% of this for our purposes. So what I will do is just start writing the configuration, and we'll come back to the documentation to point out the individual options that we're using. So in order to start a Webpack project, we need to initialize it with a configuration file. Now, if you go to the documentation, there should be something about the configuration here. So introductory configuration, and you can see it's called webpack.config.js. So let's just copy this. Let's copy that default, and we will make in the base of our directory a webpack.config.js file. And let's just copy that basic example in there. Now, bear with me a little bit for the next couple minutes. This is going to get slightly confusing, and you're welcome to skip over this section if you want. I have time for this video, so if you want to skip over these details and just get started building the React application, you can do so. But I would highly recommend going through this section. It's really a good thing to understand what's going on here, and will serve you for the rest of your developer lifetime, just understanding this stuff. You probably won't have to touch it again, but it's good to just know what's going on under the hood. So let's take this line by line. First off, the mode. This is in development, and if you go to the concepts, let's go to environment, and right here it says the mode is an option that can be development, production, or none. And this is going to enable certain optimizations that are done in production. So Webpack will do certain things. I believe it's like minifying the code and stuff like that, depending on your environment. So we are in development. What we can do to make sure that this runs depending on our actual environment, let's say that we were deploying this somewhere. What we know is that the process.env.node.env is going to equal production when we deploy it on some server. This is just a default that any deployment site or cloud host is going to assign. So if there is a process node env, we're going to use that. Otherwise, we're going to use development. So in other words, development is our fallback, but we're going to look at the node env to determine what to use for this mode. Now this of course assumes that you're only allowed to assign development or production to node env. If you were, had like a staging environment, then this wouldn't work, but most of the time it's either production or development, so this should work. Now our entry, this is a little self-explanatory, so we don't need to go to the docs for this. This is going to be the file that Webpack will start from. it will start reading that file, and then it will trace all of the imports that have come into that file and kind of just walk down the code tree to find all the relevant files that it needs to basically bundle up. So in our case, entry point.jsx is going to be that. And we are in the root of our folder. So we need to look in the source folder, entry point.jsx. So we'll say relative to source, entry point.jsx. That's going to be our entry point. And then output is also somewhat self-explanatory. It's going to output a single file. We're going to call this just bundle.js. And it's going to put it into the dist directory. Now we're going to just rename this. Instead of dist, which stands for distribution, and it's a very common place to output your build output, we'll just call this public. And the reason being is we've got this public folder, and what we want is that bundle.js file to get output to public. Now, some would argue that you kind of want to separate these concerns, and maybe you want to output this to dist and then copy over your index.html and CSS to dist so that it's all kind of isolated into this, build output. But for our project, it's pretty simple. This makes sense, and we can just output this to the public directory. So let's save this. We will save entry point. And now the question becomes, well, how do we actually use Webpack? Well, you could install Webpack globally in your path, or better than that, you can install Webpack, pin it to a specific version for this project. That's what we're going to do. We're going to say yarn add, then we're going to add a -d because this is a development dependency. Remember, Webpack is just here to look at all of our code and bundle it up into something that can actually run in the browser. We don't need it after it has done its job. We can just run the code that it output and not deal with anything else. So what we can do is just add Webpack. So we'll go ahead and do that. And now what I'm going to do is go to package.json, and we're going to add some scripts. Not necessary, but it's just convenience here. And something that I want to add is a build script. So this will run when we say yarn build, it's going to run this script right here. And what I want it to do is look in the development dependencies and just run Webpack. So we'll save that. And now what's going to happen if we run yarn build? So yarn build, it's going to invoke the Webpack binary that we just installed, and Webpack automatically knows to look for the webpack.config.js file in the root directory, and then this config has basically told the binary to look at this entry point, read through all the code, and output it to this bundle.js. But if we were to run this, we really haven't given it any instructions as to how to do this. So let's just try to run yarn build, and it's saying that we need to install the Webpack client. I guess I had forgotten to do that, so we'll say yes. That's going to actually update our package JSON. You can see that here in dev dependencies, or I'm sorry, we're in the final one there, live React Refactor. So now we have Webpack and Webpack client. So at this point we run yarn build, and you can see that we're going to get an error of some sort, and it says module parse failed, unexpected token. You may need an appropriate loader to handle this file type. Currently no loaders are configured to process this file. And what it's complaining about is this JSX that we have written. So if we go to entry point, by default, Webpack does not know how to deal with JSX. It doesn't know how to transpile this right here. And this is where Babel will come in. So going back to Babel, we talked about how its job is to take this code and turn it into this code. And so therefore we need to add something called a loader to Webpack. So if we go to the documentation there, it says loaders are transformations that are applied to the source code of a module. They allow you to pre-process files as you import or load them. So I'm going to save us quite a bit of pain here, and I'm just going to show you how to get this working with React. I'll be completely honest, this is confusing stuff. I would not spend a whole lot of time beating your head against the wall to try to understand it at a super deep level. The overall goal here is to just understand the process that our code is going through, not necessarily all of these implementation details. So what we need to do is add a module property, and this module is a valid on the config, and then we'll say rules, and then we give it an array of rules. Now, each of these rules is going to basically say like, hey, once you see this certain type of file in, coming from the entry point, here's how you actually, look at it and transpile it and bundle it. So the first rule that we're going to do is we're going to test. So this is going to be a regular expression that we're handing it. And we're going to say, if you see any file that has a JSX extension at the end of it, then go ahead and apply this rule. But if you see anything in node modules, exclude it, because we don't want to put that into our bundle. And then finally, here's where we're going to use a specific loader, and that loader is going to be called the Babel loader. Okay, so right here we're importing something that's external, so we need to install that as a dev dependency. If you go to Babel, we've got a lot of tabs open here at this point. Let's open one more. So Babel docs, and then let's just go down. If you go to presets, you can see there's a preset for React, and it gives you all this really confusing stuff. Okay, so here we get a list of all the different loaders that we can use. So let's start with the Babel loader. So we click on that, and it says, disclaimer, it's a third-party package maintained by community members. So this will need to be installed. And here's the install command. You need to install the Babel loader, Babel core, and preset. Now, I also happen to know that if we go to the preset React, we'll need this as well. So we're going to just kind of combine all of this into one command. So we will clear the terminal here, and then these are all going to be developer dependencies. Remember, because we're just transpiling code. So we need to grab the Babel loader. So that's for Webpack. Then we're going to grab Babel specific packages. So we need the core module. We need the preset env. This is basically to just kind of normalize all the different ECMAScript versions and whatnot so that we can run JavaScript in all browsers. And then finally, Babel preset React. So we'll install all of those. When we go to our package.json, you'll see that they're all added right there. And now we can come back to our Webpack config, and this is going to work because we have that installed. And then we'll give it some options. Now this, I'm not going to go into a lot of depth because it's more on the advanced side, and we'll just assume that this is going to work. So what we first need to give it as a preset is the Babel preset env, and once again, this is just to make sure that all the different versions of ECMAScript, so ES3, 4, 5, 6, 2016, blah blah blah, all of those, it kind of normalizes it so that the JS that is loaded is going to work in all browsers. And then we're going to give it an array where we give it the Babel preset React. And then this is really important. We need to give it a runtime of automatic. And the reason that we need that is because when we come to entry point over here, we are going to need that so that it automatically infers that React is part of this application, and we don't have to explicitly import React every time we want to use it. So that's the loader that we've set up. I know that this whole blob is a bit confusing, but just zooming out, the point of this is saying like, hey, anytime you see a JSX file that came, as a result of looking in entry point, so in other words, anytime you see a JSX file in our project, go ahead and use the Babel loader and make sure you use the preset React, which is basically what we were looking at here in this sandbox, so that it takes this and creates this out of it. So now we might be able to build our app. So yarn build remember that's going to run our Webpack script. And you can see that we got no errors. So that's a good thing. Now, we're not 100% sure that this worked yet, but you can see in the public folder, we now have a bundle.js, and it's a bunch of ugly code that has been, transpiled, and this is not something that you want to actually read through. Before we get any further, let's add a .git ignore to our project, because we've added some developer dependencies and build output, and all that stuff does not belong in source code. So first, let's look for node modules and ignore that. And then I'm going to do this, but this is probably not a best practice in any way. We're going to look in the public directory and ignore anything called bundle.js. And that's just because if you look at this, this is a lot of gibberish that does not belong in source control. This is an output of a build, and that includes pretty much the whole React library in it. So we do not want to put that in our GitHub repository, so we'll ignore that. Let's make sure that that is working, so we should not see any bundle.js. Sorry, there's actually some leftover code from my TypeScript refactor from the prior video, but the main point is there's no bundle.js. And if you look in Visual Studio Code, when it's ignored, it's actually grayed out a little bit compared to the other files and folders. So that's just a quick trick to know whether your file's been ignored correct. So the ultimate test is if we visit this index.html, which is importing the bundle.js that we just output using entry point as the source, does it work? So let's go to the browser. We can close this out, or I'll leave it open just so that we have reference to it. And now you can see right here, I gotta zoom in a bunch, Hello World React. So something worked here, because if you look at entry point, you can see that that's where we're rendering the Hello World React. And so we know that our Webpack config worked, and we are able to render JSX in our browser. And if we go ahead and inspect this, now you can see in the React root, that's where that p tag has been added. But there is one problem still, and that is if we go back to our code and we say by Zach or something like that, and then we save this entry point.jsx. Well, let's refresh the page, and it's not actually working. And the reason being is because every time we want to add something, we need to rebuild the application. So we need to run yarn build again. That's going to compile everything and bundle it up. And now you'll see Hello World by Zach. Obviously, this is a poor experience as a developer. We do not want this to, we don't want to have to come and say yarn build every time we make a change. So this is where the Webpack dev server comes in, and that is basically going to look at your Webpack config, and on any change to any file that is included there, it's going to rerun this build step and output it to the bundle, which is then going to be served to index.html. And believe it or not, this didn't used to be this easy, but now you can basically just add one extra command here. So instead of build, we're going to give a dev command, which is our development only command, and we're going to say webpack serve. And while we're here, I'm also going to add a build production script. And you know how we talked about over in the config, we've got this process node env. If we want to build it to production, we could just pass something like this. So set the environment variable and then call webpack. So if we ran yarn build prod, it's going to just apply some optimizations to everything. And if we look at the bundle.js, you'll also see that there's a license omitted here. That would probably be good to include. So let's go ahead and just say bundle all, and that will include the license as well. But if you look at this, now it's optimized where like everything is minified. It's all, squashed together, which makes it a smaller bundle to load over the wire over an HTTP request. So yarn build is going to create something with lots of spaces and it's not optimized. and then yarn build prod is going to optimize that. But anyways, we want to run this in development mode. So let's run yarn dev, which is going to run the Webpack serve command. And this is going to say for using this command, we need the Webpack dev server package. So we'll accept that. You'll see that that was added down here at the bottom. And now you can see that it's a running process that is just waiting for changes. So we'll go back to our index.html. You can see hello world by Zach. And then if we go to the entry point JSX, let's remove that and save it. You'll see that this just refreshed, reloaded. And if we refresh this page, it's not doing anything. So I am just not thinking whatsoever and totally messed this up. So if we try to go directly to index.html in the browser, and we are running this over live server, so localhost 5500, we're just going to get the static contents of the public directory. Now, if we look at the output of the Webpack dev server, it says that the project is running at localhost 8080. So we can kill the live server at this point. So we'll close that server. Now, if you reload this page, we got it way zoomed in. But if you reload this page, it's going to say unable to connect. But if we go to localhost 8080, now you'll see here's our hello world React is working again. And then if we go back and make a change and save that, it's going to hot reload and update in the browser automatically. So the mistake I made, I was trying to look at the static contents from live server. We need to go to a different port here. The next step here is to replace this content with our app. So we can come over to our files and next to entry point, let's call it app.jsx. And this is just going to return a basic application wrapper that we're just going to consolidate all of that logic to. We can go ahead and use ES6 modules. So we'll export a default function called app, and then this will return some div and then say my app. Now we can import that into the entry point. So import app from app, and then replace this content with the JSX element, just like that. And we're getting an error. I think we might need to say app.jsx. Yep, that's all we needed to do. It couldn't resolve that without the extension. And I believe that happens because our Webpack config doesn't know how to kind of parse through and import that if we don't have the extension on it. So now this entry point is basically done. We don't have to look at this anymore because it's all set up. And now we're going to be working from this app.jsx. So let's go make sure that it works, my app. Now let's connect some per component styles. So we're going to use just vanilla CSS. And one way that we can do that is by using CSS modules. So we can say app.css. And let's go ahead and select everything in this app and make it the color red. So this is not going to work by default if we just look at our app, but all we have to do is import, and then we just import the app.css. Now you'll see that there's some errors down here and we're not able to compile, and that is because we have not specified a CSS loader. Right now we have an entry point of this, which is going to eventually make it to app.jsx. Then it's going to import app.css, but we don't have any rule for that. Right now we're only looking for JSX files. So if we go back to the documentation for Webpack right here, and we go back to loaders, you'll see that there's some different categories, and one of them is styling. So we have the style loader, add exports of a module as style to the DOM, or CSS loader, load CSS file with resolved imports and return CSS code. We're going to need both of these, and these are third-party packages, so we'll have to install them. So let's come down to our terminal, open up another one. Actually, let's just cut the server for now. and we'll add this as a developer dependency. We'll call it, we got to get the style loader and the CSS loader. Once we've done that, we can add another rule. So remember, rules is going to be an array, and we can specify a CSS rule. So here, we're going to test and look for any .css files. So that's what we're looking for. And if we find them, we're going to use the style loader and the CSS loader. So let's save that. That's our final rule that we'll add. And let's run yarn dev. And now you'll see everything compiles successfully. And if we go back to the React refactor and refresh, we had to refresh that first time because we had restarted the server. So it's red, and now if we change this to green, it's going to hot reload and everything's going to be green. So at this point, we have our entire Webpack configuration done. We have our entry point to the React app set up, and our index.html is importing that bundle that we are, basically compiling and bundling together with the help of Webpack and Babel. I know we've spent a solid amount of time just setting up this React app in the first place, but I hope that it has been educational and given you a better sense of what's going on under the hood. This is basically what the Create React app and all of the other, frameworks that let you set up a React app, they're all doing some version of this under the hood, but that's abstracted away from you. And so oftentimes you don't understand what React actually is at its core level. So there's one more thing that we're going to do, and I kind of debated this a little bit, but I want to build this React app with TypeScript rather than, doing a whole another additional video where we refactor it to TypeScript. I think using TypeScript is really awesome, especially with React apps and across the stack. And it's not going to be too difficult to translate what we have here to TypeScript. And it will also give you a better idea of how we translate vanilla to TypeScript from a build step perspective. If you're not interested in this and you just can't wait to get started, once again, timestamps are in this video. Skip to the build where we actually start building out this application and, translating it from that vanilla JavaScript to React. So let's cut this server. And I will also add that there is a TypeScript branch and then a main branch for the repository in the description that follows and basically has all the final code here. This is a combined video, so you can find the vanilla JavaScript React app in the main branch, and then the one that we're building in this video will end up in the TypeScript branch. So I'll leave that in the description and kind of label it so that it's clear. So if you haven't watched the prior video where I converted a vanilla JavaScript app to a basically vanilla TypeScript app, go watch that because it will cover a lot of the basic concepts that I'm going to gloss over in the next few minutes. So I'll leave that in the description, but the first thing we need to do is install TypeScript. So we'll add that as a developer dependency. Once we have that, then we can run yarn tsc, which is the compiler, and we can run init. This will create a tsconfig, although I missed something here. It's not init, it is --init. So that creates a tsconfig.json file. Now there's all these different options here. I'm gonna go ahead and just copy the final one just because it's gonna save us some time. Okay, so this is the basics. The things that I'll point out here, this is pretty much the same as that prior video that we did, but just to point out, we're targeting ES6, so that's the version of JavaScript that the build output will be. And there's one thing that I've left out on purpose here, and that is a property called JSX. So let's go to the TypeScript documentation. So TypeScript, and then docs, and then go to the reference for the configuration file. So I'm not really sure where this would be. TypeScript tooling, reference, let's just search it, config, writing a configuration file. Gosh, this is very indirect. I want to just go to the reference for this. Let's go TypeScript config reference. Not sure why that's not searchable easier, but maybe I'm doing something wrong. So anyways, let's find that JSX property that we had just talked about. So that's down in language and environment. So JSX, and it says controls how JSX constructs are emitted in JavaScript files. This only affects output of JS files that started in .tsx files. So we have a couple of options here. We have React, React JSX, JSX dev, preserve, and native. This preserve option would be good if we were wanting to basically compile our TypeScript to JavaScript, but leave the JSX as it was, and then use Babel to take JSX and convert it to JS. Now, for this simple of a project, we don't really need all that indirection. We can just use React JSX and get all of that to happen for us. So let's give it to the JSX property, and we'll pass in React JSX. And so now the TypeScript compiler is not only going to look at our TypeScript and convert it to JavaScript, it's also going to recognize JSX and convert that to JavaScript. So it's kind of an all-in-one solution, which means that we can remove all of the Babel stuff that we had just added. That was good to understand, how you would do something with a vanilla application, but if you're using TypeScript, we can remove a lot of this complexity. So instead of using all of this Babel stuff, we're going to use the TS loader. And we're also going to need to change this to TSX, so it only searches for TSX files. Finally, we'll need to update all our file extensions to TSX so that it knows to grab those. We'll come back to these errors in a second. Those are type errors that we're getting. Let's just save this for now. So now we have all TSX files, and let's go back to this TS loader. If we find this in the loaders, it's right here for transpiling. It says it loads TypeScript 2.0 like JavaScript. So this is also going to be an external one, I believe. So we'll need to install it. So let's open up our terminal here and look at our package.json. Right now we've got all these dev dependencies. We have Babel core, preset env, all of these Babel stuff. And we don't really need it anymore because TypeScript has taken over, the TypeScript compiler has taken over and done all of that job in addition to compiling TypeScript for us. So we can yarn remove all of that stuff. I'm just gonna take a little shortcut and just delete all that. We still need the CSS and style loader, and then we of course need Webpack because we're still using that. So let me save that and just yarn install. So that's gonna refresh everything. And then let's go ahead and add a developer dependency called TS loader. So now we have the CSS, style, and TS loaders in our project, and that should work for the Webpack config. Now, if we try to build this, we're going to get some errors. Oh, okay. Duh. I need to update this to TSX because we're not able to read the entry point. All right, so now we're getting some errors, but it's a much better error. It's looking for type files for everything, for React and all that stuff. And so now we just need to install those. You'll see an entry point. It's going to say try npm save dev types React. So that's all we're going to do is save the React types, and then I believe we also need the React DOM types. And you can see this goes away. Root element, it's just complaining that it could possibly be null. So one thing we could do is we could say if there's no root element, then throw new error React app configured incorrectly. And now that's going to solve that because we know that that will exist. I tend to just put a exclamation at the end to say like, hey, we know that this root element is going to be found. That's okay to do in this case, I think. But yeah, if you wanted to be safe, you'd throw an error or log something or whatever to make sure that that root element was selected correctly. Let's try one more time, yarn build. And now it successfully built things into the public bundle.js. So that compiled TypeScript to JS and JSX to JS. So everything can now run in the browser. And let's make sure that that worked by going not to localhost 8080, but to the static app that we had. So localhost 5500, we cannot connect to that because live server is not running. But if we hit go live on live server and then refresh and go to live React Refactor and then the public directory, you can see that we have an app running with some styled green text. So that means that our final build worked okay. And then if we were to go to yarn dev and run that dev server at localhost 8080 and refresh, you'll see that it refreshes, and once again we can go change this to red again, and that should hot reload and change the CSS of this app. Let me close a bunch of stuff out. We'll close all the save files, collapse all this, and I'm going to collapse this terminal. It's just going to be running in the background, and if we run into some errors, we'll pull it up again. So if you remember from the prior video that we did where we refactored everything, the live TS refactor, we basically took the Tic Tac Toe game and we turned it to a TypeScript code base. So we've got the app, we've got the store, and we've got the view, and then we have our types file. This is what we're going to be referencing, and we're going to be just lifting it over and putting it into React code. While we're doing this, I'm going to run a live server, and that's going to be over here on this tab. We'll just grab localhost 5500, and I'm just going to run the vanilla refactor just so that we have a working final version of the game. So this is just vanilla.js, nothing fancy. This was from the first video. This is just our reference point, and we will eventually reach that same point over here in the React refactor. The first thing I want to do is bring over our types file. So let's copy this file of our types and put that in source. And looking at the types, we just have a player, a move, game status, game, and game state. The next thing that I want to do is copy over the HTML. So we had index.html that had all of this structure for us, and we had the main tag as well as the footer, and then finally a modal that opens when the game ends. I'm going to go ahead and copy all of this, and just to start us out, we're in the live React refactor again, and we'll go to app.tsx, and instead of my app, we're going to return all of this HTML. So all that HTML is going in there. It's going to yell at you because we need to put a fragment around this because we have no parent element to all of these. And then of course, we need to update all of our class attributes to be React compatible or JSX compatible attributes, which will be class name. So let's add that as a class name. So that should fix a few things. Then all of our comments, we'll just get rid of them for right now because those are not valid JSX. And then finally, you'll see that the style needs to be converted. This one will be a little bit annoying to do. So let me just kind of speed through this real quick. So I'm just copy pasting everything from the final version. Okay, so we've converted the HTML to valid JSX. No errors going on here. So we should, remember we have this server. I guess I'll keep it open here just so we can see a little bit of it. So that should be reloading every time we save. And now you can see in our React refactor, we've got something working. We have red text everywhere because I have not removed from our globals, or no, not globals, it was app.css where we added this. Let's get rid of that because that's annoying. And you can see now we have all of the structure and style to our application. But if we try to click anything, it's not going to do much because we don't have any event listeners or anything hooked up. Let me go ahead and just close all of these tabs. We don't really need them anymore. So the first thing that you'll want to do when you convert something over to a React application or you're just building a React app from scratch is look through your structure of your HTML and find what parts of this will be best as an individual component. So the first one that's pretty obvious that I'd like to kind of rebuild is the footer. This could be its own component. And so what I'll do is I'll just start using this convention. Let's add a new folder called components. And then in components, I will just add a footer.tsx. And then the styles for that footer will be footer.css. One could argue that, this organization is not the best, but it'll work for now. So the template that we're going to work with here is basically we're going to export a default function from each of these component files. And I'm trying to do this in the CSS file. Oops. Okay, so that looks a little bit better. So we're going to export a default function and then return some JSX from that. And then we're going to import the footer.css at the top so it gets all of the component specific styles. And then here we can just go back to our app.tsx and let's just copy the footer entirely and paste it right in here. So this will self-contain the footer, and I don't think there's anything that we need to modify here. So we can just leave that as is. And I don't actually think that yes, we do have some styles for that. So in our globals.css, where we have all of our styles right now that applies to everything, we want to come down and find the footer styles. So right here, this is where all the footer styles are. Let's rip those out and add those to footer.css and then save both of those. And so now the styles and the HTML should be scoped to this one component. And we can finally come back to app.tsx and remove the footer and replace it with our footer component. And if you hit Command period, it will add that import for us, as you can see right here. So it's added the footer, and our Webpack is going to hot reload, and you'll see the footer right here down at the bottom. It's working. And if you go to your developer tools, let's actually look at Firefox extensions, and let's look for React and grab the React developer tools. All right, so now we have some React developer tools, and I think if we refresh this, yep, we can now see the components. So you can see that the footer is one of our components now. So this is, let's zoom in a little bit. I guess I can't zoom in. Unfortunately, I don't think I can zoom on the developer tools too much. It's pretty small. Okay, the next thing that we can do is break out the modal itself. So this right here is the modal that we will pop open when someone wins the game. We can bring this over to the components and call it modal.tsx with modal.css as the styles. And I'm just going to use this template again. So export default function, remember to import our CSS. And now what we'll do is we'll grab all of this right here and return it from this component. We'll go to globals.css and find all the modal styles, which we've organized. This is another reason to organize your CSS so that when you refactor, it's pretty easy to know what goes where. So we put the modal CSS here. We'll save global styles. We'll save that component. And then we will once again add the modal. Oops. We need to import that from our components, and you're going to notice that this is going to mess things up a little bit. So if we come to our refactor, well, actually it doesn't mess anything up because we still have that hidden class. So if you'll see the modal hidden class, we're going to now control these sorts of things with React rather than classes. So I'm going to get rid of that. I'm also going to start removing all these data IDs because we're no longer having to select the elements. We can just grab them directly from React. So now once we remove those classes, you'll see down here at the bottom, you get this weird modal happening. And let me see what's going on there. So if we look at these styles, I think what's happening is we are setting the position to be fixed, but we're not giving it a reference point of where it should start. So let's give it left 0 and top 0, and now that should work. Okay. Once again, you can't click anything. There's no JavaScript functionality quite yet, but that should be styled correctly. And then if we come to app.tsx, now instead of using a hidden class that will toggle with some implicit event listener, we can just be more declarative about this and keep a state of whether the modal is open or not, and then render it conditionally here. So I'm going to just create a variable right now. You'll see how this comes into play a little bit later, but we'll just make a static variable called show modal, and we'll set that to false to start. Once again, you'll see how this changes in the future, so don't get caught up on how I'm not using state correctly and stuff like that. So show modal, we're just going to wrap it in this, just like that. So now we will be able to conditionally show the modal. And then furthermore, what we might want to do is add some props to modal so we can pass what we want to show. Remember, we are going to control this text right here with JavaScript. So it would be good to add a message as props, and then we can define a props type up here that has a message of type string. So right here, we're destructuring from the props object and we're typing it right here. And now instead of player 1 wins, we can say that is set to the message that we pass to the modal as props. Now, since this is a required message, if we go back, it's going to complain because we haven't given it all of the props. For now, we're just going to say player 1 wins because we don't have anything dynamic to pass quite yet. But now you can see if we were to toggle this from false to true, it's going to show the modal and pass in player 1 wins. And just to check, we can look at our components again, and now we have a footer and a modal in our app. So let's put this back to false for now. So that's not going to show. And move on to the next part that we're going to refactor into components. All right, so looking through the rest of this, we could of course make a scoreboard component, but this is not a whole lot of HTML. I think we'll just leave this here. That's really a style preference, whether you'd split that out. This right here, we can simplify using some React conventions. So this will be rather simple to do. So we'll just open up some brackets here, and I'm gonna make an array that goes 1 through 9. And you could of course create this with some JavaScript, but let's just be expressive about what we're doing. It's a lot easier to follow. And then from here, we're just going to map, and we're going to call this the square ID, is what each of those numbers will represent. And then for each of the square IDs, we're going to one of these div elements. Now, whenever you map across multiple elements in an array, React needs to know the key that you're giving it. And the reason is so that it has a predictable order that it can put these elements in, and when it goes to re-render and figure out whether each element has changed and it needs to re-render in the DOM, it will look at that key to tell it that. So we don't need this ID anymore. We also don't need this data ID because we're not using that old vanilla syntax. We do need the key here as I just described, and we can pass it the square ID, which is basically going to be the number on that square. And then furthermore, in our vanilla application, we were using JavaScript to render an I element, or basically an icon, in this div. So if we look back when we click something, or sorry, this is the React app we have. If we click something in the finished app, it will put one of those icons within the box. So what we can do in React is, instead of implicitly doing this, we can be, or imperatively doing this, we can be more declarative and just say, let's just put an I tag in there, give it a class name, and we know this is going to be FA solid. Now we're going to have conditional classes based on which player is currently up. We haven't implemented that quite yet, but for now I'm just going to pass in FAX, and then we'll say, I think that was yellow was X, or no, I think it was turquoise is what we had for player 1. We will of course come back to this, but if we render this now, and then at this point we can get rid of all of these, so just reducing that amount of code. Now you'll see there's an X rendered into each of those. So we'll leave that there for now. We'll come back and make that dynamic later. Scrolling through, we've got the menu. This could actually be a good use case for another component. So we'll make it a menu component, and we'll export the default menu function. Oops. And then this menu is going to have some props. So we'll initialize that. And then we also want to import the menu.css, which we need to add over here. So there's your menu CSS. Let me close a bunch of these to clean us up, and we'll just open, oops, this is from the final. So there's our menu and our menu CSS. Now the first thing we'll do is let's go over to globals and look for those menu styles. So it looks like we got them right here. So let's copy all of those. I think that's all that we need. We'll throw those in menu CSS, save globals, and then we'll go to index.html, or I'm sorry, not index, app.tsx. And at this point, we can grab all that HTML. Whoops, did that wrong. So we'll cut that out of there. And then in our component, we'll just render that div right there. Let's clean all of these data IDs up, because once again, we don't need that since we're working in React now. But pretty much anywhere that we have one of these data IDs means that we're registering it for a click listener. So we'll have to set up those click listeners here. So what I'm going to do for this menu is give it an onAction property, which is going to have an action type, which will either be a reset or it's going to be a new round. You could, of course, do this differently, however you want. I'm just simplifying things so that all we have to do is check the action type, and then we know which of these buttons was clicked. So we'll come down to the buttons themselves, and we'll say onClick, and this one will be an onAction. Oops. We haven't passed the props yet. So let's initialize these. So there's your onAction, and then there's your props. So that's grabbing from here and typing it out. So now we can say onAction, and this will be a reset. So you can see we get this TypeScript support because we have this union type. So there's your reset. And then here's another click listener. We'll say this one is going to be the new round. So once again, you could split this into two. It's just stylistic. You could comment this out and say on reset void, and then on new round void, and then replace these with those two different ones, and then come down here, and instead of passing the key, we'll just say on reset and on new round, and that would be the same. So same thing, just a stylistic concern. So I'm going to go back to my original. I like that a little bit. So now we can throw the menu here where we took that JSX out. So there's your menu, and then we of course need the onAction. We'll fill that out in a second. So let's import the menu, command period to get VSCode to do that for you. You can see it got imported right there. And then the onAction for right now, we're going to just put a placeholder in there, and it's going to pass us an action because that's what we defined. And we're just going to console log it for right now. We'll eventually hook that up to something. Now, if we go to our app, when you click the actions menu, you're going to see in the console, it should, or let's refresh. Oh, we're not getting anything because we set those listeners on the menu items. But we also need to listen for a click to the topmost menu. So what we're going to do is put a click listener on the actions button, and we'll handle this internal to the menu. So we'll say whether this is menu open will be a piece of state that we're going to introduce using the useState hook. And then what we'll do is we will look at the, let's see, we've got a function and we're going to set menu open. And basically we're going to implement toggle functionality by looking at the previous state and returning the opposite of that. So it's complaining about this because we haven't initialized this to anything. So by giving it a false default state, that's going to type our use state and this as a Boolean because it's going to use type inference, and it's going to initialize this to be closed. But when we click that actions button, it's going to basically toggle the menu open and closed. We can verify this by going to the UI and clicking this, and it's not going to do anything because we're not actually reading this menu open state. We want to conditionally render this piece of JSX based on whether the menu is open. Now we have this leftover hidden class, which we need to get rid of because that will override this behavior. So now let's open this up, click actions, and you can see we can toggle this back and forth. The last thing is we need to look at this icon, and remember in the vanilla app we had this flipping depending on the open state. So we can come down here where we're rendering that icon and basically say, hey, if the menu is open, we're going to render something, otherwise we'll render this. So I'll copy this to both of them. So right now it's going to be down on both, but let's go ahead and put menu or chevron up when the menu is open and chevron down when it is closed. So there you can see it flips. Now there's a slightly better way to do this, and while we don't necessarily need this dependency, it's something that I use and it's pretty helpful. So we're going to add something called class names. So we'll say yarn add class names. This is just a utility, really just a utility function is all this represents. And if we use that, we can refactor this code right here. And in our class name, we can import class names. So we'll go to the top and say import class names from class names. And you can see this is just a utility, a simple JavaScript utility for conditionally joining class names together. Pretty common that you'll see this within React. So now what we can do is we can say we always know it's going to be FA solid. So that's similar across the two. And then depending on whether the menu is open, we will either use the chevron up or the chevron down. So we can delete all this. So now rather than conditionally rendering the entire element, we're just conditionally rendering the class names, which is similar to our original implementation. So this is a good one for me to pause on and kind of show you what React is doing for you versus what you'd have to do in a vanilla app. So if you remember, so this is just the menu, and if you remember in our vanilla refactor, or actually let's go to the live TS refactors, the latest one we did, and we go to JS and look at the view. And then let's go to the event listeners where we binded the click on the menu. So this first one is where we're binding the click event on the menu button. And that, let me just do this side by side so that you can see it better. So here's our React on the right, and then vanilla is going to be on the left. So vanilla React, and you can see that, let me zoom out just a little bit. Here's our actions button, and here is our click listener on that button. Then here's the state that controls whether it's open or closed. Now that right there is the same as registering an event listener on the button over here in the view. And then we're calling the toggle menu class, which is down here somewhere. In the toggle menu class is going to select the items in the button and toggle some styles in a border, and then figure out which icon to throw on that. And that is being implemented right here where we're deciding which icon to put, and then whether to show it as open or closed. Then furthermore, when we come down here to the menu being open or closed, here we're conditionally rendering the menu items based on whether it's open. And you can see we have to implement this whole toggle menu and entire close menu to do that, when it's pretty easy to just say like, hey, if that state is true, then render it, otherwise don't. So that's just kind of how we can simplify our lives a little bit. And then finally, we have the action handlers, where we register something that happens when the game resets or there's a new round. And you can see that we will register that on the game reset right here. So that's what we're doing with these on-click listeners. So just kind of a before and after look to see how we're translating things. So at this point, we can come back to our game and we can open and close the menu. And if we click one of these, we'll get something printed to the console telling us which one was clicked. Now we haven't actually handled those events yet, but we will do those shortly. At this point, our app.tsx is pretty much done. You could of course refactor this even a little more and add more components to clean this up, but this is pretty readable at this point, and I don't really want to try to go any further because there's no reason to. So now we need to add the concept of state to our application. And if you remember from the TS refactor, we had this entire store class, which was responsible for, at the very bottom, basically saving our state to local storage and then dispatching an event that said, hey, this state has actually changed. And then the app.ts was listening for that event here. And when it heard that event, it would re-render the view with the new state. Now, this whole process is totally native to React. It is, and if you think about it, what this is really doing is the view is reacting to a state change and re-rendering something. So the pattern that we've used here is a very simplified, oversimplified version of what React is doing and what the purpose of React is. We just had to do it in a much more indirect, imperative fashion rather than the declarative fashion that we're doing it in by just, saying like, hey, if this state exists, like if show modal is true, render the modal. We really don't need to do anything more complex than that. But because we're using React now, just because we're using React does not mean that our state is going to like change its shape or anything. We're still tracking the same fundamental types as defined here. So all we really need to do is redefine a useState hook that will keep track of that game state in the main app, and then we'll read that state in our JSX to conditionally render things and make things happen and make it interactive. Since all of the state works together and none of it's like isolated from one another, it makes sense that we would throw this in a single state variable. So we're going to call it state and then just use the convention for a useState hook. And we'll import that to React. And we of course need an initial state that we'll pass here. If you remember from the original, so let's go back to the store, the initial state that we passed was this right here. So what we can do is just copy this object and paste it into the default, or basically the function parameter is going to be the default state. Now, because we're passing this object shape to the useState hook, useState is going to use TypeScript generics to infer the type of state. And if you hover over state, it's going to give you that object shape. So we could explicitly define that right here and put it in the generic and define the type of state that we're dealing with, but it's just easier to let it infer that. And so now we have a strongly typed state object. Now this is where things get interesting. So we have this state object, and if you remember from store, we are just mutating this state or changing it in a couple of places. So when a player moves, we are pushing a move to the current game moves array. And when we reset the game, we are pushing current round games to the history. And then when we do a new round, we're pushing to the all games array. So those are really the only places that we're changing the state. And then the rest of it is going to be something called derived state. And that is basically where you are constructing you're constructing a set of information that you have derived from that raw state object. And two good examples of this would be our stats getter and our game getter. And in the previous refactor, that's why I called that derived stats and derived game, is because we're basically, in both of these, we're reading the current raw state, and then we are calculating things and returning that to our application so that it can use that information to do things. So same thing here. We're grabbing the raw state and then calculating all of this stuff. We're calculating if there's a game winner, the current player, and the status of everything. So this is all derived state. And we can actually, what you might be tempted to do is put, derived state and then set derived state in some use state call. But really, you don't need to do that. There's no point in doing that because now you have to keep these two state variables in sync with each other. If you read through the React documentation, it will kind of explain to you why that's a bad idea. All we really need to do, since this is a pure function, is come down here and define our game object, and then we need to make a method to derive that. So let's call it derive game, and then we also need to derive stats, not state, we need stats. So these are two empty functions that we've defined, and here we're going to derive the game, and then stats, we're going to derive stats. Now, of course, we need to pass the state object into each of these, and it's going to yell at us because we haven't defined that as an argument. So all we need to do here is say state, and then we need to define the state shape. Now, this is where we need to start typing it. If we go back to our types.ts that we had defined at the very beginning, we have this game state key that we can use. So we can pass that here as game state, and then import that as a type. We'll also put it right here, so state is game state. And now when we pass this state object into derive game and derive stats, it's going to accept it. And at this point, it's just a copy paste exercise. We'll go back to our store, which was, again, let me remind you, this is from our prior refactor. This is our vanilla application, not our React one. All we need to do is grab from stats, we can copy the return type of stats, and then in our derive stats, we'll just return that. And now we're no longer referencing this .player. That is going to be, we need to define that. So we'll do that up here. So if we go back to store, I think we have a players array, or no, this was in our original app is where we put that. So here's our players config. So let's copy that to the top of our app.tsx file. So there's our players config. And then now we can just grab that from that scope, the global scope here, and map through it. And we have a derived stats object. So before we get any further, let's just console log this. So console log stats, because we've implemented that function. And if you go to the console here and refresh, you'll see that we have printed this here twice. And the reason that it gets printed twice is because we are in strict mode. So if you go back to entry point and see this wrapper right here, when we're in strict mode, React is going to re-render each component 2 times, and that is to catch bugs that happen. And I'm not going to go too far into that, but that's why we're getting both of these re-renders, not just one. But anyways, we get the player with stats and this derived object where it says player 1 has 0 wins and player 2 has 0 wins, and there are 0 ties. So just with that information, we can start to populate our React application. So if you go down here to the bottom, you can see that we have this static numbers down here denoting who has what number of wins. So what I'm going to do is grab the stats array, and we know from our config that player 1 is the 0 index and player 2 is the 1 index of that array. So all I'm going to do is interpolate a variable here, and we're going to grab the stats derived state, and we're going to look at the players with stats and grab the first player. And then we're going to print the number of wins in that slot right there. Then we can also throw the number of ties, so stats.ties, and then finally stats.players with stats. We'll grab the first index, which is player 2, and pass in wins right there. So at this point, our player 1 ties and player 2 are getting dynamically populated, and that part is done. So the last thing that we need to do is implement our derive game function right here. And we can do that by another copy paste. So store.ts from our original project, not the React one, we had this getter called game. And that was basically just calculating some things and returning some derived state. So let's paste that in there. We need to reference players from the global scope here. And there you have it. I think that should be pretty much it. We're referencing state right here, and that should work. So now if we print the game, so console log game, and refresh, here's the game. We've got the current player, which is player 1. There are no moves yet, and the status is complete is false. There's a couple things we can do now. Let's get rid of this console log, and let's also get rid of this show modal static variable. So get rid of that. We can grab that from the game derived state now. So instead of show modal, what we can say is, hey, is the game.status complete? And if the status is complete, then we are going to open up the modal, and instead of a static message, we will say game.status. I think we're going to need to do this dynamically. So if there is a winner, we're going to say game.status.winner.name wins. Otherwise, it's going to be a tie. So you can see how we're just reading directly from the state to get what we need, whether we need to render this and open it up, and what the message should be when it happens. But of course, this isn't going to matter if we're not rendering it within the game itself. So now what we can do is read the current state in the current game and figure out which squares need to be populated. So right here, remember, this is where we are looping through all 9 of our squares on the game board and rendering an icon if there's a move in that slot. So what we can do is grab an existing move. So let me show you where this originated from. So if we go to our original project and we go to the app.ts, I believe that's here, you can see that when a player moves, we are checking for an existing move. And if there's an existing move, we are returning because a player can't click that twice. And then we are calling player move. Furthermore, in the view, to figure out, which squares need to have icons, we have this initialize moves method. And what it's doing is it's saying for each square on the game board, see if there's an existing move. And if there is an existing move, then we're going to basically simulate a move and populate that square. So with React, all of this logic is way easier to do. So we can basically just copy that logic right here. And we're not looking at moves. We need to look at the current game, moves. And now the square ID is already a number. So we can just replace this entirely with square ID. So within this map function, we're figuring out if there's an existing move. And if there is an existing move, we're going to render that icon there. Now also remember, on each move, we have the player object available to us. So let's refactor this right here, the class name on this icon. Rather than a static X that is turquoise, we can use class names. So we'll wrap that. And let's just start over here. So it'll be FA solid no matter what. And then we're going to take the existing move, grab the player, and then give it the color class. And then we'll also take the existing move.player.icon class. And that will tell us what color and what icon to render right here if there is an existing move. So now if we go back to our game, the board's going to be empty and we still can't click anything because we haven't listened for that event. So the last thing that we have to do to make this game interactive is add a click listener on this div or this square that we're listening for. So we will attach a callback function to this and we'll say if there's an existing move, we're going to return early. So we're reusing this that we established up here. So if there's an existing move, don't do anything. Otherwise, we need to handle the player move. And this is going to require all the logic for handling a player move. So I'm going to separate this out into a handle player move function. And then I'm going to pass it the square ID of the clicked square. And then I'm going to grab the game.currentPlayer. And then we need to define this function now. So we'll come up here and we'll say function handle player move. It's going to take a square ID, which is a number. And then it will take the, what did we say? The current player. So player is a player. So now what happens is if there's an existing move, return early, otherwise handle the player move. And that's going to be defined in this function right here. So thinking back to our prior game, how did we handle a player move? Well, let's go to the view. This is our original game, not our React app anymore. And looking at the view, this is actually not what we should be looking at because this is all handled by React. We already implemented that. So we need to look at the store. So here's the player move handler. Basically what we're doing is we're getting a copy of state. We are pushing a move to the current game moves, and then we are saving that state. So let's go ahead and just copy that, paste it here, and instead of this.getState, we will just grab, actually let's comment this out for just a second. When a player moves, we know that we need to set the state. So let's call set state. And to get the prior state that we need to deal with, we can pass a callback. And this previous will represent the prior state from the prior render's snapshot. So we can access that here. So if we wanted to now place this logic in the set state callback and uncomment it, we can do a structured clone of the previous state right here. Then we can push something to the current game moves, and then instead of saving state, we will just return the state clone from this set state callback. And then the only thing we update here is we're grabbing this from the argument, so player goes directly here. And then what's it complaining about? This argument is not assignable to parameter of type never. And it's saying that current game moves is of type never array. And that's because we did not explicitly type this as a game move. So now we'll come through and actually type this out a little bit. And if we wanted to, what we could do is just cast this. We can say as game state. And game state is from our types.ts right here. So we can cast that to a game state object, and that's going to fix this because now it knows that the current game moves is a move array. You could either do that, or a better way to do it is just say use state is of type game state. And now that will explicitly say like, hey, the object I'm assigning here is of type game state. So now if we handle the player move, we should start to see some interactivity here. So you can see that our app is starting to work and it detects a player win. Now if we click play again, it's not going to do anything. And that's because we haven't set an event listener on the modal. So if we command click the modal to open that file, you can see that we're going to need an on-click handler. And that's going to happen when the user clicks play again. So on click, and then we'll pass it that on click handler, which is going to be in props. So this is really just a way of us to basically tell the outside world that's consuming this modal component, hey, there's an event and it's an on click event. That means that the user wants to play again. So now we'll come down here and we'll say on click, and we need to do something to close the modal and update the state. So in this case, we need to reset the game. So reset game, but the problem is we don't have this implemented yet. So similar to how we implemented the handle player move, we will also say reset game. Oops. And now this is going to be a function that we'll call when that modal is clicked. So similar to how we are just calling set state and using the previous state to find our next state, we can do that here in reset game. So set state, we'll grab the previous state, and now we have to do something with that previous state and derive something and return the new state that we want the game to be in. Once again, we have already implemented this in our prior refactor. So let's go back to Store.js, which is where we implemented this. And you can see that we have a reset method, and then we have a new round method. We can pretty much combine these into the same method and just have like a Boolean check to see whether it's a reset or new round. So let's first copy over the reset. So we'll paste that in, and instead of get state, we're just going to pass the previous right here. And now what we're going to do is we're going to read from the game, which is our derived state, and we're going to destructure the status and the moves from there. And then finally, we'll return the state clone, which will set that new state for us. Now, like I said, in our original, we had a reset and a new round. So all we have to do is conditionally, let's just add a prop, or not a prop, but a parameter up here and say, is this a new round? And have that as a Boolean. So if we come down here to this reset game, we're going to say that's false. It is not a new round, it's just a game reset. And then if you remember from our menu, we have this on action. So what we can say here is we want to reset the game, and then to detect whether this is a new round or not, we'll just say, does the action equal new round? And if that evaluates to true, then we have reset the game. Otherwise, it'll evaluate to false, and that'll just be a plain old reset. So we've hooked up this listener. We just have to implement that, have to actually use this variable to figure out what to do. So all we need to do is come down here after we've reset the current game moves, and we'll say if this is a new round, so is new round, we also want to push to the history. So we'll say stateclone.history and then all games, and then we'll basically just push and spread the state clone .history.current round games. And then we will set that current round games equal to an empty array. So if there's a new round, we're also going to reset that. So at this point, we've got the reset game completed, and I think this is the majority of the logic. So let's go try our game out. So it detects a win, and if we click play again, it closes things, everything resets, and down here player 1 has 1 win. Let's get player 2 to win 1. So player 2 wins, we play again, player 2 has 1 win. Let's click a square, reset that, it seems to work. Let's go ahead and reset the scoreboard down here, and that seems to work as well. So I think we're pretty much done. Let me just kind of pause the video here and go through and see if there's any cleanup that we need to do, and then we'll be on our way. Okay, so there's actually one big thing that I forgot to come back to, and that is local storage. At the moment, we're not persisting this game across browser refreshes. So let me collapse some things. We'll collapse the players, derive game, and derive stats. We will collapse reset game and handle player move just to hide them from our view. And you can see with our use state hook, this is where we're storing the state of the game. So if we were to play a couple moves and then refresh this browser, it's going to basically reset everything because we're not storing this to local storage any longer. And then furthermore, I realized that this turn indicator is not implemented. So let's go ahead and do that. We'll get rid of these data IDs because we don't need those anymore. And then this becomes pretty easy. So we just add class names around this. So FA solid, and then we will just figure out whose turn it is by saying the game.currentPlayer.color class, game.currentPlayer.icon class, save that. And so now this will be dynamic. And then finally, we need to just replace this right here with the game.currentPlayer.name. So this should make the color, the icon, and the name dynamic. Let's make sure that that's correct. Looks like everything's working except for that part because we have this as a static style. I think maybe an easier way to do this is just remove this class name altogether, remove that from there, and then use the entire div to specify the color. So we'll say game.currentPlayer.color class is going to apply to the entire div, which will style its child elements. And then we're toggling on the icon. So player 1, player 2, player 1, and seems to be working now. And once again, the last thing is local storage. And this is something that I'm not going to spend a ton of time on the implementation to, but there is a way that you can extract the local storage function to a React hook. So we can basically make a replica of use state, but instead of just using state, it will also keep it in sync with local storage. And in that manner, we can basically have the same interface while getting that additional functionality. So just so that we're not getting into crazy detail or anything, we already do that in these videos. I'm going to go into source and make a hook called useLocalStorage.ts. This is a React hook. You can learn more about this if you are in the React docs and go to the beta docs, the new ones. And then you can go to, should be some hooks, a hooks reference somewhere. Let's go to the reference. So you've got the built-in React hooks. I don't know if it does say anything about like custom hooks and how you would do that. Oh, here, reusing logic with custom hooks. This is a good place to check out what I'm about to do and understand why we would do this. But I'm just going to copy paste everything in here to this file. This is a use local storage hook. And basically what we're doing is we are adopting the same interface as the use state, except we are also keeping it in sync with local storage. And you'll see right here, this is where we're like setting a value to local storage. This is where we are getting the value from local storage. And then in the parameters, we'll pass the key that we'll use to track that in local storage. So I've documented this a little bit. You can read through it on your own time. It's not necessarily super important to understand all the internals here. I'll also note that I've added this effect right here that basically keeps track of other tabs that change. So if you were, let me close some things out. And if you went back to our original implementation, app.ts, this is not the React app, this is the prior videos. You can see that we're listening for the state change. This has pretty much become irrelevant now that we're using React because that is kind of built into the paradigm of React. But we also have this where we're listening to the local storage of another tab and re-rendering the view if that changes. So I've created this effect here which does the same thing, and it will update this state variable every time another tab changes its state. So I will close this and you'll see how easy this is. We'll go back to our app.tsx and we'll just comment out this original state. And all we need to do, we can name it the same thing. So set state, state, and set state. And now instead of use state, we're going to use local storage and import that. Now it's going to ask us for a key. So we'll say game state key. And then it will ask us for our initial value, which is going to be this right here. The same thing that we passed earlier. So we'll uncomment that. So you're going to see how quick and easy this is to update. So remember, if we go to our React game, play some moves and refresh, not going to work. But all we have to do is replace use state with use local storage and import that from our file. And then we need to give it a game state key. That's just the key that will be used in local storage as that first argument. And then our default value is the second. And that should do it. That will keep the state in sync with local storage, and we don't even have to think about it. So we can play the game, refresh, and it will find the state that we're in after a refresh. You can also duplicate the tab, play something over here, and then that's going to sync up over on this side and vice versa. So now that we've got it synced up with a local storage, I think we have replicated that original application in full. So the last part of this is just going to be some cleanup and making things easier to kind of find and read through. So let's go through and look for any like data IDs. We don't need any of these because that was a paradigm from the original implementation where we needed a stable way to select a DOM element. So we'll get rid of all those. Let's go through our components. Should be okay there on the menu. No data IDs there, and we're good. And then furthermore, we can just extract some of these things out. So let's make a file called utils.ts. This will just be some utility functions. And if you remember, we have this derive game and derive stats, and then we also have the players up here outside of our component itself. So we can take all of this stuff. You could leave it here. There's no problem with that either. But I can throw all that into a utils file, and then we can export them from it. Okay, and then we just need to import a few types from the types file. So we'll import the player and then the game state, and that should satisfy these functions. So those are now isolated to the utils file, and then we of course need to import them. So command period to import from utils. Do that again here, and you can see we've got that import, and that should work. Okay, so that kind of cleans up our app file. We no longer need use state because we're doing the use local storage hook, which uses state under the hood. So we'll expand this out, and this is pretty much the final game. Once again, you can find all of this code in the repository I've left in the video description. Be sure to look at the TypeScript branch to find this exact implementation I just did. There's also a non-TypeScript version of this same app. So now that we're done, we can close out this developer server, the Webpack dev server. And a good thing to do is always to just check to make sure that it builds correctly. So we have these build scripts, and let's just run yarn build. And what this will do is basically check all your types, type checking, compile everything, bundle it up, and output it to the public directory with bundle.js. And we can also try the build prod to make sure that it does its optimizations okay and it doesn't complain about anything. So there you go. And then finally, we've got live server running on port 5500 already. And since we just built this app, it's totally static, and you can actually view this directly from the public directory rather than using the Webpack dev server. So you can think of it as Webpack came in, did its job, compiled everything, transpiled everything, and gave us one nice clean bundle output, and now we're just ready to go. We've got what we need, and the browser knows how to load the app. So let's go back to the browser, and we'll go to localhost 5500. close everything out. And I know we've got a lot of folders here, but let's go to the live React refactor. And then if we click public, it should give us the game, and we should be able to use it just like we were with the dev server. So we can reset, we can get a new round going and just play the game. So just wanted to show you that's a good thing to do. Check your build, make sure it works. And then you could really you could deploy this game right here over any CDN because it's static assets. So you could put it on Cloudflare, whatever you want, and it can be served to your users, throw it on GitHub pages, what have you. So hopefully this was an educational video that hopefully you enjoyed seeing how we can go from a vanilla JavaScript application and port that over to React and kind of see the benefits of using React. It makes a lot of our code a lot simpler. We basically went from, let's just kind of recap, we went from this live TS refactor where we had an app. Let's just close all this out. You can just scroll through. This is our main app file where we're registering all the event listeners, controlling everything. This is our state where we have our store class. And this is our view where we are handling selecting all the elements up here. We are rendering here. So this is basically what React is doing for us. And then we're binding event listeners, got all of our helper methods here. And all of this stuff, it's pretty verbose what we've had to write here. We even had the delegate method so that we could figure out which square was clicked, and that was pretty confusing. So we've gone from this over to our React application, which, as you can tell, if we go to app.tsx, it's pretty concise what we've got here. We don't have any delegate methods. We can just handle everything basically right here with some event handlers. We've got a hook that helps us deal with local storage. And then we have our components split out by their separate concerns, also with their separate CSS. So that's just a much cleaner way to write an application, and it's a lot easier to extend into the future. Congratulations! Most people who start a video like this never complete it. I have the YouTube stats to prove this. I think it's over like 90%. So if you are still here, congratulations. Thanks for sticking around, and I hope you learned a ton from this course. A lot of times when I complete a course like this, I'll get questions of where do I go next? And I wanted to take this time to just talk a little bit about my website, fullstackfoundations.com. It's a brand new site that I'm just starting out to try to get a lot of these courses and lessons that I have here on this YouTube channel more organized so that you can kind of navigate full stack web development. And you might see it as a little bit ironic because so far I have only covered front end stuff. And I had previously done a series called the Full Stack Roadmap. And so the fullstackfoundations.com website is a continuation of that. I really want to eventually get to these back-end concepts, so be sure to check that out. Subscribe to my email list. It's on the site somewhere. You can find it to be notified when I release those tutorials. And I really want to make this site something to be a resource that helps you really learn those foundational concepts so that you're not just learning how to make something work, you're also learning why it works, how it works, and how to become a stronger engineer overall. So with that, I will leave that in the description. I'll leave the link there. And as always, really helps me out if you subscribe to the channel. If you've watched this entire course and have not subscribed yet, what are you doing? Go ahead and subscribe, give this video a like, and I will see you in the next course.